Welcome back, Gophers.
Hello.
Hey.
So we had an amazing day of content yesterday. We've got one more today and another tomorrow. I'm really excited about some of the speakers that we have coming up.
Yeah, RustConf starts Saturday?
Yeah, we're doing it in a parallel hallway track here.
Parallel universe.
You guys, you know.
We're going to drive Johnny up a wall here.
So we're here in the frozen tundra.
Yeah. It's a whopping 0 degrees in here or something.
And I think everybody layered down, surprisingly. I'm not really sure that was smart, but...
Well, you look like you layered up a bit. That looks like
No, that hoodie is definitely thicker than this is.
Okay,
this is pretty light.
Well, I donned my slightly lighter gray today for all of you to cheer it up, you know? To really add some cheer to the scene.
Aaron, add some color. Yeah, I've got some color.
Yeah, there's a little bit of white in here, you know. I got a white undershirt.
Yeah,
like,
wait till tomorrow.
It's like the whole SNL Debbie Downer bit. You know? Like, oh, here we are. It's like, do you hear about the new strain of flesh-eating bacteria?
Well, Johnny said it. I got some real color for you guys tomorrow. I got blue and a little bit of red in there. So just get ready.
Can't wait. Can't wait.
I mean, just be on the edge of your seat. I know I am. Yeah.
So I just want to take a moment to thank all of the speakers from yesterday. All of this content is so great. It means the world to me that a lot of the speakers were able to fly out. Unfortunately, some weren't, but still, every talk from yesterday was just incredible. And we still have 2 more days. Thanks so much to all of our sponsors for making this happen. Please go check out their virtual meeting sessions that are happening throughout the conference. If you want to attend, you do need to register for that. You can do that on the GopherCon homepage. While you're there, go check out the sponsor page themselves. Many of the sponsors are doing little events and giveaways and things like that. So go do that. Yep. If you're new, you weren't here yesterday. Most of us are all chatting on Discord, discord.gophercon.com.
Yeah. There's also GopherTown. Wait, did you mention GopherTown already?
I did not.
No, you did not mention GopherTown. So GopherTown, I think every time I think about the concept, I'm like, wow, this is such a silly but weird but cute thing. Basically, you just walk around.
Somewhat nostalgic for some of us.
I know, right? Yeah, just walking around like a little avatar, and you can connect with other people, and all of a sudden your video feeds come up, and you can play games. I mean, it's really such a fun implementation, and I think they're using Go for some of that stuff too. If they're not, they should be. In any case, GopherTown is another spot you can go hang out, and obviously we have the awesome channels that have popped up over on Discord, and one of my personal favorites remains the Dad Jokes channel, and really I really appreciate having woken up this morning. The spinning of the Earth. Seeing a whole spin of the Earth. It makes my day.
I think we got dad jokes now from all the populated continents.
We got some premium content in there, yeah, and that whole Earth spinning joke comes from Theo. So thank you, Theo. I've been keeping my eye on some of your good stuff.
It's definitely the Peanut Gallery channel too.
In the Peanut Gallery channel, where you get to heckle us, especially Aaron for his colorful choices of.
Hello, I'm here. I'm here for all of you.
Exactly. So yeah, get involved, make new friends, and if there's a channel that doesn't exist and you'd like to see it, request one. We'll make it happen.
And in fact, dad jokes came from popular requests in Peanut Gallery. We got mainframes. What else? We got a couple others.
We got high frequency trading.
Yep. We got HFT from there. Yep. No Rust channel. Just putting it out there right now.
No, there will not be a Rust
channel.
Oh,
there will be.
There will be.
As soon as our next talk starts, there's going to be a Rust channel.
All right.
Oh, man.
Yeah. No, Peanut Gallery has been great fun. I think we love that feedback from all of you. Just the talks are amazing. That feedback is amazing. GopherTown, that collaboration and that connection has been really amazing too.
And if you don't know where all these links and things are, GopherCon.com on the homepage. There's a section what every Gopher needs to know. That'll give you the links to all the things.
So I think it's time we kick this day off. Who do we have first?
We've got Natalie Pistunovich. I apologize. I think I got that right. I consulted many experts for how to pronounce that last name. Apologize if I didn't get it right. Natalie is a lead developer advocate at Spaink. She is a Google developer expert for Go, OpenAI ambassador. She's done tons of public speaking. I didn't know this. She's a sailor, apparently.
What?
I did not know that.
Yeah, I mean, that's on the screen here. That's amazing. She organizes tech conferences like B-Sides Berlin, Cloud9, that's N-E-I-N, like the German, no. Pretty clever. That could go in dad jokes too.
Yes.
Hey AI, GopherCon Europe. She's extremely accomplished here. I could go on and on. There's a long list on this screen.
Go Time panelist.
Go Time panelist. We saw her yesterday. Yeah, she's everywhere. If you've been in the Go community for more than a second, you've seen her out there doing everything. So her talk is today on AI-driven development in Go. I'm really excited for this talk. I hope you all enjoy it as well. So Natalie, go ahead, take it away.
Hi everyone. I'm here to talk about AI-driven development in Go. In the past, I talked about Go with DevOps and machine learning and even mobile. And last year, I gave a workshop here at GopherCon about building an end-to-end machine learning platform with Go. And in the previous year, we talked about the importance of beginners in the Go community. If you'll try really hard, you will find a regular Go talk of mine, but that's not our plan for today. So my name is Natalie, and this is a picture that I took in the last vacation that I got to do 2 years ago. And it was a great decision because it was super nice and the memories keep me going through the last 2 years. Another good decision that I made was take a job that required me to use Go back in 2014. A recent decision that I took, and I hope that will turn out to be good, is to dive into the world of AI engines. And if you want to hear more about decisions and thoughts and so on, join me in the Go Time podcast or in the Berlin user group of Go or at GopherCon Europe. Some other hats that I wear, in addition to my job as a lead developer advocate at Spaink, is being a Google developer expert for Go, an OpenAI developer ambassador, and the organizer of all sorts of developer events. Our plan for today is to talk a little bit about the history of AI, then about AI-generated code and Go, and what does this mean for us as Gophers. Let's hop right into the history of artificial intelligence. So, classical philosophers like René Descartes and Galileo Galilei regarded thought, taste, odors, and colors as symbolic representations, and perception as an internal process. Then, in the summer of 1956, a group of researchers gathered together for the Dartmouth Summer Research Project on the topic of artificial intelligence, and this is considered to be the birth of AI as a research field. In the following years, access to digital computers became possible, and scientists instinctively recognized that a machine that could manipulate numbers could probably manipulate symbols as well. And as we said, manipulating symbols can be the essence of the human thought. And in the following years, indeed, computers were solving algebra problems, proving theorems in geometry, and were even learning to speak English. And researchers were optimistic, and they predicted that a fully intelligent machine is just a few years away. And government agencies like DARPA were pouring money into the field of AI. But in the 70s, those researchers and their optimism proved to be a little bit too optimistic for the difficulty of the problems. In addition, public criticism about artificial intelligence went up and the government funding stopped. This is called the first AI winter. In the 80s, AI was proven useful again, this time used as narrow AI, so for a specific domain. And specifically, this means AI-driven programs that were called expert systems. They were implemented in the different companies, and they were answering questions and solving problems using their internal knowledge base, and this was saving the industry a lot of money. In addition, Japan launched the 5th generation computer, which is a sort of a natural language processing machine, and following them, so did the UK and the US. Back came the AI funding. Progress in the field of neural networks and semiconductors enabled the development of practical artificial neural network technology. The industry was booming again. But The second AI winter came in the end of the 80s, specifically in 1987. Apple and IBM's desktops became more powerful than the expensive, dedicated AI hardware. This led to the collapse of the industry of the chips that are designed specifically for AI. The expert systems became too expensive to maintain, and DARPA once again stopped the funding. Then, in the 90s, the computational power was strong enough and cheap enough. AI was used to solve specific rather than general problems, and AI researchers began to develop and use sophisticated mathematical tools more than they ever had in the past. Algorithms developed by AI researchers were used in the industry, and in 1997, Deep Blue, the computer, beat Garry Kasparov in a chess game. And today, we are again in the era of the artificial general intelligence. And what's different is that the industry problems keep being solved by AI. This time, we also have big data, so a lot of data in each company. There is cheap and fast computers, and the ML techniques that are in place are more advanced now. The different industries have a lot more data about their users, and they increasingly use AI for their business logic. Now let's talk a little bit about the history of AI models. So in 2010, IBM DeepMind was founded. And in 2014, they joined forces with Google to accelerate their work while continuing to set their own research agenda. Some of the big achievements was to manage Google's data center energy consumption and AlphaFold, a system which accurately predicts the shapes of proteins. In 2015, OpenAI was founded as an AI research and deployment company with a mission to ensure that artificial general intelligence benefits all of humanity. And in 2017, Google AI was founded as a division of Google with a mission to conduct research that advances the state-of-the-art work in the field, applying AI to products and to new domains. Basically, develop tools to ensure that everyone can use and access AI. In 2018, GPT-1 was released. That stands for Generative Pre-trained Transformer, and this is a language model that uses deep learning to produce human-like text. Until now, most of the natural language processing models were trained specifically on a particular task. GPT-1, trained on 117 million parameters, performed better than most of the supervised models that were trained to solve a specific task. And not just that, it needed very few to no examples to get the context and still outperformed the models that were trained to solve a specific task. Next, in the following year, came GPT-2, which is trained on 1.5 billion parameters. And in June 2020, GPT-3 was released. This model was trained on 175 billion parameters. You see the hop between each version of the model. That's 2 orders of magnitude. And of course, GPT-3 has a great zero-shot or few-shot learning performance. So where is AI today? Well, let's think quickly on what does today mean. Are we all aware that 2050 is closer than 1990? Okay, so let's minimize everything and focus on the last 2 years. We said that last year GPT-3 was released with 175 billion parameters, and this year Switch Transformer by Google Brain was open sourced. This model scales up to 1.6 trillion parameters, but the model release does not mean you can just go ahead and use it. You do need some hardware. In addition, Wudao 2.0 was released by the Beijing Academy of Artificial Intelligence. Wudao 2.0 is 10 times larger than OpenAI's GPT-3, which is trained on 175 billion parameters. It also has 150 billion parameters more than Google's Switch Transformer. But I don't know anyone who uses it. Looks like they have 12 partners at the moment in the forums of apps that are using this tool. And the most recent tool that was released is the Megatron Turing by the collaboration of NVIDIA with Microsoft, back to the scale of hundreds of billions. Now, here's a nice visual that I got from NVIDIA's developer blog. And here's a Reddit post that nicely puts everything in proportions. Apparently, we jumped from the mole rat brain to the octopus brain. I took the liberty of adding Google's Switch Transformer and Beijing's Academy of Artificial Intelligence Wudao 2.0. Anyone recognizing a hockey stick? For fun, let's add one more number. GPT-4 with 100 trillion parameters. While it has no official release date, the development of it is already in progress. Now, if you ask yourself, how does that compare to a brain size? The cerebral cortex is the outer layer of the largest part of the human brain. Only us mammals have it, and it's in charge of things like attention, perception, awareness, thought, memory, language, and consciousness. Wait, what? GPT-4 has the same number of parameters as our brain? That's pretty mind-blowing, especially given that from all the models that we talked about, OpenAI's GPTs are the ones that are publicly available. Okay, enough nerding out about AI models and numbers. Let's talk how it's relevant for us. The introduction of AI engines introduced a new type of engineering, prompt engineering. Let's see some examples. We will do several demos, and you will probably recognize the different tasks that we'll see here from your everyday developer lives. And let's start with getting acquainted with what we see here, this interface. So the playground is the way you interact with the GPT-3 models, and you can start with choosing an engine. The OpenAI API is powered by a family of models with different capabilities. There is the base series that can understand natural language. Then there is the instruct series that is like the base one, but is better with following instructions. And there is codex that is specializing in translating language to code. So for this example, I'm going to go with the Da Vinci codex. And the parameters that you see here, this one is for creativity. This is for how long the response is. And stop sequence is when do I ask the AI to the engine response to truncate. There are several other parameters, and we can look at that at some other time. The first example is adding a unit test. So the input that I am providing is a part of a library, and this is all the context that the machine has. So it's a snippet of code that begins with package main, and it ends here. And there's also this, which you as a human can parse that this is where the code ends and the instruction begins. But this is all the context that we have given. Now let's click generate and see what happens. Lo and behold, it followed the instructions correctly. So it generated a unit test. It used a function from the right library, and it used the correct syntax, and it also used the correct formatting without getting any context other than what you see here. We will do several demos, and you will probably recognize the different tasks that we'll see here from your everyday developer lives. Next, I will use the AI to help me understand a new code base a little bit better. Let's say that I'm looking at this examples file for the Go client of Prometheus for the first time. I can go and read everything and read the comments and kind of make sense of it, or I can copy that and ask it to explain what do I see here. So the instruction that I'm providing is explain in detail this Go function, and then I'm just pasting a function. And look at that. It explains what it does, and it does explain in detail because this is what I asked. And you can always go back and read a little bit in depth once you have the bigger image, because this is what you got from the previous screen. Let's increase the complexity level and do some bash. So I have a file which I downloaded from Kaggle called spotify.csv. And it has a list of songs that were recently played. It's 4 columns: the user ID, the artist name, the track name, the playlist name. And I can see this is comma separated. So let's say I'm looking for some recommendations of new music to hear. So I can ask it to filter by the playlist name. And because I'm looking for songs for my work playlist, I'm going to search for words like deep focus or some combination of them. And then I want it to print in the specific format of first the playlist name, then the artist name, that's the second column, and then the track name, that's the third column. And I'm only asking for 12 rows, that's enough for me. Bash signature, and I'm starting with awk. Now you see that I already gave you more context that I gave to the computer, and it successfully gave me a command. Let's see if it works. I'm just going to copy paste that. And I have 12 songs. This is printed in the order that I asked it to print. First the playlist, then the artist name, then the song name. And I can see that the playlists were filtered by the word deep, so that is there. And it's not exactly what I had in mind when I was looking for deep focus, but as it happens many times when programming, prompt engineering is not different here, that it did what I asked it to do, not necessarily what I had in mind. The last example would be building a website. So I am asking the following: build my website. So the landing page will have this title, and then I want a button that would email me this email. This is not my email. Please don't use that for contacting me. And I want this specific cat image, and I'm giving a slightly vague instruction that add a list, title of resources with 5 websites of online courses like Coursera. Let's see how well does it perform. So it generated this, and I'm just going to copy paste that into an online IDE. Specifically, I'm trying here with Replit, and I already have a new JavaScript project set up. I'm just copy pasting this into the HTML file and running it. And look at that. This is a title that I asked. This is the email. You can see in the bottom left that it will mail to the right email that I asked. And this is the image that I asked it to insert. And here is a list of 5 websites of online courses. So it did exactly as I asked it. And some things I could have improved, maybe give it in the instruction of not just websites, but maybe the URL of the website, right? Because you can interpret, add a list of websites with either adding their names or adding the URLs. And this is a small example of what prompt engineering is. You do use English because this is a natural language model, but this is also a model that was trained on a specific subset of the internet. So it has a finite world of context. It does not have your English level skills, whether you are native or not like me. And you have to find the right language to speak with it. And it doesn't have to be English. The model supports different languages as well. Some languages better, some languages worse. Now let's talk about AI-generated code with Go. Codex supports multiple programming languages. Python is the one it performs the best in, but Go is high up this list. And when we're looking at a small code snippet, it's kind of hard to say if a human generated it or if machine generated it. And I'm not just talking about a hello world, I'm talking about a complex command. For example, here's a name of a client. Please use it correctly to utilize its functionality. Implement 1, 2, and 3. Now, as a developer, I can say that using a new library will take some time for me. I need to figure out how does it do things, how do I do things with it, see some examples, browse the docs, but not Codex. Codex just says, not a problem, and goes ahead and imports a library that I mentioned, not even by the name, but it's importing the right one. And it goes ahead and imports the library that I mentioned, not by the exact name. Still, it knows exactly what to import. Then it imports the additional required libraries, and it writes the code correctly with these libraries. It does exactly all the steps that I asked it to do, and it even documents the code. All that, and the code is written the Go way. If I told you that I wrote this code, you would believe me. But this is not always the case, especially when we're talking about generating a lot of code. The reason for that is that code that is machine generated in large amounts can look like it's machine generated. And that can be a problem because it can land us in the uncanny valley of code. The uncanny valley is a concept that was identified by the robotics professor Masahiro Mori in 1970. This is the hypothesized relation between an object's degree of resemblance to a human being and the emotional response to the object. Basically, if we're looking at this graph, on the left there is a robot that looks very much like a robot, and it does things that are more efficient for us, and we're okay about that. Then, if you go right on the graph and you see something like a humanoid robot, so it looks a bit more like a human, that's even cuter, so we like this a little more. And when it goes to this creepiness area, where it looks like a robot, but it also looks like a human, and you're not sure how you feel about that, this is the uncanny valley. And when you pass that, when it's so resembling to a human, you cannot tell anymore if this is a human or a robot, you're feeling wonderful about this again. And this is not applying only to robots, this is also how you feel about code. Luckily, the Go code that we all know and love is already auto-generated with GoFunt. So we're actually expecting it to be rather robotic. So even if a machine will generate it in large amounts, we will probably not get feeling uncomfortable about that. Some additional good things about Go is that there is one clear way of doing things. There's no chance to get things in different paradigms, which will make it unfitting with different snippets of the code. And with the inevitably increasing automation, you do find yourself that you have to read even more code just because more of it is auto-generated. So as we, the developers, need to parse things more quickly and we become this little compilers, we really get to benefit Go's simplicity because it provides readability and it's always the same everywhere. And GoFunt parses the code to a syntax tree and stores it instead of storing the source code. And because all Go code has a similar outputter, another machine can have easier time creating this output. Cool. What's next for Gophers? Don't put down your keyboard and leave just yet. Instead, hop on the early train and embrace the automation. What's there to embrace? Well, good thing you asked. There's a lot to embrace. I will be skipping the examples because I'm sure you saw so many of them online already. And if you want to see more, you can always find them online, even if you go to the GitHub Copilot page itself. So the very first thing you can do is to automate the boring and repetitive part. Things like writing tests for the different types or even generics. Check out the agenda for more talks about this topic. You can get inspired by what the computer is proposing for you to write when you write a comment, for example, and it auto-completes a code block. So if you're not sure what to write, you can have a good start. If you're not sure about what you started with, you can always ask it for more proposals or consider alternatives before getting to the part of the pull request review by your peers. You can automate comments. Now, this point easily deserves a whole talk, but instead I will settle for showing you some interest answers that I got when asking about this point on Twitter. People don't document enough, not a surprise, and this slows us all down, also not a surprise. But I am looking forward to how AI engines that specialize in code will help us solve this and be more productive. One more benefit for Gophers is that AI can help you understand any code base. Yes, Go codebase is written the same practically everywhere, and that's great. What happens if you need to interface with some other team? Front-end, mobile SDKs, even some of the infrastructure content. You can use the AI to explain code to you. Now, you ask, what is my prediction? AI-generated code will change software as we know it. Backend, front-end, mobile, game development, QA. We saw that the languages that are dominant in these fields are already supported by codecs. Data engineering is an interesting point. I'm not sure. More than instructions are still needed, but the execution is getting increasingly more automated. We can summarize this point with saying that AI will change development as we know it. Another prediction is that code generation will become part of our development flow. In the same way that the IDE already makes your development faster by showing things like the function signature and other useful information, all the benefits of AI-driven development that we talked about will become part of your developer flow. Everything will keep getting more AI-driven. We said how already a lot more data is being collected and used for recommendations, personalization, and so on. And all fields will keep being more AI-driven or data-driven or ML-driven, call it how you will. I mean, have you heard of legal tech? AI won't skip any field. Okay, so everyone has a lot of data. The code that is processing it is getting augmented. What about how it runs? Sure, there are cloud solutions like the Azure OpenAI service, but as with any cloud solution, it's not always the right choice. So everyone has a lot of data, and the code that is processing it is already getting augmented. What about how it runs? Well, infrastructure and monitoring already have a lot of automation in place. This will sure not go away, but you cannot just ask a model to autocomplete configurations for you. What I can imagine happening is a more efficient set of default values based on your use case, but not something that is production level ready, at least not in the foreseeable future. It's like these codex examples that show us how an auto-generated SSH key is part of code that it autocompletes. Yes, it's in the right format. No, it's not usable. So here is where MLOps or AIOps come into play. This is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. If you attended my workshop here last year, where we built this AI/ML infrastructure end-to-end using Go, or watched a talk of mine on the topic, you probably remember this paper and specifically this diagram from it. See that black cube in the middle? This is the code for the machine learning model itself. It accounts for about 5% of the code of the system. The rest of the code is a supporting infrastructure. And it's an increasing point of interest. Although the name split between AI and ML migrates here as well, and looks like it depends where you come from. Sure, there are solutions to help with that, like the Azure OpenAI cloud, but as with cloud, it's not always the solution, and hey, someone needs to maintain that cloud too. Security is another interesting point, and my personal prediction is that it will be similar to how it went in chess. What happened in chess is that the computer not necessarily became smarter than us, it just became powerful enough to be able to try all the different combinations in a very short time. So the machine was strong enough, powerful enough, cheap enough, and fast enough to do all the things that we cannot do because our computational power in the brain is limited. And you cannot necessarily say that the computer is smarter than us in chess, but they do beat us in chess. And I think this will be similar in this field. Eventually, it will be able to just try more things faster. Maybe all that's left for hackers is just social engineering, but that's for another conference. So what can you do today? Apply for the access to the different AI engines. Join the waitlists. There is the Codex waitlist for OpenAI. There is the general waitlist for OpenAI, which gives you access to GPT-3. And you can also, if you didn't get yet the Copilot access on GitHub, you can also apply for that. And you can go to AI21 for accessing a model that is a natural language model, but not focused on computing. As I mentioned, the other models from this talk are not yet publicly available. Next time you're looking for something to hack on, build and deploy a basic end-to-end machine learning infrastructure. You can find talks that I gave about this, and it will give you an example of how does a bare bone infrastructure look like end to end. Once you have that done, you can always add a lot more different features and components on it. There are multiple tutorials online about this, and there's even a workshop this year by Daniel. Integrate automation in your flow. VS Code already has GitHub's Copilot. This will keep improving in its performance, and a lot more extensions will come. And be excellent to each other. Your fellow human developers will stick around for a while. And that's it. We talked today about a brief history of AI and the current state of things. We talked about AI-generated code in Go and how it's designed with automation in mind and how it benefits us. And we talked about what's next for us Gophers. TLDR, automate more. Thanks for coming to this talk. I hope this taught you something new. I hope this inspired you to try something new. And I hope that next year we get to meet in person. And I would love to hear about all the interesting things that you got to do with code and AI. Thank you.
Thanks so much for a fascinating talk, Natalie. This is actually something I've been playing with a lot more recently.
You know, I'm still stuck on how much I don't know about Natalie. You know, like she's like a sailor and stuff. She's deep into this AI stuff. We've been like Go Time, you know, like co-hosts for like what feels like years now. And I'm like, Sailor Natalie?
Every day you see a new side.
I know. Yep. I'm like, this is and man. Anyways, this is obviously she's multi-talented and a great individual. Yeah, and really interesting stuff. I'm like, I keep thinking that okay, AI is going to evolve to the point where we are going to have an iRobot kind of situation in our hands, and we won't have Will Smith to save us.
Who's going to step up?
Who's going to step up?
It's going to be Aaron. He's going to kill all of the robots with this loud shirt.
They can't handle it. No one's going to write the AI to be able to handle this.
A couple of housekeeping notes. First, subscribe to the YouTube channel. We still haven't hit 100K. I'm not mad. I'm just disappointed.
Start paying people, man. $1 per subscriber? How much do you want this?
Yeah,
how much do you want
this?
Nah, man. I just wear the cool t-shirts. That's all I do.
So later today, we also have an AMA coming up with the Go team on Go Time. It's kind of a. If you have questions for the Go team, there is a Go team AMA channel in Discord underneath the speakers section. Go drop your questions there, and the Go Time team will hopefully get to as many of them as possible. We also have some VMSs coming up. I'm going to steal your job here.
Yeah, I mean, everybody, let's do this. Erik's the VMS guy for the day, so let's focus in.
I can't have you isolated on camera for too long.
No, it's the camera, the sensor, and the camera can't handle it.
Yeah.
So we've got a VMS virtual meeting space coming up with CockroachDB. What's in a name? Microsoft's running a Go SDK lab, and then Buff is running open office hours.
You know what you just did, though? You're the VMS announcer for the rest of the day now.
Is that how it happens?
That's how it works.
You were looking for somebody to just pond out. She's like,
no. I love announcing those. You got to bring the energy for them. I love it.
Oh, man.
Yeah. Well, we also have a, let me get this right, creative usage of generics contest submissions. That is a Discord channel now, officially, unofficially, officially. That I guess CrowdStrike created that channel, and now we have people like listing off ideas.
So if you never want to work at CrowdStrike, you should submit.
Well, they did say that does not disqualify you.
That's true. I don't
know.
Yeah,
submission doesn't disqualify you, but you take the risk of winning and then losing.
Yeah, winning and losing a job and gaining a sewage-infested gopher, apparently. I don't know. Yeah, but there's some interesting stuff in there. Obviously, none of them are great ideas, but it's interesting to see, you know, what people can bring to the language with generics in 1.18. So. All right, well, we've got an interview for everybody. We have an interview from Richard Ford, who's the CTO of Praetorian. So this is all about security. We've heard a lot about security so far from yesterday and even a little bit in Natalie's talk. We had Akil yesterday talking about static analysis. A lot of what he was talking about, you know, was increasing the security of your code through static analysis. You know, Natalie touched on it. Security is clearly a really important topic. It always has been, but it's kind of getting a lot more attention these days, I would say. You know, we've got companies out there doing supply chain stuff. We've obviously got the AI. I mean, this is getting more and more important as, you know, software grows and grows in scale and importance, right? So we've got Richard Ford, CTO of Praetorian here, and he's going to talk about all things security. Praetorian is a big player in this space. So let's see if we can bring Richard on. There, hey Richard, welcome.
Morning, Richard.
Hey, good morning. How you doing this morning?
Great, great. So yeah, I mean, you at Praetorian, all of you are really big in this space. So, you know, what can you tell us about some of the stuff you're doing with security?
Yeah, so Praetorian offers a lot of different services in security, a lot of high-end consulting, but we also have products. And it's the products, I think, that right now would be most interesting to the audience. One of the things I wanted to chat a little bit about was some of the work we're doing in Go and Go security, one of our open source tools, GoCart.
Nice, nice. Yeah, I've heard a little bit about GoCart, but have you guys played with it at all? Or
I've not. I saw the announcement, but between stuff going on at work and getting ready for this, it's something I've not played with.
I am curious though, because obviously if this is sort of relying on static analysis, I mean, when I hear static analysis, I always think, okay, code improvement, you know, that kind of thing. You know, Akil's talk yesterday sort of shed light into that. Like, I'm wondering what role static analysis plays, right, in security tooling like this.
And how much of responsibility does it have through the whole pipeline?
Right.
Yeah, that's a really good question. I think static analysis is an important part of security, but it's not the whole story, right? So static analysis tools have sometimes had a bit of a bad name because they are kind of noisy, right? If you've ever run static analysis against your own code, you know what I'm talking about. And so when we set out to build GoCart, what we did is we wanted the quietest tool that only alerted when it matters. Because developers, at the end of the day, you want to be developing. You want to be building that cool service, not thinking just about security, right? So they need to be quiet, and they're a part of the security solution, but very much not the whole story. So, you know, my advice is you need to be using quiet tools in the space built into your deployment pipeline, but there's a lot of other things that you need to do too. Because it's really about finding a holistic solution so that you can get back to doing what you're best at, which is developing great applications.
So what are some other considerations after static analysis? Like we've done the scanning, trying to alert on just the important things so that we don't almost get alert fatigue. What are some considerations beyond that?
Yeah, that's a great question. So I think one of the places where things go wrong for customers all the time is they write something and then the way it gets deployed isn't necessarily what they intended. So you can imagine writing an API endpoint that was not designed to be exposed to the sort of internet, right? It's not supposed to be out there skinny dipping on port 443. It is designed to be behind your application gateway and not directly hittable. Let's say something goes wrong in the way you deploy it, or you change your deployment scripts and you accidentally expose that. What it's about for security is figuring out all those sort of weak things. So you've got to look at how things are getting deployed. One of the things that I encourage customers to do a lot is to look at, you know, managing their attack surface, right? If you ever have done exploration and discovery of what you're exposing in the cloud, it's almost a guarantee that I'm going to find assets that you didn't mean to expose publicly. It could be a Swagger API right, which is not ideal. It's not the end of the world. It could be an open S3 bucket. It could be a service like the one I just mentioned, which is supposed to be sort of firewalled off, but is actually hittable. And so doing that active discovery in real time of what's going up and coming down in your cloud is sort of the missing secret sauce that pulls together with static analysis, because you're going to get a lot of static analysis alerts. You need to prioritize them and do them in the order that has the most impact, and that order is usually how exposed to the internet are they.
Yeah, I mean, this seems like something that's been kind of unsexy for such a long time, but now, I mean, this is crucial stuff, I think, you know. Like,
spoiler alert, it's always an open S3 bucket.
Like, always.
We even have an award for it, don't we? Like negligence awards. Yeah,
there's always a text file in there that's got something, you know, something in it.
My key takeaway here is skinny dipping behind port 443.
Yeah,
I'm going to use that
yeah,
one.
that's great. Yeah.
I wish we had more time to chat. We've got a whole lineup of speakers coming. We appreciate you coming and chatting with us, Richard, so much. Will you be on Discord answering questions, go-kart and security related?
I could be around, and hey, next time in person, right? Looking forward to those days.
Yeah.
Thanks so much, Richard.
Thanks, Richard.
All right, take care. Cheers.
All right, well, is it time for our next talk?
Yes, it is time for our next talk from Mr. Madhav Jivrajani, talking some jibber jabber about the Go scheduler. No, he's not talking jibber jabber. He's talking, you know, he's going on a deep dive, talking about queues, fairness, you know, related to the Go scheduler. We've had some awesome talks about the Go scheduler over the years at GopherCon's past.
Yeah, those are some of like the talks that I really like love, watching people dig into exactly how all of these things work.
Yeah. Indeed, and we're hoping that Madhav's talk is going to add to the pantheon of great content we have in the Go scheduler. So Madhav, it's your show.
Hi, my name is Madhav, and today I'll be talking about queues, fairness, and the Go scheduler as a whole. So a little bit about me before we get started. I work at VMware, where I work on open source Kubernetes full time, because of which I spend most of my time in the community there, working mainly on areas of API machinery, contributor experience, and architecture. Currently, I am also an undergrad at PES University, Bangalore, India. So let's get started. Now, the agenda for today is as follows. We'll start with a little bit of motivation, talking about why we are here and why do we even care about this. Then we'll talk a little bit about the Go scheduler model. We'll talk a little bit about fairness, the design of the Go scheduler, and then actually visualizing what's happening internally by pulling out some metrics and playing around with things. Then we look at one of my favorite topics, which is looking at the fine print of things, that is really going deep and looking at what's happening under the hood there. We'll look at what some of the knobs are that the runtime provides us with that we can play with. And finally, I will leave you with a few references and materials that I found particularly helpful to understand these topics better. So before we get started, a small disclaimer. Everything discussed here is in reference to Go 1.17.2, which was the latest Go version as of this recording. So why are we here and why do we care? We are mainly here because we love Go's concurrency primitives, namely Go routines and channels. Let's talk about Go routines mainly today. So Go routines, it's really helpful to think of them as lightweight threads, which are managed by the Go runtime, and you have a super minimal and easy to use API to work with them, which is namely the keyword Go. So you can do Go func or Go function name or whatever to create a Go routine and run things and utilize concurrency. Now, let's take a small example. Let's say this is our program. We have a main function, and then we create a Go routine to go do something, and we call another function to do another thing. Let's look at this particular code snippet. We have a main function which creates a Go routine, call another function to go do another thing. Now let's actually compile this into a binary called app. Another way to look at this binary is having two logical parts to it. One being our application code itself, and the other being the Go runtime. Now, our application code often calls into the Go runtime to help with things such as creation of Go routines, executing system calls, allocating memory, and so on. So an example of what calling into the runtime looks like is something as follows. When we compile this program, it actually gets compiled. The statement go do something actually gets compiled to a runtime function called newproc, which is responsible for creating a new Go routine. So this is just one small example of what it means for our code to call into the runtime. And then we have our operating system, which is responsible for actually running our code. The runtime is what interacts and interfaces with the operating system to handle things such as creation of threads, actual operating system threads if it needs to, as we will see, and handling memory and so on. Now let's actually run our code. So when we run our code, we have multiple Go routines that might exist at any point of time. But it's also important to remember that these Go routines exist in the user space. Now, subsequently, in the kernel space, you also have OS threads or operating system threads that exist. And then finally, you have the actual hardware on which our code actually runs on. Any actual execution happens through running operating system threads onto hardware. And at most, you can run the number of operating system threads that you can run is equal to the number of hardware cores that you have. So in this case, it's 4. And you can have more number of operating system threads than hardware cores available. And subsequently, you can have more number of Go routines than operating system threads available. Now, how do we get the code inside Go routines to actually run on the hardware? That is, we need some way to map Go routines to operating system threads so that they can be run on our hardware. Now, this is what is known as user space scheduling. There are multiple ways to do user space scheduling, but we will look at the one which Go follows. There is another excellent talk by Kavya Joshi on the Go scheduler, which discusses three ways to do user space scheduling in great detail, along with pros and cons. So I'd highly recommend checking that out as well. I've linked that talk towards the end. So what Go follows is something known as NM scheduling. What the NM scheduling model gives us is it gives us increased flexibility, more importantly. And what this basically means is that you can have substantially more number of Go routines than operating system threads that exist at any point. And these Go routines are then multiplexed onto different OS threads. And the advantage that this gives us is if a Go routine is suppose running on an OS thread and makes a blocking system call, for example, then that operating system thread is also going to block. And if there are other Go routines that are meant to run on this blocked thread, those would also block if nothing is done about it. What this model allows us to do further is it allows us to take this other Go routine which was supposed to run on this thread and make it run somewhere else, as we will soon see in much greater detail later on. So as we saw, the Go scheduler does NM scheduling. And the next question that comes to mind is, how do we actually keep track of Go routines that are yet to be run? So at any point, your program might be creating more and more Go routines to run, but how does the user space scheduler that exists actually know what Go routines it has to next run? Following how the OS scheduler or the kernel scheduler does things, we could have a run queue here. So let's maintain a global run queue of Go routines that are yet to be run. And this queue follows FIFO, first in, first out. Now, the first important thing to note here is that with FIFO, there comes an inherent notion of fairness, meaning that if a Go routine is created first, it's only fair that it gets to run first. And subsequently, the operating system threads that exist can take Go routines from this global run queue and then run them, or the user space scheduler can explicitly go ahead and assign Go routines to different operating system threads to run depending on how it's implemented. With this state, there are a few things that are worth discussing and taking into consideration. Since we have multiple OS threads accessing the same shared data structure, which is the global run queue in this case, we would need some way to synchronize access there. And a lock is one way to do it, and that's how the initial Go scheduler did it as well. That is Go 1.0. This is how things happened back then. Now, if you have a lock which needs to be acquired and released every time a thread needs to pick a Go routine, things won't be as scalable as you might want them to be. Mainly because if your Go routine is, for example, short running, and let's say the Go routine finishes running, the operating system thread would need to get a new Go routine. If it needs to get a new Go routine, it needs to acquire a lock, wait for a lock if it's not available, and so on. So there's going to be a lot of contention here. So things aren't going to be scalable. Now, what if the running Go routines happen to be in long running tight loops? it's likely that the ones in the run queue are going to end up starving. And one way to deal with this is actually forcefully stopping the long-running Go routines and making them execute later on, also known as preemption, which we will talk in greater detail later on. So once you actually try and preempt something, what's going to end up happening is that you need to decide what length of time slice is appropriate for each Go routine. Now, if you keep a shorter length for each Go routine, what's going to end up happening is you're going to have more timely access to the shared resource, but also you're going to end up with a lot of context switching that's going to occur. So from a fairness point of view, and also from an efficiency point of view, this is not going to be the best way to go about it. So to mitigate these issues and challenges, what ended up happening was as follows. The notion of distributed run queues was introduced. So each OS thread would have its own local run queue that it would have a set of Go routines that it could take from and run. The advantage here is that for the OS thread to access the run queue, it does not need to hold a lock, because no other entity would access this particular run queue then. There is still a global run queue maintained to keep track of Go routines, the reason for which we will soon see. Since there is a global run queue, you're going to have a lock there. But the contention problem here is substantially reduced because each OS thread is going to be taking things from its local run queue more often than it's going to be taking things from its global run queue. And as of Go 1.17.2, and this has been the case for quite a while now, each local run queue has a dedicated length of 256 Go routines. Now, that looks good so far. But let's take a small detour and talk a little bit about what GoMax procs is and what it actually means for us. So GoMax procs, according to the documentation, the way it's defined is as follows. It limits the number of threads that are actually executing and actively running code. The meaning of this is that if there are threads that are blocked in system calls or threads that are blocked otherwise, those threads are not going to be counted against the GoMax procs limit. And what this subsequently means is that you can have a large number of threads that are going to be blocked in syscalls, but only a small number of threads that are actually executing code. Another thing is that we maintain per thread state here, namely one of the per thread state being we maintain local run queues. Now, if a thread is blocked in system calls, it does not really need to maintain a local run queue. And subsequently, whatever Go routines are part of that thread and are blocked, and that thread is blocked in system call, those Go routines will probably be used elsewhere and run elsewhere. So we don't need to maintain that per thread state. It's not too efficient from a memory standpoint, as well as those Go routines could be better utilized elsewhere. Second thing is that the Go scheduler is what is known as a work stealing scheduler, as we will soon see. Meaning that if a particular thread does not have work to do, it's going to try and steal work from other threads that have an excess of work that it is currently doing. So in order to try and steal work, it would then, now each thread would have to check with an unbounded number of operating system threads. And this again is not as efficient and scalable as we would want it to be. So how do we tackle this? To deal with this, the notion of something known as a processor was introduced. Processor, like the Go routine and the operating system constructs, is also a heap allocated data structure. A processor is actively executing Go code and has an OS thread that is associated with it. And much of the state of the previously per thread can now be moved into the processor named such as the local run queue. So now you have a bounded number of entities that you would have to check if you have to steal things, or you have to steal work rather. And another thing is that the number of processors is always going to be equal to the number of GoMax procs that exist. So this is what our scheduler now looks like from a very high level. You have a global run queue with a set of Go routines, which is behind a lock. And then you have a set of processors whose numbers are equivalent to the value of GoMax procs. And each processor has a local run queue with a bunch of Go routines. And you have an OS thread, which actually is executing some code. For more detail into the design decisions of this and why things happen the way that it did, this particular talk by Dmitry Vyukov, who is also the original author of the new scheduler design, which is the new and improved scalable Go scheduler. This talk is an excellent watch for that. So if you're interested, please check this out as well. Before moving on, let's actually spend a minute or two talking about fairness in general. So what do we mean by fairness and why do we care about it? So let's consider the following scenario. Let's say we are at a supermarket where there is a cashier helping us checking out things, and you have a bunch of customers waiting in line to get their items processed. And each of these customers can have a bunch of items that they want to check out. And this queue is FIFO again, first in, first out. This looks fine. But what if the scenario is something as follows? Let's say one of the customers that is the first customer has an excessive number of items being processed. So here it's shown as 6, but it could be, let's say, 20, 25. What's going to end up happening is that the cashier, which is the resource that these particular customers actually want, is going to end up spending most of its time on this one customer, and the rest of the customers behind this one customer are going to end up starved of this particular resource. So in scheduling, especially in presence of a system which is FIFO, if you have a resource hog, the first customer there, it leads to something known as the convoy effect happening. And this is a common problem that happens in scheduling, and there are multiple ways to deal with this. So how do we deal with this in scheduling? One way is to just schedule the shorter running tasks, but this would require us to know what the characteristic of the workload actually looks like. And this isn't always the case, and sometimes it's not even possible to know this. Another way to deal with this is something known as preemption. Now, there are two types of preemptions called cooperative preemption and non-cooperative preemption. In cooperative preemption, what ends up happening is you end up trusting the entity that it is going to give up the resource voluntarily in a timely manner. But if it doesn't end up doing so, there is pretty much nothing that you can do about it. That is cooperative preemption. Non-cooperative preemption, on the other hand, says that, hey, you know what? If you've been running or consuming this resource for a certain amount of time, after that time, you are forcefully going to be stopped whether you like it or not and run at a later point of time for your remaining duration. What this allows us to do is it allows us to give the other waiting entities some time on the resource as well. Now, keeping these two in mind, let's move on and again revisit the concept of preemption from the Go scheduler's point of view at a later point. So, all right. Now that we have enough context, the first thing that we ask ourselves is, how do we even choose what Go routines to run? We have so many Go routines. We have in our local run queues, we have in our global run queues. So which one do we actually end up running? So let's try and understand that first. Let's say that the Go routine that is currently running, as highlighted here, ends up calling into the runtime through some way and exits and stops execution. Now, this particular processor is not going to have anything to run, and it needs to choose one Go routine that it can run. Remember that an initial issue was that we were checking the global run queue with a lot of lock contention, and that led to issues. So what we end up doing is, first we check the local run queue, for which we don't need to hold any such contended lock. So we check the global run queue if it has work in terms of Go routines. So here, yes, we do have work available. So we take a Go routine from there and we start running it. Awesome, that works great. Now, let's say that the local run queue of processor P0 is also empty. What do we end up doing now? What we end up doing now is as follows. Now we actually check the global run queue next. So we hold the lock, we check if it has work available. If it does have work available, we steal from the global run queue and then start running those Go routines. But there are multiple reasons as to why we steal from the global run queue first, rather than checking some other source of work. So we check the global run queue. It has work. And now what it's going to do is, it's not going to take just one Go routine and run it. What it's going to do is, it's going to take the number of that is equivalent to the length of the run queue divided by the number of processors that exist. So it tries to take what it thinks is its share. And what this also allows next is, if some other processor wants to check the global run queue for work, it would then find the number of Go routines equivalent to its share also available there. for it to steal. And if you steal multiple at a time, you don't need to further keep checking the global run queue often, and you further reduce the problem of lock contention there. So you check there is work available, so you steal the proportionate number, and you get go routines now in your local run queue. So now you have things in your local run queue, you start running it from there. Now, what if the global run queue also is empty? What do you end up doing then? Next, what happens is there is another component in the runtime known as the net poller, which is responsible for handling asynchronous system calls, mainly network I/O. So if a particular go routine is waiting on a network I/O system call to return or get a response back, it's going to end up waiting on the net poller rather than blocking an actual OS thread. So this asynchronous type of blocking is extremely helpful in the runtime. And this is what also happens in the cases of blocking on channels or timers as well. So next, what we're going to end up checking is the net poller. If the net poller has any work. So let's say that the net poller has a ready go routine. So it takes a go routine from the net poller and starts executing it. But what if the net poller is also empty? What ends up happening then? So here is where the processor ends up stealing work from another processor. And this is what we talked about earlier when we said that if you have to check an unbounded number of OS threads, things would not become as efficient as you would want them to be. So here we have a bounded number of processors, which is 2 in this case. It calls into the runtime, we need to find some work. Local run queue is empty, global run queue is empty, net poller is not giving us any work. So now we end up stealing half of the work available in another processor. So in implementation, what ends up happening is the processor randomly picks another processor and then checks if that processor has work available. If it does, it steals half of it. Now, since we are randomly picking things, it's also possible that you might end up picking yourself, and stealing from yourself when you don't have any work doesn't really make sense. Or you might end up picking a processor that also doesn't have any work. This processor stealing is retried actually, and I think currently it's retried 4 times. So it steals half the work that is available from P1 and it brings it in its local run queue. Now, since there's work available in the local run queue, it picks things from the local run queue and starts running. Awesome. So that looks good, but there is still the issue standing about the convoy effect. What will that be taken care of in the current scenario? We spoke about preemption earlier. Now, actually, let's see how Go does it. Let's look at the history of preemption in Go. So in Go 1.0, you had purely cooperative preemption, meaning that if you had a tight loop or a hot loop that ran, let's say, infinitely or for a really long period of time, and it did something, what's going to end up happening is that Go routine is never going to give up the processor, and all the other Go routines are going to end up starving then. Or if not starving, you would have increased latencies there. In Go 1.2, what was introduced was function call preemption. Here, what happens is whenever a function call is made, there is a check to see if the stack size of the Go routine needs to grow. And that check is subsequently responsible for handling preemption of that particular Go routine if needed. But the problem here is that that function call might not happen at all because the compiler might just inline that particular function for efficiency reasons. And if that function is inline and there's no actual function call taking place, the same issue as the first case happens. But in Go 1.14, what was introduced was non-cooperative preemption or asynchronous preemption, meaning that if a Go routine ends up running for a certain amount of time, regardless of whether it makes a function call or not, it will be preempted eventually. Now, each Go routine is given a time slice of 10 milliseconds, after which a preemption request is issued. This 10 milliseconds is again a soft limit, and preemption is actually issued by sending a user space signal called sigerg to the thread that is actually executing the Go routine. Now, to understand more about why sigerg and what the design process behind this particular feature was, there is a talk detailing out this particular change by Austin Clements in a previous GopherCon. So who actually ends up sending this particular signal, and from where does it come? So there is a long-running daemon in the Go runtime called sysmon. So this particular Go routine is long-running and it does not execute on a P, or in other words, it executes without a processor, mainly because this particular Go routine handles a bunch of other stuff in the runtime. Two cases of which we will soon see. So the first case being it helps with preemption. So if it sees that a Go routine is running for a long period of time, namely it's ran for 10 milliseconds, it issues the preemption signal. So let's see what that looks like. So if a Go routine has been running for 10 milliseconds, the sysmon daemon sends SIGURG to the thread that is actually running the Go routine. So where does this preempted Go routine end up going? Let's say that the Go routine ends up running in an infinite loop. What's going to end up happening is after 10 milliseconds, you preempt it. If you put it back in the local run queue, and all of the Go routines in the local run queue now are, let's say, short-lived Go routines or that do some work, for example, well under 10 milliseconds, what's going to end up happening is that the Go routine that you ended up preempting, let's say you put it back in the local run queue, these Go routines run, that particular Go routine starts again, it's going to run for 10 milliseconds, and those other Go routines which are actually very short-lived will end up having to wait for an entire 10 milliseconds slice. So effectively what is done is once a Go routine is preempted because of it being long running, it's going to be put back in the global run queue, effectively meaning it's going to be run after everyone else. Let's try and observe what's actually happening when we are running something. So let's try and pull out some metrics from the Go runtime. And also, since the preemption is issued using a user space signal, we can actually use the Linux kernel's tracing subsystem to observe that these signals are actually being sent. So let's see what that looks like and try and understand things in a better manner. To see what's happening inside the scheduler, what I've done is I've written a small tool which takes the scheduler traces that the Go runtime provides us with and exports them out to Prometheus for us to visualize. Now, for the purposes of this demo, I'll be setting the value of GoMax procs to 2, mainly because it's easier to visualize things that way, but the same interpretation and results can be extrapolated to higher values of GoMax procs as well. The way we're going to do this is that first we have a configuration file that we will provide to this tool, and it's as follows. So we have a path which specifies what the value of GoMax procs is, which is 2 for us, and then subsequently what binary we want to run. And then we give it a bunch of Prometheus configuration as well in terms of what endpoint should you scrape metrics from and what the port should be. And the interval here under shed indicates how frequently you want to get runtime traces from regarding the scheduler runtime traces out from the Go scheduler. So in this case, it's 10 milliseconds. The effective command that ends up being run is as follows: go debug equals shed trace, which allows the Go runtime, or which enables the Go runtime to emit scheduler traces, and we do that at a period of 10 milliseconds. And then we set GoMax procs equals 2, and that's our binary name. Now, before actually running things, let's look at the code that we're actually running the binary for. So the code is pretty simple. We spawn 10 Go routines, each of which does some CPU intensive work. And then we finally wait for them to complete. Now, the CPU intensive work function here is basically a function that multiplies two matrices of size 1024. It's nothing of significance, but it's just something to create long running workloads so that we can visualize what's happening inside the scheduler. So now to actually run this tool, before we run it, I'm going to start Prometheus as well. I've kept the scrape interval to be 10 milliseconds, mainly because that's the time slice for preemption for each Go routine, and things become significantly clearer when that's the scrape interval for Prometheus as well. So let's actually go ahead and run this. So now that our binary is running and we are starting to serve metrics, what we can then do is we can go to Grafana and go to our data source and just verify if everything is working correctly. Yes, it is. So our scrape interval is 10 milliseconds. Let's just save that. And now let's actually add metrics that we want. So we will add in local run queue 0, which is our first run queue length. And then let's add in the other two run queues as well, which is local run queue 1 and the global run queue. There you go. And add. Okay, awesome. So let's just zoom in here a little bit to see what's happening. So here we can see that we have 3 lines as we expected, and now the yellow line is local run Q1, which is this line here, and then we have green line, which is the local run Q0, and the blue line is our global run Q. So let's see what's actually happening here. So initially, local run Q0 had 3 go routines which were running, and local run Q1 had 2 go routines running. And as you can see here, after 10 milliseconds, one go routine gets preempted. And as soon as it gets preempted, it gets put into the global run queue. So each of the local run queues, that is, each of the processors were running one go routine which got preempted, because of which each of them had a dip by 1. And the global run queue effectively had a rise by 2. Now, if you see here, at this point now, the local run Q1 has pretty much no go routines running. So it's going to check its local run queue. It has nothing. So what it does next is check the global run queue. Now at this point, the global run queue has 7 go routines that were running. What ended up happening was it's the local P1 essentially stole 4 go routines, and the number of go routines for P1 became 4 here. Post which local run queue 0 also ended up stealing go routines, because of which there was a further dip. And as you can see, next go routines ended continuously end up getting preempted after 10 milliseconds, and the global run queue's length goes on increasing by 1 each 10 millisecond period. Post which, as soon as something reaches 0, it steals work and the global run queue length drops, and then it keeps on going. So this is pretty much what we saw earlier, and it was really interesting for me to actually visualize this and see that what was actually happening inside. Now, another thing that we can actually observe is that whenever a preemption request is issued, that preemption request is issued using a user space signal called SIGERG, as we saw earlier. Now, since this is a user space signal, what we can then do is we can use Linux's tracing subsystem to actually get events for whenever that particular signal is issued, and thus enabling us to see the preemptions that actually happen while the program is running. So let's go ahead and stop this program. And to enable the whole tracing mechanism, I have a small script here which enables it. So let me go ahead and run this script, which enables filters and all of that. Now sig23 here, 23 is the signal code for SIGERG, similarly to how 9 is the signal code for SIGKILL. So let me go to the tracing directory, which will have our log. And now let me run the binary itself. So this is running. Now if we do, if we look at the log and we grep for GopherCon, which is our binary's name, we will soon see that the GopherCon binary here, let me just zoom out a little. Yeah, the GopherCon binary here has a ton of preemption signals being issued at regular intervals of time, and these are basically the thread IDs to which the signal is being issued to. So this was also really interesting for me to see these signals being emitted and observing them as they happen. Okay, so now that we've seen what actually happens inside the scheduler, let's revisit our code snippet from what we just ran. So just to recap, we run 10 go routines, each of them doing some CPU intensive work. The question that arises now is that when a go routine spawns other go routines, as in this case, where do these spawned go routines end up going? And the answer for that is that these spawned go routines are put in the local run queue of the processor that is responsible for spawning these go routines. Considering FIFO brings fairness to the table, should we put the spawned go routines at the tail of the queue following a purely FIFO approach, or can we do things in a better manner? So let's look at what a purely FIFO approach would look like. So this spawns another go routine. This go routine gets put at the tail of the queue. So there are a few interesting considerations here. Namely, FIFO is good for fairness, but it's also poor for locality. LIFO, on the other hand, that is last in first out, is great for locality, but it's bad for fairness. But maybe we can look at a few Go-specific practices that we can look at and use to optimize for commonly used patterns. So channels are often used in conjunction with coroutines, namely for communication or synchronization. And let's look at the following code snippet to try and understand this better. So here we have two coroutines, a sender and a receiver, that are communicating over a channel. So the sender sends something on the channel, the receiver receives it and processes it. Now this is an unbuffered channel, meaning that if the sender sends something but the receiver has not received it, the sender is going to block. But if the receiver, and subsequently if the receiver tries to pull something out of the channel but there's nothing there, the receiver will block till the sender sends it. So let's try and illustrate this. So let's say the receiver is running, the receiver tries to receive something but it blocks, the sender is supposed to run next. So the sender runs, unblocks the receiver. Now, where does this receiver end up going? It ends up going at the tail of the queue following a purely FIFO approach. It would have to wait for all other go routines effectively in the local run queue to actually be able to start processing that message. So what is the impact on performance here? Let's assume that all the go routines in the local run queue are long running ones. So on an average, each of them are going to take 10 milliseconds to preempt. So if one of these, either the sender or the receiver, is at the tail of the queue, it's going to have to wait for, on the worst case, 255 into 10 milliseconds, because 256 is the length of our run queue. So this essentially might be an issue of poor locality. So can we combine LIFO and FIFO approaches to try and achieve better performance in some form? So let's consider the LIFO approach. So as soon as a go routine is spawned, you put it in the head. You put it at the head rather than at the tail. What effectively ends up happening is that these two go routines can end up respawning one another constantly, and then they can end up starving all of the other go routines in the local run queue. To solve this problem, there is what Go uses is something known as time slice inheritance, meaning that whenever a go routine is spawned, the spawned go routine inherits the remaining time slice of the go routine that spawned it. So in this case, if a go routine spawns another one at the 3 millisecond mark, the spawned go routine gets a time slice of 7 milliseconds rather than 10 milliseconds. Now this effectively ends up giving these two go routines a time slice of 10 milliseconds together in order to run, after which one of them will end up getting preempted and the other ones can continue execution. And the impact of performance on this was rather significant. From this snippet is taken from the commit that implemented this change, and there was a benchmark called benchmark ping pong hog, which is similar to the example you saw earlier with the sender and receiver. That benchmark improved by 99.88%. And not just this one benchmark, there were improvements throughout the language. This looks good, but you could still end up starving the go routines in the global run queue because you might never end up polling it. And the solution for this is that you poll the global run queue occasionally. How do we compute the condition in which that decides when to poll the global run queue? Meaning that firstly, it should be efficient to compute because this is in the scheduler's fast path. Secondly, while implementing this, a few things were initially considered. So first, it was made that the condition was a function of the length of the local run queue itself, but this required an explicit counter to be maintained, and things could probably be done in a much simpler manner. So how is the condition finally computed? It's computed as follows. So there is a counter called shed tick, which is incremented every time a new runnable go routine is found and subsequently executed. So whenever shed tick is a multiple of this constant 61, you poll the global run queue. Why 61? Firstly, it's not too big, meaning that you don't want to poll the global run queue too infrequently. And if you poll it too infrequently, you have the same fairness and starvation issue. If it's too small, you end up polling it too frequently, and then you have the same lock contention issue and also fairness issue as well, meaning that you are not being fair to the go routines in the local run queue. And most importantly, it's prime. And the reason for it being, the reason that being prime is most important is as follows. So 61 is chosen also by keeping fairness in mind to some extent. And the reason for this is that when you have an application running, it's likely that the frequency at which the application calls into the scheduler or the scheduler is required to find a new runnable go routine, that frequency is likely to be something that is a power of 2 maybe, or 16 or 32, or something along those lines. But it's less likely, but not impossible, that the frequency is something like a prime number such as 61. And the reason that prime number here is important is because you want to try and minimize the interference between the frequency at which the scheduler is called into and the frequency at which the global run queue is checked. Because if these two frequencies are even somewhat similar, what's going to end up happening is that that particular check is going to be true more and more often, and that leads to bad fairness as well as high lock contention. To illustrate this, let's consider the following graph. You have the orange line here being a frequency of 8, that is the application frequency at which it calls into the scheduler, and the blue line is of frequency 61, and the red line is of frequency 64. So as you can see, the orange line and the red line are 0 together, significantly more number of times than the orange line and the blue line are 0 together. So you're essentially trying to minimize the number of collisions as much as possible. And another great way to look at it is trying to select the size of a hash map. And hence you choose a prime number over something like 64 or another power of 2 or 32, which isn't a power of 2, but you still might end up having more number of collisions there. So we've seen how go-routines effectively end up running on threads, but what happens when they get blocked on system calls? If you have a go-routine blocked on system call, there is effectively nothing that is there to run the other go-routines in the processor's local run queue. There is still work to do, but there's nothing there to do it. There are resources elsewhere available, but we are not making use of that. The show must go on. So what we do end up doing is we perform something known as handoff to deal with this. Meaning we first disassociate the processor and the thread blocked in the system call state by issuing a call called release p, which disassociates these two. Now you have the thread, you get another thread, which is either already available for you, or you create a new one, and you associate that with the processor. And now you have a thread to run go routines. You pick a go routine from your local run queue. If you don't have a go routine from your local run queue, you pick a go routine from your global run queue and start execution. Handoff can get expensive, mainly because when you disassociate a processor and the thread and you try and get a new thread, what might happen is an existing thread might not be available for you, so you have to create a new one. And creation of this new thread can get expensive, especially if you have repeated system calls that might cause your thread to block. And the way that the Go scheduler tries and optimizes the survey is as follows. So the Go scheduler will do an immediate handoff only if it knows that the call is going to be blocking and for a prolonged period of time. One such example for this is a CGO call, for example, or if you do a system call such as read on Darwin architecture. In other cases, it's going to let the thread be in the block state and it's going to change the status of the processor to reflect that it is in a system call. If the system call returns soon enough, you don't have to worry about creating a new thread or getting a new thread. And all of that, you can resume execution as is. But it's also possible that thread that you optimistically hoped for returning from a system call soon enough, it might not, can prolong for a long period of time. So in that case, sysmon comes to a rescue again. So sysmon sees that if a processor is in a system call state for a prolonged period of time, sysmon is what is going to initiate the handoff then. So it's going to call release p and then handoff is going to happen. So that was when you enter a syscall. But what happens when you actually return back from a system call? So the scheduler tries to schedule this go routine on its old P itself, the one it was on before going into the system call. So this is mainly to try and maintain as much locality as possible, and also to try and utilize that LIFO buffer if it could. The blocking and unblocking ping pong pattern can be done more efficiently. So if that is not possible, it tries to get an idle P and schedule it on there. An idle processor is something that ran out of work, didn't find work locally, didn't find work globally, didn't find work on the netpolar, didn't find work on another processor as well. If that is also not available, the scheduler puts this go routine in the global run queue for some other processor to take it up. Awesome. So we now have a fairly good idea about what happens under the hood. So all of this is taken care of by the runtime itself. Are there any knobs that we as a user or a developer can try to use to control some of this runtime behavior? There are a few runtime APIs that are exposed, but it's always a good idea to first treat the runtime as a black box as much as possible, and only use these APIs only when it's actually and absolutely necessary. So a few runtime APIs that are available to interact with the scheduler are as follows. So the num goroutine API, as the name suggests, returns the number of goroutines that exist in your program at the time that it was called. And the remaining goroutines I would like to talk about just a little bit more in detail. So gomaxprocs, as the name suggests, sets the value of gomaxprocs. One thing to keep in mind here is that if this is changed after the program is started or while the program is executed rather, for whatever reason you need to change it, keep in mind that it will lead to a stop the world operation, because the scheduler will have to resize the size of the list that holds all of the processors to be equal to the new gomaxprocs value, and then subsequently resume execution. So a stop the world operation will occur there. GoShed, the GoShed API yields the processor that and the calling goroutine gets put back into the global queue. If you plan to use it for performance reasons, it's likely that the improvement can be done in your implementation itself somehow. So use it only if it's absolutely necessary. GoExit, it terminates only the calling goroutine. And when I say only, what I mean is if you call GoExit on the main goroutine, the other goroutines are not going to, but once they finish execution and they come back, there is nothing to return to at all. Runtime detects this as a deadlock, and your program is going to end up crashing. And this one such example of where this is useful and used is in the testing package in the fatal method. One of the more interesting ones is lock OS thread and unlock OS thread. What this call does is it wires the goroutine to the underlying OS thread, and it's mainly used when the goroutine changes the underlying thread state in some form. So let's say it changed the thread state, and this thread created a new thread, mainly because when in the scheduler, if it sees that all the available threads are in a blocked system call state, right before the last thread enters a system call, it's going to create a new thread, so as to make sure that progress in work continues to happen, and there's one thread that is always available to actively execute code. So let's say this thread creates a new thread, but this thread has no idea that the thread state was changed, and now this goroutine is scheduled on this thread. It's not going to function as you might expect it to, and debugging this can get really, really difficult. So whenever you have such a situation, try and use lock OS thread and unlock OS thread there. So Weaveworks actually has a really excellent case study on this. The issue they ran into was because they changed the underlying thread state in terms of setting a namespace. And these are the two related articles for that particular case study. I'd highly recommend going through them. This particular call, that is lock OS thread, acts like a taint indicating the thread state was changed, meaning that no goroutine can now be scheduled onto this thread which is locked, and no thread can be created also from this locked thread to try and avoid the issues that we saw earlier. And one caveat to keep in mind here, or one gotcha rather, is that if a goroutine that has logged onto a thread creates another goroutine, this created goroutine, there are no guarantees that it's going to run on this logged thread. So don't create a new goroutine when you expect it to run on the changed thread state. Okay, that was a lot of information, but it was really interesting to talk about as well. So thank you so much for sticking around and listening and attending this talk. So in conclusion, the Go scheduler is distributed and not centralized. Fairness is kept at the forefront of the design next to scalability. The scheduler design factors in domain-specific knowledge as well as language-specific patterns. Understanding runtime APIs well before using them, and use them only if it's necessary, and be especially careful if your goroutine intends to change the underlying thread state in some form. These are a few references that were really helpful to me, and I hope it helps you as well. Thank you so much for listening, and I hope you have a great rest of the conference.
We have a lot of exciting things at CrowdStrike. We currently are processing close to 500 billion events a day. In a day, we process more events than Twitter has tweets in multiple years. So there are very few places, very few companies who have that scale that we operate at. It's a holy grail of hard problems to solve and the satisfaction of stopping breaches, protecting our customers. What would you rather do? stop nation-state attackers and protect your customers, or try to get consumers to click on some ads, right? I mean, it's a no-brainer.
Thank you so much for that insightful talk, Madhav. I really love kind of diving deep into how things work under the hood.
Yeah, the whole thing about Go is simplicity is hard, right? That was one of the core observations, early on. And I think it's really cool to see under the hood here how much work was done to make Go so simple and intuitive. I think it's really important to know, while we're writing this code, while we're trying to write beautiful code, what's going on at that layer right below. I think that's pretty cool. And appreciate Madhav for diving in there. It was one of the pantheon that you talked about.
Or Jibba Jabba, depending on who you ask.
Yeah, right. Yeah.
And I mean, also, it's important too, these things can take a lot to digest. And so often these sessions are jumping off points, to go explore more. Like, where do you go? They're kind of like hooks,
Right.
And if you have questions about all of this stuff, I know that Madhav is in the Discord. There's a room under the speakers section. He's in there to answer any questions about the talk specifically and the Go schedule.
And that goes for all the speakers. Okay?
Yes.
All the speakers have their own Discord channel. Don't leave them hanging. They're going to be lonely without you.
Heckle them if you have to.
Heckle them, yeah. Reminder to heckle us too.
Especially Mark Bates.
Especially Mark Bates. You haven't been shy with heckling us, so
right.
Yeah. Share the love,
but don't heckle the speakers. They put in a lot of work. Do not heckle them. Heckle us or Mark Bates, apparently. That's also okay.
That's also okay.
Yeah.
Later today, we also have an AMA with the Go Time team and the Go team. Please submit questions. There's a Go team AMA channel in the Discord under the speakers section where you can drop those. If you're watching us anywhere and you're not on the Discord, you can jump in at discord.gophercon.com. Also, big news related to the anti-hiring clauses at CrowdStrike.
Imagine a big breaking news banner above or below. Maybe we can get it on the TV there.
This just in. Yeah. So apparently they've removed all the disqualification clauses and you're all hired.
Yeah. All of you. Do your worst. You're going to go to CrowdStrike, write a bunch of generic code that's bad, anti-pattern. We're going to be inventing anti-patterns, I guess, right?
I think they're looking for now creative uses.
Yes. I think we saw try, catch, and finally so far. That was one of them. Async and await was another one of them that we saw.
I want to meet the people who implemented that in this short window of time.
Yeah, and there are playground links. There's a Discord channel for it. We mentioned last time. There's playground links.
We knew this was coming, right? We knew there was going to be this spike of some fun things. And
we brought this on.
Oh my God, what?
But it's like you said, the level of creativity so far has been really impressive. So thank you to all the anti-pattern creators. It's all going into Erik's book. It's going to be wonderful.
Well, he'll profit.
Who's writing the Go generics that generate Rust? That's the question.
Yep, indeed.
I think we know who. I think we know. Between you and I think we know who.
So we also have some more virtual meeting spaces coming up with some of the sponsors. Please go check that out. There's some career opportunities session going on with Bread. There's a Dapper overview with Microsoft, and Course Hero is running open office hours. Also go into Discord, engage with them. They all have their own channels. They're hanging out to answer any questions. Some of them are hanging out in Gopher Town if you want to interact in more fun avatar way.
Non-text, I guess.
This is the analog Gopher time right here. Hey, buddy, how you doing? Hey, I'm good. Let's talk about some Go. I mean,
it's like one of those PBS sessions with
Hey, how you doing?
Tune in next time for a Bob Ross recreation from Johnny.
Exactly.
I'm a little worried about your talk later. I'm concerned.
Yeah, you're concerned, But listen, I do really want to know how these things come about. I've heard about 3D printing for a long time. I've even thought about getting one, and I Oh yeah, you're offering me more of those things.
These were all made possible
These are
by
all made
3D
possible by 3D printers. And yeah, my curiosity is now piqued because we have with us Sebastian Spaink, who's about to tell us exactly how this magic happens. So Sebastian, please tell us about 3D printing Gophers and Go.
Yeah, hi. Yeah, my name is Sebastian Spaink, and welcome to my talk, 3D Printing Gophers with Go. Yeah, over the past 2 years, I've been 3D printing as a hobby, and I've become obsessed with it. I think it's amazing. You can create just about anything out of just a pile of plastic. And I've been able to create some cool stuff like dinosaur skulls to more boring practical things like pegboard trays. And there's still a whole lot more I like to print. And another obsession of mine is the programming language Go. So of course I started looking at ways I can incorporate these two obsessions. So I started 3D printing a horde of adorable gophers, and while I was doing that, I found other ways you can incorporate Go with 3D printing. And that's what I want to share with you today. So my main goal for this talk is for me to share with you, to help you discover a fun new way to use Go in a popular hobby. And this talk is meant for an audience of anyone. So if you're a 3D printing enthusiast or a complete beginner, I'm hoping that you could take something away from this talk, and at the end be able to 3D print your very own adorable gopher. So I want to start in the basics and talk about what is 3D printing. So a very generic term, like a definition for it, is it's just a construction of a 3D object from a digital 3D model using a specialized tool known as a 3D printer. And that's all there is to it. Where it gets more exciting is when you talk about the actual technology behind a 3D printer. So as I mentioned, I'm just a hobbyist, and so I don't have any actual professional experience 3D printing. So I won't be showing you how to 3D print a bridge or make spaceship parts, but instead I will be sharing the noble art of how to create a gopher. And when you're talking about the technology behind a 3D printer as a hobbyist, there's two main ones that are available. One is FDM 3D printer, which stands for Fused Deposition Modeling, and another one called an SLA 3D printer, which stands for Stereolithography. And what I like to do is go into some detail of how these 3D printers work. So here we have a diagram illustrating the highlights of a FDM 3D printer. And this particular one is operated solely by gophers. And so how we want to look at it is in the top, you have this input material called filament. And this filament gets pushed down through some extruders down to a hot end, because a filament it can be made of a lot of different materials, but its key characteristic is the fact that it melts when it's heated rather than burning. So it's going to get heated up and melted and then pushed out through a nozzle in perfect dimensions and deposited on top of a print bed, where the nozzle and the print bed will both be in motion, and it will be drawing these shapes layer by layer in order to construct a gopher. And at the end, you'll end up with something looking like this. So I used some fancy multicolored filament for this one, but you can actually still see the layers inside the final resulting gopher, showing how it's built up from from bottom to top, and it slowly rises from the build plate. And at the end, once it's cooled down, you have yourself a gopher. In contrast, the SLA 3D printer works kind of in the opposite way, where instead of the input material going to the build plate, you have the build plate going to the input material, which is, in this case, a liquid. It's a big old basin of UV curable resin, and the build plate's going to lower down into that resin at a certain height right above the bottom, and then the UV light will project a certain shape onto the build plate, then curing it, and it will rise and lower again, and we'll do this until out of the nothingness rise a perfect looking gopher. And then unlike FDM printer, where at this stage you'd be done, you can take it off the build plate, there's actually a lot of post-processing that needs to happen with an SLA 3D printer, and it's because the resin is toxic, you can't handle it safely without having gloves and the appropriate safety material. So I find it a little bit more it's a little bit more difficult opposed to an FDM 3D printer. But you can end up with a gopher looking something like this. And the SLA printer is actually capable of a lot smaller layer heights, so you can't see the layers. They are there, but they're so small that they aren't visible at all. So here you can actually see both of them next to each other, the FDM 3D printed and the resin printed one. And so also one of the things, if you notice, the FDM printer tends to be better for doing very large scale things, as far as being able to get because the input materials are cheaper in the cases that I've seen than the SLA 3D printer. But so now that we've seen just like a general high-level overview of how 3D printers work, I think it's time to answer the important question of how can Go help with all of this? So I think, looking throughout the 3D printing process, there's like 3 main steps that Go can be involved in that kind of involve the entire process from beginning to end. One where Go can be used to control your 3D printer. It can help start a 3D print. It can also help you create a 3D model. And it can also help you monitor your 3D printer because 3D prints can take a very long time. So as fun and exciting it might sound to sit next to your 3D printer for hours, whispering at sweet nothings, you do have to be able to remotely monitor it. And that's where Go can help us. So let's dive in by first looking into how we can control a 3D printer using Go. In order to discuss that, you need to understand the 3D printer's firmware. So on your 3D printer, there's some firmware, which is the link between the software and the hardware that will help actually control your 3D printer. And a very popular open source firmware that is most likely running on your 3D printer is something called Marlin. There's other ones available like Clipper, but in my case, I'm using Marlin. And it's very configurable, and it takes something called G-code as input. So you can communicate with this firmware by using this programming language known as G-code. And G-code looks something like this. It's it's in a programming language in a sense, and all of the syntax is kind of broken down in this type and number format, where you're going to have this type and number associated together that gets related to a task. So your firmware knows what this command, this instruction is associated with. And the types that are possible is G type, where it's related to a geometry category of instructions based on linear movement. And then there is the M type, which is related to some miscellaneous function categories. And then the number is, I don't know if there's actually a sense behind the number, but yeah. So you're going to have these two associations, and they can also accept some parameters. But let's look at some practical examples of G-code to understand a bit what I'm talking about here. So here's some G geometry type category G codes. We have G28, which is a special one, which you most likely see at the beginning of the 3D print. It brings your machine axes home so that any movement afterwards will go from that 0 position. And you can make the components move by sending them G1 or G0 commands and providing them an X, Y, or Z axis as a parameter, and it will move in that direction. There's also a special axis E, which stands for the extruder, and that will tell how much filament will get extruded out. And then F here, it'll describe how fast the movements will take. So what we can do here, so how Go can be involved is, so G-code's going to be doing most of the heavy lifting, obviously, but where we can use Go is we can use it to communicate the G-code to the 3D printer. And your 3D printer has a microcontroller with a serial port. So we're going to have to do some serial communication with Go in order to send these G-code commands over to it. Use Go to connect to a 3D printer, and by doing the serial communication, and let's look at a practical example of how that is accomplished. So in my case, the environment setup that I'll be using is a Raspberry Pi that's going to be connected to a micro USB port, which is then connected to the microcontroller's serial port. And on the Raspberry Pi, I'm running Linux. And on Linux, the 3D printers can be represented as a special device file. And this special device file can just be accessed by using the standard OS library, and you can open up just like a regular file. You do need to define some flags to make sure that you're not being set as the controlling terminal so that you don't get any special signals sent from your 3D printer, and that you can read and write from it. With that, you need to use this special structure called term.ios in order to set your configuration, because you need to add some extra details depending on your motherboard that you're connecting to. You need to be able to set the correct baud rate, which is the speed of communication that you're going to be communicating over the data channel. And so this particular number I kind of pulled out of the internet, just looked at my 3D printer and said, okay, this is the one that's associated with it. And with this term.ios structure, you can set the set the configuration correctly. And once this configuration is defined, you can set it onto this special device file by using a system call, this IOCTL. So you pass it the file descriptor and you pass it the configuration structure and say, hey, this is how I want to communicate with the special device file. Something I wanted to point out here is interesting. So we actually have to use an unsafe pointer to make this system call, which is not something I usually do in my daily work with Go. Try to avoid using unsafe pointers, but you have to in this case for two reasons. You need to circumvent the type conversion that Go offers. So, because you're kind of giving over a chunk of memory to the operating system saying, hey, you can do with this whatever you want. And we need to also prevent the garbage collector from cleaning it up before the operating system is done with it. So, kind of unrelated with the actual serial communication, but kind of an interesting tidbit. And here it is kind of broken down, the entire program. So we open up the serial device, we set some configuration, and we set it onto that device. And now we can start reading and writing, and we start writing out our G code. And we can start reading it out into a buffer. So overall, I found this kind of complicated. Luckily, the internet provides this open source package called Tarm Serial that has made it a lot easier. So behind the hood, it's actually doing what we just described. But with this package, we can make the code look a lot simpler. And this main function, all we have to provide is the special device file name and the baud rate. And then we can open up the port and write out G-code commands. So here I've got a brief pre-recorded video kind of demonstrating that program running. So here we send the G28 code so you can see the 3D printer homing itself. And you notice that it kind of like detected the barriers, its limits, by hitting on all the axes, and right now seeing where the z-axis as far as it can go, but using this special BL touch. And then the next couple of commands is going to be moving in the x, y, and z direction, 40 millimeters, and kind of see all the pieces moving around. And then you can kind of imagine in an actual 3D print, all these pieces are going to be moving around in order to draw out layers, which we'll be looking at more later. So now that covers the first category of G-code, the linear movement. So we've seen how we can actually get things moving, which is an essential part of 3D printing. And then the next category is going to be the miscellaneous functions. So these are important. So the two main important ones I wanted to highlight here are ones to heat up the hot end and build plate. So you can start melting the filament correctly. So it has to be at a perfect temperature in order to make sure that, depending on what kind of filament you have, to make sure it melts correctly. And then you could also hit up the build plate, where this is actually an optional thing, but heating up your build plate is very useful in order to improve adhesion of the actual print so that it doesn't warp or roll off the bed. And what I would like to do now is I want to show you another practical example showing how you can heat up, seeing this miscellaneous functions in action. But in order to do that, we need some way to visualize the temperature increase. So luckily, there's another G-code commands, another miscellaneous ones, M105 and M155, that will help us gather the temperature. So we can make use of this to illustrate that the previous commands were actually working. So M105 is kind of just a basic one where we just get a single temperature report, and it will tell us what the current temperatures are of the tools. And then M155 is an improved version of it in a sense if you want to get time series data where you want to see that temperature actually increasing and changing over time. And it takes in a time interval as a parameter, and it will report this temperature every 2 seconds in this case. So let's take this and create a new demo. So what my intention here is to make use of the Go program we looked at previously to set and send the G-code commands over serial and have it run on the Raspberry Pi, which is connected to the 3D printer. And then alongside it, also have another Go program running to get and parse that temperature report, and then send it over to the Influx data database, which, if you aren't familiar with, is a database that's good for doing time series data, and it comes with a fancy dashboard to help show that data changing. And so let's dive into that. So let's look at seeing how we can create a program to read and parse this temperature report. The first part is very basic, or at least very similar to the first program, where we're just writing out a G-code command over serial, M155, and say, hey, run this, give us the report every 2 seconds, and we'll read the results into a buffer. In the actual code, so I simplified it here for the sake of putting it on a slide, but the actual code is actually running this reading into a buffer in a Go routine, which gets triggered on a time interval, also every 2 seconds. Like, let's get the new temperature report and read it in. But so then the temperature report that we're going to get kind of looks like this is going to be this cryptic string line that we're going to receive, where we have this key and value pair where T is associated with the hot end temperature and B is associated with the build plate temperature. And then the values is going to be this actual / target, where the actual is going to be the current temperature and the target is going to be the temperature that you set with those M104, M140 commands. And what we're interested in is we want to get that actual temperature so that I can demonstrate to you that this miscellaneous function actually worked and that it's increasing the temperature of the nozzle and build plate. So what we can do in Go, we can just make use of some regular expressions, very straightforward as far as like just made up this regular expression to grab the T and grab the actual temperature and then dump the key value and convert it into a float so that we can work with it and send it along to the influx database so that we can see it change. And then we can do the same thing with the B build plate. I'm sure you could probably come up with a more clever regular expression, but this is like the most simple, straightforward way I could think of. Okay, so we've got the temperature report being reported every 2 seconds. We're getting this temperature report. We know how to parse it. Now let's send it over to the influx database so that we can visualize that change. So we can keep an eye and actually make sure that it's working. And so in case you've never used an influx database before, what you need to be aware of is something called line protocol. This is the text-based format that defines a metric, that defines like the data point that we're interested in, that's holding the temperature data. And in the most boiled down way of looking at it, it's just going to be a measurement name that describes the data point. And it's also going to have a key and value where the key is going to describe that value, and that value is going to be the temperature. So to help illustrate it, I've got this. So here we got this temperature report, and here's broken down as a line protocol, where I just call it tools temp, and then we have the hot end equals to 20 and build plate equals to 20. So 20 in this case is actually just the idle temperature. It's in Celsius, and 0 at 0 because the user hasn't set an actual target temperature. But then that would change to be like 200 or 50 or whatever the user sets it as. And now we're ready. So now you understand how line protocol works. Now we're ready to send it up over to the influx database. And there's actually multiple ways of doing this. And the most simplest way I want to start off with is showing that you can send it with a REST API. So here we're going to like concatenate a string to create the line protocol. Also a very crude way of doing it, I think. But we know what the structure looks like. We push it together. And now we can write it out to a body for order to send it to the REST API. And in order to send it to the REST API, you do need to have the influx database set up. And I won't go into detail exactly of how we need to do it, but it's written in Go, and you actually end up with a single binary that can be run in all of the popular operating systems. And there's more documentation online that you can look at of how that works. But you're also greeted with this wizard, which you'll need like 2 key bits of information. So I'm trying to make it like as simple as possible, where just like, this is open source project, you've started up, you get this wizard, and you need to come up with an organization name to define your workspace, and you need to define a bucket in order to have a named location where you're going to send this line protocol. And then, as I mentioned, we can just use REST API in order to accomplish that. So we just have this endpoint with that bucket name, with that organization, and this URL is like I'm running it locally. And all you need is an authorization token, make sure it's secure, and then you can just start sending your line protocol over to this influx database. So here we have another pre-recorded video of showing this in action. And what we're going to have is we're going to execute the program we just kind of described before, where it's going to be on a loop and a Go routine, kind of checking the temperature report every 2 seconds, and it'll be sending it over to the influx database. And then we're going to use the previous program to send some M104 and M140 commands in order to set the temperature of the build plate and the hot end. And here we've got to have it sped up, and you're going to see this gauge increasing and stopping once it's reached that designated temperature. And that's it. So with that, we've kind of already, and with that we've got, yeah, that kind of covers the entirety of the controlling your 3D printer, and also kind of touching the monitoring aspects as well. So, you know, because we're able to already move our components and heat them up properly, we are, you know, we also saw how we can monitor it. But let's now look at the more exciting bit of actually creating and preparing a 3D model, because that's the whole fun of a 3D printer, is you want that end result. You want that little plastic knick-knack to bring you comfort. So let's look at making an important 3D model. So how you go about doing it is, the obvious thing is you go onto the internet and find your perfect 3D model. And I've put some 2 links here of sites that I've used in the past. Good luck, because there's a lot of talented artists out there creating some amazing looking 3D models. But there are cases, of course, where you're going to give a GopherCon presentation and you're looking for like the perfect gopher that you want to present. So you have to create one yourself. And there's some tools that I'm familiar with, Blender and Tinkercad, that provide a user interface for you to craft yourself a 3D model of a gopher. And at the end of all this, you're going to end up with an STL file. This is the standard file format that gets shared. So if you go download something or you want to make one yourself, you want to end up with an STL file that will describe the geometry and your 3D object in a bunch of triangles. So there's actually a fun, so while using a user interface is exciting, it's even better if we get to use Go itself to create a 3D model. And I stumbled upon this amazing package called STFX that provides an API to define 3D objects using Go. And it does, and it outputs an STL file, exactly what we need to get in order to 3D print something. It uses some magic behind a hood called STF, which stands for signed distance functions. These are mathematical functions that describe primitive shapes like boxes and spheres. And with that, we can Frankenstein ourselves a beautiful gopher. So let's look at some practical, let's go ahead and start doing that. So what I want to do now is kind of show you a practical example of how we could build a gopher using the tool set available to us with STFX. So let's start very simple, defining a sphere of a radius of 45. So 45 is a number I just pulled out of midair, and when it showed rendered, it looked great, so I went with it. And then we call another function called renderSTL, and we can render this sphere into an STL file. And if you preview it, you end up with this sphere. And it's even already blue, so it already looks a lot like a gopher, but let's take it further. And what we can do is we can define more primitive shapes. And we need to take those primitive shapes and move them around and put them where they need to be in order to give that idea that it's a gopher. And so how this works, we have got this transform 3D method that takes in a matrix. And so if you're familiar with 3D modeling or working maybe perhaps with games, this stuff looks pretty familiar to you. But if you're not familiar with it, all you really need to do is define a vector that defines an X, Y, and Z, and provide some numbers in there to help define where those objects will live in the world space. And we'll be making use of this translate 3D and rotate 3D functions in the upcoming slides. So let's start with eyes. We can define a smaller sphere and then transform it and translate it to the correct location of these X, Y, and Z coordinates. And then we can add some pupils, and we can make use of another method called difference 3D to carve out a smaller sphere from those eyes to give that idea that we have pupils. And we end up with this beautiful shape where we have a gopher with 2 eyes. So let's look at another iconic feature of a gopher, and we can define some teeth by using a box 3D, so another primitive shape, as well as some spheres for the mouth and the nose. And then we move them around. Oh, and I forgot to mention earlier at the very bottom here, we also have the union 3D. So throughout this, you're going to be defining your shapes and you're going to be gluing it all onto the main sphere body. So that's like the whole thing that we're doing here. We're taking these primitive shapes and we're just slowly, like a clay model building up a gopher. And so we end up with this. So it's already looking very much like a gopher in my opinion. Like this has all the iconic features of one, but we can take it even further and we can add some arms. That provides a capsule 3D function as well. So we get kind of like a pill-shaped object. And we're going to be making use of the rotate 3D method calls here, where you're going to have to provide the vector of what axis you want to rotate at, and then also the degree of rotation. and then you'll need to move it to the correct location using the translate 3D methods. And with all that together, and you stick on, you can end up with 2 arms. So two pill-shaped arms, I thought looked very Gopher-like. And then we can take this pattern and build up on top of it and just keep it going. And you can end up with a full bona fide looking Gopher. So once you have this, he is almost ready for 3D printing. The only thing is he's very spherical. So if you want to end up trying to 3D print him, you're going to have to use something called supports, which are these extra structures around a Gopher, around a 3D print, our Gopher in this case, to help make sure that it's not 3D printing in air. But I've always had difficulty 3D printing very spherical shapes like this, where you're going to end up and during your 3D print, suddenly it's going to roll away because the supports aren't strong enough to hold it in place. So what I would like to do is let's cut off the bottom, a little bit of its bottom off, so that it has more adhesion to the build plate. So we can cut off, there's this cut 3D method, and then we can end up with this easier to 3D print Gopher. So he's going to be sitting on the build plate nice and secure, and he's now fully ready for 3D printing. But you're probably wondering, like, I went on and talked about G-code for quite a long time at the beginning, and now I'm talking about this STL file format. So an STL file format isn't actually G-code. It's a bunch of triangles describing geometry. And what
somebody will take this copy. Just come back in later.
By using a slicer, where you're going to have the beginning being the preparation of heating up the tools, and then you're going to have the middle part of actually moving around the components, and then at the end turning everything off. So you're going to have to be able to configure your slicer so that it actually uses the correct filament and it uses the correct temperature. And so you can end up all right, great. So now let's look at, so here we have a preview of showing the, of a slicer called Cura that can slice the STL. And this is what I was using to show the Gopher slowly coming up as we're adding bits and pieces to it. And you can use it to slice, and here it actually provides a preview screen of how it looks like sliced. And you can notice here we've got kind of like, almost looks like tears coming out of its eyes. And this is the support structure to keep its eyeballs in place while you're 3D printing it. And we kind of have this little GIF showing all the layers that it slices. So each of those layers is like described in G-code of how to print that layer. And you'll end up with this. So this is our programs. This is our Gopher's 3D model described as G-code. And you're going to have this majority middle code describing the movement of where the nozzle and the build plate's location, where everything needs to be, and some of that miscellaneous functions to heat up, and yeah, everything we saw before. So with this G-code, we are now ready to 3D print a Gopher. I did decide that while our very circular and spherical Gopher was, beautiful and perfect in its own way, I wanted to take it to the next level, and I used a tool that I was more familiar with, Blender, in order to give it a bit more of an hourglass shape and give it some other, tiny little detail changes. And also with the benefit that this model doesn't need any supports. I uploaded this model for free on this website, so if you want to 3D print this particular Gopher, you're welcome to. And yeah, so here we are. So we have now seen how we can control a 3D printer using Go, and now we have a Gopher we want to 3D print. So the next step is to go ahead and start 3D printing some Gophers. And then the final subject I want to cover is monitoring a 3D printer. So let's see what we need to actually do during a 3D print. So why would you want to monitor a 3D printer? 3D prints can take a very long time. So that Gopher I showed at the beginning of the slide took 6 hours to print. While in this more extreme example here, I 3D printed this life-size cave bear skull over the course of 6 days, where each part took about 2 days each. And yeah, so you can imagine during that time, I wasn't just sitting there watching my 3D printer, as exciting as that might be. And you need to be able, and it's very important then, during this 3D printing process, to be at a quick glance to know what is happening and to be able to do it remotely, so you don't have to be sitting next to your 3D printer the entire time. And some important things you want to monitor, like, is it done or not? Should I come in? Should I go to wherever your 3D printer might be and change it out and get the next print started? Or is the hardware all operating correctly? Is the temperatures all correct? Is there enough filament? And what layer is currently being printed as well. And that's an important one when you are dealing with supports and you're unsure if there's going to be an issue at like the meeting point between the support and the actual object, and making sure that things don't break down. So like, for example, this cave bear skull, I was concerned that the teeth might fall off. So I wanted to make sure that I was there at the correct layer. And so when you're talking about monitoring a 3D printer, if you use a 3D printer, you're most likely aware of this very popular open source tool called Octoprint. And it's amazing. It's a very feature-rich, it allows you to fully remotely control and monitor your 3D printer. And it comes with a very snappy web interface in order to watch it all happen. It's actually written in Python, so it's not in Go, so I won't be showing any of its source code, but it works very similar to what we went through previously in the beginning of this talk, where it connects to your 3D printer using G-code and over serial communication, and then it's going to be getting like temperature reports and sending it out to its dashboard, opposed to Influx data. And what we can do here is I want to make use of this very well implemented tool, and let's build up on top of it, because it provides a REST API, so it allows us to access all the data that it knows about and transform it. So what I want to do is, here we have a screenshot of the Octoprint's snappy web interface. And it's very useful. It has a lot of good information, but it's a little bit overwhelming. So I kind of wanted a custom dashboard where it just highlights exactly what I need. And that's where I want to use Go. So while we could have rewritten Octoprint entirely in Go, let's make use of this pre-existing tool and use some Go in order to scrape this data and send it over to the Influx data dashboard. And we can make use of a tool called Telegraph. So Telegraph is an open source project written in Go that I'm actually helping maintain as a full-time software engineer. And it's described as an agent for collecting or reporting metrics. So it can accept input data and output it to Influx database, very similar to kind of what we did in the monitoring the temperature project, but it makes it easier because it already has some functionality pre-implemented. It comes with a whole bunch of plugins, so it's kind of this plugin-based infrastructure of all of the functionality is segmented off into individual plugins. So it's kind of this batteries included situation where you have a single binary with a lot of functionality that gets enabled by configuring it using a TOML, which is this, it's a configuration language similar to YAML or JSON, if you have heard of those. And you can use that to configure it. So what I want to do now is I want to show a practical example of how you can monitor your 3D printer and then make use of Telegraph in order to do so. To give some more details about Telegraph, Telegraph works with plugins, as I mentioned, and there's 4 different categories. Input plugins, which are help you collect metrics from third-party APIs, such as Octoprint. There's also processor and aggregator plugins, which we won't be discussing, but they're there to help you transform metrics. And then there's output plugins to help you write out to various destinations, in our case, the Influx database. And then it kind of works in this flow here, input plugins to output plugins. Very basic, very straightforward. And now what I want to do is let's make our own plugin to work with Octoprint. And that's something I actually did already, and I already wrote an Octoprint plugin. But I kind of wanted to take you on a journey in a sense, and let's rewrite this plugin from scratch to show you exactly how it works, and we can build up on top of it. It's completely written in Go. It's a little bit unique in the sense of majority of plugins in Telegraph. It's an external plugin, and an external plugin works slightly differently. The fact that it is a separate binary that gets managed by Telegraph by using an internal plugin called execd. And here I kind of got a diagram illustrating what I'm talking about. We have this, this red box illustrating a separate binary, and it communicates with this execd plugin that knows how to talk with this binary, then, and that's managed by Telegraph. And what also here, another terminology that you'll be exposed to when talking with external plugins is Go shim. And the Go shim is a utility tool to help you build up a plugin, an external plugin. It allows you to make use of some internal Telegraph features, and it makes it seem like you're actually writing an internal Telegraph tool. And so yeah, this is where I kind of describe. So with Go shim, so if you're writing with Go, this is kind of just a utility to help you. So we're not going to be worrying about reading or writing from a TOML config. We're not going to be worrying about communicating with execd plugin. What I'm going to be focusing on is simply let's gather some data from the Octoprint plugin and making that work. And here's the data, here's the flowchart showing it working, where we're going to be focusing on this blue box. Let's make this Octoprint external plugin, which is going to gather from the REST API and gets managed by Telegraph and outputs to this swanky dashboard. So in order to make an input plugin, all you need to be worrying about is this interface, and you're going to be implementing a gather method that takes an accumulator structure. So this gather method is going to have all the functionality in it, and it's going to be called over at an interval by Telegraph. And this accumulator structure is what's going to be storing the line protocol. So instead of concatenating some strings, you're going to be using this structure in order to define these data points. There's also a sample config and a description. Those are just there as helper for describing what your plugin is all about. So we won't actually be looking at that because we already know. So here's the accumulator in action. It can add fields, and here it's the key and veal values where we have the name. And what we're concerned about here is the temperatures. And with the accumulator set up, the other important aspect is the actual, the user interface as far as your plugin is concerned, the TOML configuration. So you have to define a structure for this user input of data to get unmarshaled into. And in our case for Octoprint, we just need a URL and an API key in order to make our API calls. And so if you've never seen it before, it's just like these two brackets and then this key and value structure. Getting from the data from the REST API, I mean, it's a very basic and straightforward kind of implementation where you've probably seen how Go works with this before. We're calling this endpoint, unmarshalling into a printer state, for example, here, and same thing for the temperature data. And with that, you kind of end up with so this is actually everything you can end up with from the very basic Octoprint REST API. And luckily, Octoprint also provides plugins similar to Telegraph, and it can extend its functionality. And the community has provided these two other data endpoints, layer progress and filament management, that I want to quickly extend this Octoprint plugin with. And so yeah, so these, like filament manager is a really cool one to be able to actually find and use, because that's something that I've had issues with, where if you're 3D printing a very large object and you're concerned that you're going to suddenly run out of filament, this thing actually helps you keep track of it, so you don't have to keep, manually keep track of weighing your spool. This will actually take care of it. And in order to integrate that into our Octoprint plugin, you need to set up an external database. In this case, I set up a Postgres database, which also a lot better documentation out there than I can share with you now. But here's like a general example of this the user interface this plugin exposes in Octoprint that you can configure and register your filament spools into. And then here, this is a screenshot of how it looks like in the back end, where you got a bunch of filament spools and the weight and what it's going to be after printing. And then in the actual Go code, it's just going to be a SQL statement that you're going to call to select that information. And at the end, you're going to have this gather function that's going to be filled with this functionality where you're going to get the layer progress, the printing state, the temperature data, and the current filament data. And all of this is going to be pumped into the accumulator and send along the pipeline over to the influx data database where we can actually make some use out of it. Yeah, it's also important to mention, right, so we saw the configuration of the Telegraph plugin, the external plugin, and then you also need to configure the actual Telegraph binary to say where your external binary is and where that configuration is so that it knows to launch that as a daemon. Because the benefit of external plugins that I didn't mention before, so you don't actually have to write it in Go. You could write it in Rust if you wanted to, but I preferred using Go in this case. And then we need to configure the Influx database output plugin, and the Influx database dashboard comes with some very nice utilities in order to make that easy for you to help pre-generate it, and it will kind of look like this, some basic TOML configuration. And what we end up with is this demo flowchart here, where we've kind of extended it from the first one, where it's not just a REST API anymore. We're also reading from the plugins from Octoprint. And yeah, here's a quick preview of the dashboard, but let's see it in action of an actual time lapse of a Gopher being born. So here we have the dashboard being populated with the Octoprint external plugin being run, and we can see the state, and we're going to see right now the nozzle and build plate temperature being set, and the state's going to turn from operational to printing. And as soon as the temperature is correct, yeah, and then I've overlapped a video of the printer, of the Gopher slowly rising out of nothingness, and the layers increasing as it gets completed. And that, yeah, through the magic of video, that 6-hour print turned into 10 seconds. And if you see here, the remaining filament also decreased once it was done. And that's it. So yeah, we've printed a Gopher with Go. So that was broken down in 3 different steps and how you can do it. I hope you enjoyed this talk, and I'm hoping to see a whole lot more Gophers out in the wild. And that's it.
Thanks so much, Sebastian. That was really cool. And we don't see these talks beforehand. And Johnny is celebrating this talk in his own way as well.
He's been playing with them for the entire talk.
Yeah.
Until he mentioned Rust, then I was like, oh.
Well, yeah, I was happy to hear. He built it in Go, but I saw in there he built a Rust API.
I'm pretty sure it was a REST API.
I know, but that was for you because you're always so into Rust. So
I'm over Rust now. I think Nim, Zig
is where it's at.
I think that's where we're going.
Nim and Zig.
Fickle with the languages.
You really are. Yeah. What's it going to be next? We're going to go back to. There was a mention of Perl in the peanut gallery.
I did Perl years and years and years ago.
Yeah.
Back when you tried to write the most complicated program you could in a single line. In hindsight, it was a really bad idea.
The original elite code.
But there's actually some nostalgia here watching this, because a few years ago, do you remember the Cupid project?
Yes, I do.
So used Telegraph and Influx and did some hardware to build a PID controller for my barbecue, and all the thermometers for the meat and everything, built a whole Grafana dashboard. I mean, because we're engineers, you have to totally over-engineer every hobby.
Your cooking, your meat, engineer your meat.
Well, and that was what was interesting about this is, we don't see these talks beforehand, and so I was going in kind of expecting he's going to 3D print Gophers, great, but he did everything. He was building the model, he hooked Telegraph up, all this stuff was this all-encompassing 3D printing as a service thing. He could charge for this Rust API.
Here's another startup that now
it's
got created.
Someone else buy another domain for this, and we'll get funding. And
is this what's this domain?
Gophers? RustAPI.com. Should we do that?
Yeah. So we've got some more amazing sessions coming up. We've got more virtual meeting spaces coming up with some of our sponsors. We've got the Here's What Breaks My Bytes. We've got a Q&A with Course Heroes talent team. Makar's doing a Team Journey session. If you want to attend any of these, make sure you sign up on the GopherCon page. It's the only part of this that requires a ticket. We've got a Go Time session coming up later, which is an AMA with the Go team. There is a Go Team AMA channel in the Discord. Please drop questions in there that you have for the Go team. While you're at it, for Go Time sessions tomorrow is Gophers Say, which is a Family Feud style game where they will ask all of you, the Go community, questions, and the Go team will have to compete to guess what the most popular answers are, correct or incorrect.
Right.
Rust API.
And that's at gotime.fm/gs, right? For the
Gophers Say.
For the Gopher. Okay.
Yep. Indeed, indeed. Up next, we have Mark Bates doing another return. I was going to triumphant, but
I'm really glad that you're introducing this because I don't know whether I can stomach saying nice things about Mark 2 days in a row.
Mark, we love you.
Yeah, we really do love Mark. He puts in so much work.
He does.
The Lightning Talk sessions are so fantastic every year.
Yep, always a great opportunity to sort of, if you've never given a talk, a full-length talk like we've just seen and like we've been seeing over the last couple of days, a great way to sort of get your feet wet and get some feedback from the community as you do so. But obviously, you're going to have to wait till next year for that. For right now, we're going to have Mark Bates emceeing the whole Lightning Talks track. So, Mark, up to you, man.
Hello and welcome to GopherCon, Lightning Talks Day 2. It's so great to be here. I hope you enjoyed yesterday's Lightning Talks as much as I did. Like I said yesterday, this is such an honor and a privilege for me to be able to bring up these new voices and these new great ideas to all of you live as we're out there in the world. This is so much fun. I wish we could be together in person as always, but unfortunately these are the times we live in, and hopefully next year we all can do. But anyway, we have an incredible slate of speakers for you today, and I know I said that yesterday and I hope I delivered, and today I mean it again. Awesome speakers coming to us from around the world. We have so much to get to. Before we do that though, let's go over the rules of the games for all of our contestants. Each one of our speakers will have exactly 7 minutes to give their talk. That's right, 7 minutes. At the 1 minute mark, if they have not if they're still going, they will hear this sound. Wonderful. And if they go over their time, the curtains will literally close on them like this. There we go. So there we go. Those are the rules of our games. Unfortunately, we don't have the big hook like we usually do in person to pull people off stage, but we have the curtains and that's good enough. So with that said, let's start the show because you don't want to hear me speak. You want to hear these amazing speakers. So we're going to bring up our very first speaker of the day joining us here. Amit, are you with us?
Yeah. Hey, hi. How are you?
Good. And yourself?
Yeah, I'm doing good. Can't complain. It's raining here in LA.
Oh, you're in LA right now. So there you go.
Yeah.
That answers the question of where you're joining us from. It's an unusual event to have that rain in LA. So try and enjoy it. Go sing in it later. I hear that's fun.
Yeah. I see.
So with that said, Amit, why don't you take it away? Love to hear from you.
Yeah, sure. Hello, everyone. This is Amit Mishra here. Today, I'm going to talk about some patterns which we found useful while building our replay platform. Let's go over motivation behind this talk. Basically, here at Fox, my team and me are responsible for building a platform or taking care of the platform, which helps to serve live and VOD contents to millions of concurrent users. And as you guys know, like serving live content has its own challenges because of the unpredictable nature of the traffic and overall audience itself. And our platform basically helps to serve events like Super Bowl, WWE, pay-per-view fights, and various Fox entertainment related shows. In order to basically handle various challenges, we planned to rebuild our whole platform using Golang. And the reason behind was like because our legacy Node.js based platform was very tightly coupled application, and it was very hard to scale, and it had very high dependency on its external services without any fail forward strategy or caching kind of strategy. But due to simplicity of the Golang and power of concurrency, we are in process of migrating our whole platform into Golang, and we are already seeing some good results. And based on those good results, we discovered a couple of patterns which are very easy to implement in Golang, and I wanted to share with you all. agenda. Well, let's talk. Let's dive into first pattern. The first pattern is like thinking about a true microservices. Since we had this whole monolithic system, we had 20 to 30 internal, Node.js modules. We wanted to come up with a strategy where we can divide these services into true microservices, and we basically came up with a strategy of dividing those into using 3 different criteria. The first one is like, okay, what are your dependency on the external services? Second one is like, okay, even if we had the legacy services and we could not migrate those into Golang, how do we deal with those? So we probably build a Golang based proxy around those kind of services. So that was our second criteria. The third and the very common criteria which we use normally is like, building the services based on dedicated data stores like Elasticsearch or DynamoDB or, anything else which is suitable for your project. The second pattern was like a strategy to migrate the legacy services itself. Like since we decided to build all these services into Golang, but we cannot just go. We could not just migrate those in one shot. We could not afford any kind of downtime. So we had to come up with some kind of a strategy where we can still build these services and go live with these services without any downtime. And this is how we started. We had this start state where we had a legacy kind of playback services, which was serving to the clients. The first thing we started doing is like start building the proxy services around those legacy services. And these proxy services were based on the Golang. And you will be surprised to hear that just by putting the Golang proxy gave us so much performance boost without doing any optimization. These proxies were just taking the same request and response. It was just passing to the client, but that itself gave us, good flexibility. And the second step we followed was like, okay, once we had the proxy, we started swapping out our legacy playback services using new Golang-based playback services, and we started doing some comparative testing. And once we had some good confidence on the comparative testing, we basically implemented a feature flag, and which we can turn on, turn off based on what we needed. And then once we had that whole thing implemented, we could just rely on new playback services, which was based on the Golang. That was very pretty much a useful pattern we've found ourselves using in all over the stack. So hopefully it will be useful for you guys too. The third pattern and the most important pattern was the circuit breaker pattern. Basically, circuit breaker pattern and microservice word you might know that it's very common pattern which basically allows to build you fault tolerant and resilience kind of services which can survive graceful degradation. The purpose of the circuit breaker pattern is basically to detect the availability of the underlying services which caller services are depending on, or any kind of service failure. And we in order to implement these services, we basically use Golang, because implementing these kind of pattern was very simple in Golang. And one of the thing we used was like the Hystrix Golang library, which is of course based on the Netflix Hystrix. But this is how our configuration looked like, which had various control over like a maximum concurrency, timeout, and all those kind of things. And based on the circuit breaker pattern, we could implement our monitoring dashboard, which was which gave us like a clear view about, okay, what's going on with our external services, which previously we were not able to control, but now we are able to understand that if those are responding slow or what's going on. And based on that, we could open and close the circuit and serve the fail forward kind of scenarios, or fail forward kind of responses. The fourth pattern was like the strategic caching. Since I explained that during the live environment, caching contents is very hard. And for that, we had to come up with a good strategic, good caching system. And we built our whole caching system using Golang. And it's one of the most performing platform in our whole system. And the Golang provided us the flexibility to build the features like leaky bucket cache, where the kind of like keep or cache warm, and the similarly stale cache. The fifth pattern was the single flight pattern. In single flight pattern, you will find this is the most useful pattern when you're trying to deal with the thundering herd kind of problem. It basically helps you to suppress all the duplicate function calls, and we use this Golang single flight. And here are the results we could achieve. That we have infinitely a scalable platform, and this is how it looked like previously. Our Node.js response was like way more than what we have in Golang. And similarly, we could save lots of cost, and we are able to serve our current NFL event, which is going on, and hopefully we are going to planning for the 2023 Super Bowl. This is our roadmap looks like for the Super Bowl. Like, we are planning to serve at least 20 millions of concurrent users, and then moving everything into Golang, and then
Well, thank you, Amit. That was a wonderful talk. And good luck in the Super Bowl. I know I'm rooting for the Red Sox to win the Super Bowl this year. They're amazing skaters. Anyway, let's bring up our next speaker, Asdine. Are you there?
Yes, I'm there. Hi, how are you?
Good, and yourself? Where are you coming to us from?
I'm on holidays in India right now.
India? Nice. Must be getting late there.
Yeah.
I can only imagine. Well, I'm not going to keep you up too much longer. Why don't you take it away so you can go to bed?
All right. Hi, I'm Asdine Arish. I'm a software engineer at Sourcegraph, and today I'm going to talk about my side project, which is Genji. Genji is an embedded database. It combines SQL with documents, and it's written in Go. So documents here are just any structured data, which could be flat or nested, and it's not limited to JSON type. In fact, Genji is not a JSON database. It's document fields are actually SQL types like ints, double, text, blobs, and so on. Genji took a different approach when it comes to SQL. Instead of implementing the SQL standard, we decided to treat documents as first-class citizens. So the SQL API is completely designed to take them into account, to deal with missing fields and type mismatch between documents, etc. So there's no JSON column type. There's no column, concept of column. There are paths, which are very familiar if you look at these. And you have the choice between creating tables with schemaless tables or with schemas. And the schemas will allow you to control all the fields you care about. It's a general purpose database. You can use it for application data, for caching in memory or on disk, exploring data you don't know much about. You can use it on small devices, on the web. Well, it's still experimental, but that's the goal. And you can store encrypted data on disk. So creating a table with a schema looks like this. It's pretty much the same as any other relational database. The main difference on the left, you can see that we are using paths instead of just columns. So you can see on line 18 that we are applying a constraint on the author name. And we also imply that author is a nested document, and it will be inferred automatically by the database. We can, as I said, use the constraint, any constraints we want, and we can also create indexes on either the fields we defined above or other fields that are not defined here. This is very important. Schemas in Genji only apply to what you care about, and the rest will be stored with the default conversion. We can also create a schemaless database, as I said, by simply writing create table and the name of the table, and we'll be able to store anything. This could be very useful when we want flexibility or we already know the shape of the data we are storing. So as an example, let's just consume the GitHub API and search issues from the Golang repository. So here's an example of a response from calling the GitHub API. So it's just a list of big JSON documents. So we start with creating a table called issue, and we would not define a schema for a constraint for all the fields. we know that there will not be changing because we're consuming the GitHub API in this case. And we are mostly interested in data exploration in this case. So all we want is to use the ID of each document and use it as the primary key and make sure that it is an integer. Then we can create a structure or use one from the GitHub client library or whatever, just to unmarshal that JSON data into a Go structure. Then we can insert it by using insert into issue. And this one is let's say, the classic way of inserting data. We define a bunch of fields here, ID, URL, etc., and we just pass the values one by one. We can do better by just writing this, insert into issue values, and then we pass the complete variable. And Genji will use a little bit of reflection magic, not too much, to transform that structure into a document and then insert it and validate it if we defined any constraints. This is not implemented yet, but this is like a goal to be able to just specify the URL in place of the table, and the library will just go and fetch the data. I'm not sure it will support pagination, but gotta try it. Then once we fill the table with documents, we can query it. This is the Genji API. You can use the query method to count the number of issues per user in the Go 119 milestone. And as you can see, we're using paths here, like where milestone.title equals Go 119. And yeah, we can use them in the group by in any classic SQL clause. It's pretty straightforward. We can, the query method returns a stream, and then we can iterate over the stream and just scan each document into the variable of our choice. In terms of features, we have update, delete, etc., and we are adding more and more. Joins are totally planned, not yet implemented at all, but we're getting there. We have ACID transactions. So this is a document database, but it has all of the guarantees that you can have with, let's say, SQLite, for example. So you have a single writer, concurrent writer, and multiple concurrent readers, and it's compatible with the database SQL package. It's written 100% in Go, so no CGO required. On the lower level, we are using an engine system. So we have 3 implementations. The first one is memory. So you can create an in-memory database with that. We're using the Google B3 library. And on disk, we have 2 flavors. One is Bolt.
Wow, thank you very much. That was an excellent talk. Some really interesting stuff there. I know I'm always looking for a good embedded SQL database, so I'm gonna have to give that a try out. So let's bring up our next speaker, Sean. Sean, are you with us?
Indeed I am. How you doing there, Mark?
All right, and yourself?
Yeah, good. I'm in sunny London. I mean, it's not sunny, it's winter and it's nighttime, but it could be sunny London, you know. It's if we say it off, nothing else comes true.
You do get those 2 or 3 days in August that really just make the rest of the year worthwhile.
Yeah, we call that summer. That's all of it. You know, the rest of it.
Yeah.
You know, there's.
I've been there once.
You know,
I've been there once in hot summer. It's lovely. Anyway, why don't you? Let's hear what you have to say there, Sean. Take it away.
Wonderful, thank you. So hi everyone, I'm Sean. I'm the Senior Developer Advocate for the UK and Ireland at AWS. And I don't know about you, but I've seen a lot of slide text over the last couple of years. So today, I'm just going to talk just between you and I, but make it a bit more personal. So as a developer advocate, I spend a lot of time writing content and building demos to show off all the super cool stuff we build here for you at AWS. And with that in mind, whenever I put together a workshop or product, I like to include just a little bit of magic, just making things work as seamlessly or invisibly as possible so developers such as yourself can just enjoy what you're building rather than spending time fighting with bugs or struggling to figure out instructions. And this year at reInvent, which is our premier learning conference that we run for the global cloud computing community, I was involved in writing a workshop about migrations, getting your stack from wherever it is now up to AWS. And that would seem like a fairly straightforward proposition, right? Take thing in place A and put it in place B. Well, no. Anyone who's ever worked on a large-scale migration will tell you that it takes a whole bunch of planning, testing, and coordination to get something from place A to place B. And no two strategies are the same. There's almost incalculable number of AWS services and combinations of them that you can use to deploy your applications to. So how, when you're running these workshops, do you cover all the different use cases for as many people as possible without writing dozens or hundreds of specific niche workshops? Well, with a little bit of Go-powered magic, of course. See, first of all, when we were thinking about putting this workshop together, we needed a demo application that people could migrate from place A to place B. And we didn't want people to have to deal with example applications that would require installing dependencies and having to keep tracks of files across multiple locations. So things like Node.js with its Node modules or Python with pip, they're out. That's not part of the migration. That's a detail of the language. So having a single compiled binary was perfect for us. So Go was a very early, obvious choice. That said, having a server be a compiled binary doesn't completely help solve that if we have to deliver a directory of static assets that we want to serve through the application. So we wanted to build a HTTP server to demonstrate these things. So we just want one file, one application that has it all. So how do we achieve that? Well, there's this great module called go-bin data, which can take a directory and recursively convert the files therein to byte slices. And that means that all of our static assets are now built into the compiled binary, and we can serve them from memory when the app is deployed. And so that's that. One tiny little magic app that you can pick up and deploy without having to worry about assets. But here's the rub. I mentioned we have a bunch of services that you can deploy applications to, and we planned to cover more than a couple of them in our workshop. You see, each service has its nuance and specificalities when it comes to running an application. So what works for one service out of the box may not work for the rest. Think Lambda versus EC2. It's a whole different mindset. And we're going to need an app that can detect where it is and behave appropriately instead of just firing up and hoping that it'll work. Now, it's easy enough to build something that goes, ta-da, you deployed me, well done you, woo! But that feels like a missed opportunity. We wanted to build something that not only tell you that you've done something right, but it will give you more information about what you had done. So how do we go about that? How do we build one app to rule them all and not immediately fall over when we hit an edge case? Well, that takes a little doing, but we figured it out. See, some services in AWS are kind enough to tell you when you're executing in their environment. Take Lambda and Fargate with ECS, for example. They set environment variables that you can look up and use to change things accordingly. Other services, however, like EC2, are a little bit trickier. See, EC2 doesn't set such an environment variable, but it does have the metadata service. And so the metadata service is an API which exists on your EC2 instances that you can query to find out information about the instance that you're running on. Things like instance name, public IP address, the AMI ID that was used to launch the instance. And so that's what we decided to do. First of all, we would check the environment variables to see if there were any services that we would recognize. If not, we then check for the presence of the metadata service by making a quick HTTP request. If the metadata service was there, we then do a follow-up request to get the instance type and check it was a valid value, rather than risk delivering a false positive to our users. So with environment variables and the metadata service, we've managed to cover our serverless platform, some of our container platforms, and EC2. And that's not everything, but it's a fairly big coverage of all the options we have to offer. But let's talk about Lambda. So you see, so far, our little magic application is a self-contained HTTP server, which, while very cool, isn't exactly the best thing to be serving up in a Lambda function. Lambda functions only run for the time that they're needed. So having an always-on, always-listening server makes no sense. So how do we get this thing to serve all the other use cases, but also feel at home in a serverless environment without bringing a load of bloat with it? And that's obvious, right? We make it create a new version of itself, specifically for Lambda. That's right. Our app can make a new version of itself prepared specifically for serverless environments. So how does that work? Well, if you think back, everything we need, all we need to do now is rearrange it. So if our workshop attendees hit the Lambda section of our Magic App webpage, we take all those dynamically generated views and render them for hosting from a secure S3 bucket. Then our code writes a new version of itself, which admittedly is in JavaScript. Sorry, everybody. That will let Lambda serve those assets from the S3 bucket out through an API gateway endpoint. And this all then gets put together in a zip archive, which is dynamically created and then sent as an octet stream to the requester. And all that can be done with just the click of a mouse. And that's it. That's how you build a Magic App that knows where it is in AWS, changes how it acts depending on where it is, and even creates a new version of itself if it needs to. All in one handy, Go compiled executable package. I've been Sean Tracy. Thank you for your time. I'm big on feedback, so I believe there is going to be a link put in Discord any second now where you can tell me how I've done and let me know if you'd like to know anything more. So please do that. Other than that, have fun. Thank you.
Thank you, Sean. Make sure you get that sheet on the bed before the missus notices that it's gone. Okay. No, that was an excellent talk and very brave without any slides as well. I appreciate that. Let's bring up our next speaker. Christopher, you there?
I am here.
Fantastic. How you doing, Christopher?
I'm doing great. How are you?
Good, good, good. Christopher is one of my students this semester in my Intro to Go course. So it's always great to see my students coming through. So, of course, you are getting graded on this. So there's no pressure at all. At all, Christopher. Where are you joining us from?
I'm in North Carolina.
North Carolina. Awesome. Well, take it away. Good luck.
All right. So today I'm going to be talking on a bit of a less technical, softer topic, but it's scratching your own itch using Go and XBAR. One of the reasons I'm talking about it is because building tools for yourself is rewarding and it's also helpful. I'm not going to be getting deep into the details of XBAR, but their documentation is fairly strong, and I will describe the pieces that I show. So to start off, let's talk about why you're here. You initially probably decided to pick up Go, learn a little bit more about it, and you go the normal routes, read the books, all of the books, and now you're probably closer to a Go reference document or a scholar on the topic, but you may not actually be able to implement things yet. You just know about them out of context. You've watched video tutorials, and now you are fully capable of making the world's best to-do list or Hello World web server. And you've probably read a lot of the written tutorials that are online. You've become extremely good at following line-by-line instructions, and your touch typing skills have much improved. But all jokes aside, all these resources are really great, and especially when you're getting started, it's a really great way to go. The people giving their time to create them do sacrifice their own personal time, and it's what makes the community so special. So having all these available allows people to learn. Everyone learns in different ways, and usually a combination of many. And then as you go, you need different things on top of that. So all of these provide a lot of different resources. So what I'm talking about today, if this sounds similar to you, is the plateau that you tend to hit after you've gotten through these and you're trying to move over to the next stage of getting prepared to start looking at entry-level positions or things like that. And a lot of what you hear is, we'll build things. Okay, so build things, but what do I build? And how do I decide what direction to take it? And that's where XBAR comes in my opinion. What it is it's a application built by Matt Ryer that allows you to build and script things that appear in the Mac OS menu bar. It originally started off as Bitbar, made the top of Hacker News. And if you want to know more about the details, I know Matt has given a couple of talks and a lot of podcast interviews where he touches on it. He even says, this is an example from the site, and this is his quote on it. So from there, why XBAR? Well, the nice thing about XBAR is that it allows you to write these Go programs. You can do it compiled or scripted. And I'm just going to talk mainly about the compiled today. The scripted stuff, there's a couple of bugs. related to writing Go in a script format. But it allows you to have an immediate feedback loop. You're going to be writing things that you are taking in as the user of. And so essentially you're dog fooding the code that you're writing, and you're going to be the best criticizer of that. And it hurts less when you're the critic of yourself. As an example, if you've ever looked at a line of code you've written, not knowing it was yours and asking who the heck wrote this, and then you type in git blame and realize it was you, it hurts a lot less than someone else giving you a hard time. So to get started quickly, you go to the docs on Xbar, you dutifully and academically pour through all of the details, or you just scan it quickly, find the piece you need, and start building things. And pay for it later when you get stuck. But the basics of it are this. You just print line out of your script, and it formats into this menu bar application. So the place that you start, obviously, would be just mapping the code, basic print line statements, to kind of see how this transfers into the output of the application. And here I have some more examples. As you go further down, these lines are just examples of different options that you have to try and play with different features in the application. This piece right here essentially gave me this in my menu bar. So it was just me testing how different things fall into place. The next step after this is clearly mischief. As developers, we tend to have the natural ability to want to use things in ways that they are not meant to be used and just see what's available. So this is an example. I just wanted to see if I stacked as much stuff as I could in the top part that was going to come out in the menu bar, what would happen? Would it overload the menu bar? Actually, no, it wouldn't. It animates through the items based on what's there, which is actually a really nice thing. Doing this, you kind of go through discovery. You figure and feel out how things work with this application. In this case, it would be a 30-second loop. Every one of these top 3 items would rotate every 10 seconds. So from here, the next stage would be free will. This is the point where you have the basics of the tool, and this is the part that's most important. You're going to have problems that you want to solve, and they're not going to be designated on, I want to learn A, B, and C. They're going to be designated on, I want to solve this problem. And what that's going to allow you to do is shove yourself into places that you're not comfortable with. It's going to allow you to come across things that are going to teach you why certain things are idiomatic in Go. And it's going to force you to learn reference documentation, reference the language. So this is what I did. And parting thoughts, a personal example is Jira. We've all been there. It's not a bad tool, but sometimes, hypothetically, you work at a place that has a process that sounds like it's agile, mixed with waterfall, mixed with a 5-lane traffic jam, and a dumpster fire in the middle. But you need to make it work. So what you do is you build a tool that scrapes through the API, puts things in a neater format of how you can work with them, keeping the business happy because you're still accomplishing things, and allowing you to deliver on products as well. So then these are an example of a tool you would build. So the pieces are all in there. There's environment variables, there's API calls, calls up to shell, HTTP links, and on and on. And also, if you get bored from that, you can move over to Whales, which is what Xbar is built on. It allows you to build full applications. And at the end of it all, you get to learn. I wanted just to say thanks to Matt and Lee Anthony and all the open.
Thank you, Christopher. That was excellent. I particularly loved when you almost attributed Xbar to me. I'm sure Matt will love that. Nice little Mark Matt Freudian slip there. So thank you very much for that. I truly enjoyed that. Let's bring up the next guest here. I believe we have Varun with us next.
Hello.
Hey, Varun, how are you doing?
I'm doing great. Yeah,
excellent. Where are you joining us from? I'm doing great. It's GopherCon. It's GopherCon. Who doesn't
Yeah, I'm
love
joining from
GopherCon?
Mumbai. Yeah.
Mumbai. Oh, from wow.
Yeah.
So from quite a way. So it's also even
midnight.
later for you than it was for a bit. Nice. Have you ever been to a GopherCon before?
No, this is my first GopherCon, so I'm really excited to be here.
Welcome. Well, hopefully you get to join us in person. They're super cool in person. I mean, this is cool, super cooler in person, trust me. Anyway, you are going to be talking about better understanding of errors, right? Fantastic.
Yeah.
We all need to understand our errors better. So take it away. Let's hear from you, Varun.
Hey everyone, I'm Varun Gandhi. I work as a software engineer at SourceGraph. I've only been writing Go for about 6 weeks now, after working in C++ for about 2.5 years. Given that, the compiler complains about my code quite a bit. So today, I want to share my favorite tip for better understanding compiler error messages, which is by reading the Go spec. So what is the Go spec? It is a document describing the syntax and semantics of Go code. Syntax covers things like keywords, punctuation, and so on. Semantics covers type checking and the runtime behavior of code. Unlike some other language specs, such as that for C++, the Go spec is quite accessible. If you're not sure why some code does or does not lead to a compiler error, then consulting the spec is a good way to understand the details. Let me illustrate with a couple of simplified examples based on actual errors I was having trouble understanding. Consider the following example code. I've declared a struct x with a single string field s, and I'm trying to get a pointer to the field in various ways in the function f. Which of these lines do you think will result in a compiler error? I will wait for 10 seconds in case you want to think about it before I reveal the answer. Turns out the fourth line in the function will give an error, but the other lines are okay. For the fourth line, the compiler complains that you can't take the address of i.x.s, but it doesn't say why you can't do that. Clearly, there's some reason why taking the address is allowed on the second and third lines, but not on the fourth line. Let's take a look at the spec to understand this better. In the Go spec, there's a section called Address Operators, which covers this. I've slightly tweaked the wording in that section and shown it here. According to the spec, the address of x is only well defined if x falls into one of the 5 cases described here. It's a variable, a pointer, a field access, or a slice or array indexing operation. Let me remove those last 2, since those won't be relevant for us. Now let's see how this definition applies to the code example from before. The relevant case is the field selector one, since in all 3 cases, we're trying to take the address of a field. So what exactly is the addressable struct operand part? We can answer that recursively by examining the definition of addressable again. Temp is addressable because it is a variable. Hence, temp.s is the field selector of an addressable struct operand, and it too is addressable. i.x is a pointer in direction, hence it is addressable. Hence, i.x.s is also addressable because it is the field selector of an addressable struct operand. However, in the last case, i.x is neither a variable nor a pointer nor a field selector. Since it doesn't match any of the cases, we're forced to conclude that i.x is not addressable. Hence, i.x.s is also not addressable. That's why the compiler gave us an error for the last case, stating that we couldn't take the address of i.x.s. Okay, that's a lot, but now let's move on to a different example. Here's a trick question. Does Go have implicit conversions where it would convert a value of one type to a value of a different type without an explicit cast operation? If you ask the search engine, it might give you a confident result, saying that Go doesn't really have implicit conversions. Again, this is an example where consulting the specification is valuable. Let's consider some code as shown here. I have 2 custom types, A and B, which are wrappers over a struct and string respectively. I take a value of the custom type and try to return it as a different type, first for A and then for B. Take 10 seconds. Which of these do you think will work? Turns out the first function works and the second function doesn't. The compiler tells us that you can't use B as type string, but it's not clear why the example with A works, but the example with B doesn't. They seem pretty similar, right? Again, let's look at the spec to see if it can help us better understand what's going on here. In this case, since the error is in type checking a return statement, let's look at that section. According to the section on return statements, the condition that applies here is that the return value must be assignable to the function's result type. Assignable here is a key term that is defined in the spec. Let's look at its definition. There are many different cases for when some variable is assignable to a type T, but the case that is relevant here is the one that talks about identical underlying types. Here, underlying type and defined types are also terms which are defined in the spec. I'm not going to show you their definitions because there's only so much space on the slide, but I will explain them in context as we go along. Let's look at how this applies to the first code example from before. For the example of the single element struct, the underlying type of A is the single element struct type, and the struct's underlying type is itself. You can think of the underlying type as what's on the right-hand side of a definition for types which are defined with type declarations. So V and T will have identical underlying types, and the first condition is satisfied. If we look at the second condition, A is a defined type, but according to the spec, an anonymous struct type is not a defined type because there's no type declaration for it. Hence, the second condition. Let's look at the second example. The underlying type of B is string, and string's underlying type is itself. So again, the first condition is satisfied. However, according to the spec, both B and string are defined types, so the second condition is not satisfied. And that's why we got that compiler error. I just want to leave you with a couple of closing thoughts. If a compiler error doesn't make sense, your first instinct may be to use Google or Stack Overflow. To that list, consider adding the spec as well, because if you put in a little bit of extra work, you'll get a much more authoritative answer. Second, sometimes reading the spec can help you understand the different cases in the language, which you hadn't considered before. Thanks for your time. If you want to learn about how SourceGraph can help you understand your code faster, check out this QR code. And if you're passionate about spreading code literacy, join our community space. I look forward to speaking with all of you in Discord or on Twitter. Thanks.
Well, thank you, Varun. That was fantastic. I really enjoyed that talk very much. And agree, you should read the Go spec. It does hold most of the answers. So definitely great advice on reading that spec. So with that said, we have time for one more excellent speaker here. I mean, it's been just an amazing slate of speakers, like I said. So let's bring up our next speaker. Kevin, are you with us?
Hello.
Hey, Kevin, can you hear me?
Yes, I can.
Fantastic. And where are you joining us from?
I'm joining you from Uganda. Kampala.
From Uganda. Okay.
Exotic locations.
Fantastic. Okay, well, why don't you take it away here? I'd love to hear from you. Go for it.
Okay, so I'm Kevin. I've been a software developer for a couple of years. I'm new to Go, actually. This is my first year of using Go, tinkering with it. I did a small workshop earlier that really made me fall in love with the language, the simplicity, and the way it's used, and generally the community also. Today I wanted to talk about making an image recognition application that could determine the age of a bean plant. Since we can use machine learning models to extract information from images, I was thinking that I could just build a small app that would get, let me say, size information from the length of the leaf or something, and then I could determine how long that plant has been up. That was my original plan, and then I ended up discovering that that was not going to be so simple, and there's a lot of technical debt and technical understanding that goes into trying to create something like this. So today I wanted to instead to highlight some of the issues or the technologies that a person would have to focus on if trying to develop, say, an image recognition application, so that I can help also other beginner users actually get something done instead of spending all of their time researching different issues. So instead of sharing a slide, I'll be sharing an article that I landed on that I feel covers all of the technical issues that one would face in the process. Let me start with sharing the TensorFlow guides themselves. Anyone who has tried to look through the documentation for TensorFlow has seen that the Go bindings are extremely difficult to understand and to interpret in a quick sense. it's not easy for someone to just pick up the technology and let me say add the adapters and use them to create to process the information. Yes, because when you start in this process, you imagine you're just going to build them say as an API service that will receive information, pass that information, like pass the image information, and then return that. The article that I landed on that helped me outline this entire process is API building an API recognition with Go and TensorFlow by Tim Rabzej. I don't want to. I hope I'm not saying that so badly. In the basic sense, we're going to look at getting the image, the response. Okay, let me say the request response, passing the data, and feeding the tensor model to the machine learning model, and then returning some output. One of the first technologies that the person has to understand before even they dive into this is Docker, because since you're going to be running machine learning models, you're going to have to run some sort of orchestrated container to host both the application and the machine models that you're going to be running. So here he easily quickly describes the Docker compose file and load some TensorFlow. I'm not going to dive into details because it's a limited talk, and the more I looked into it, the more I realized that I cannot go into depth about some of the concepts that I wanted to cover. He extracts the Docker-long image from the official repository, and then let's dive into the necessary packages for Go. Here I also want to take a side note to outline that I feel there's a steep, okay, not a steep, but there's a learning curve involved before you work with anything that is machine learning related. It's not plug and play like you'd imagine with many libraries. As a software developer, we get used, I think we get accustomed to being able to look into something, pick up a new technology, research it a bit, and then start tinkering around. The first, after the step of learning Docker, the next step you have to go to is learning how to implement machine learning models. So what you get from a model usually is a graph that understands the image layers of the data, and then a list of labels that is used for the output to give you the response of what you're looking for and what is going to be predicted from the image layers. Let me dive directly into the model here. When you load the model here, you can see that an understanding of Go is not enough to be to develop this. That is quick. You have to get the image response, pass that to the model through the handler from your server, the HTTP server, and then send back the bytecode, the byte response. Images are another obstacle that you realize when working with images is that they do not allow you to add the data directly. You usually have to undergo some sort of transformation such that the machine learning model can understand the kind of data you're trying to feed it. I'll look at that here. I don't really think there's enough.
Well, thank you, Kevin. That was wonderful. Now, look, I know I said Kevin was going to be our last speaker. But you know me. I don't play by anybody's rules. I'm Mark Bates. I'm going to give you one more talk. What? That's right, one more talk. Let's bring up Arun and Yankee. Arun, Yankee, how are you two doing?
Very well.
Yeah, doing
We are
great.
ready to go.
Great. And you're Arun. Where are you joining us from?
I'm coming from Berlin. We had our first proper day of snowing, so Christmas is on the way.
Fantastic. And Yankee, where are you coming from?
I'm from Kathmandu, Nepal. So it's currently midnight.
Fantastic.
Excited to join GopherCon. Yeah.
I'm excited to hear what the two of you have to say. So take it away. Go for it.
Yeah. Hi, everyone. So, if we could map out Go, we are here today in order to expand that map a little bit by introducing you to the community of Go developers from the Himalayan country of Nepal. So let's go to Nepal. So for anybody that doesn't know where exactly Nepal is, if you see this map and you can spot the gopher, then you found Nepal. So Go Nepal is a small but a growing community. We are roughly, reaching the target of roughly around 200 developers and more at the moment. We started with 2019. I'm actually very new to it, but that's the reason why we have Yankee here in order to give you a bit more insight on that. And before we get into the meat of it, we want to introduce you to our gopher as well, the one that you see right over there wearing the Nepali topi and the Daura Surwal, which is our national dress. So that's our mascot. So let me introduce Yankee.
Yeah, Yankee from Postpay, basically. Yep.
And we also wanted to make sure that we included Milap Nopane, who is also from Go Nepal team. He's one of the early founders, so we wanted to make sure that he was put on the slide because he's provided us with a lot of information. So Yankee, why don't you cover us on how things are going with the state of Go in Nepal at the moment?
Yeah, so like Aaron mentioned, Go is like pretty popular here in Nepal. So in our Go community, we have a lot of early adapters since the early days of Go. We have a lot of CS students who are like coming into our meetups, learning new things. And we also have a professional crowd of software developers, and it's pretty popular among DevOps in Nepal as well. So what is Go used for? Mostly for internal tools and open source contributions. So we have a huge pool of people contributing to open source projects in the CNCF space. So that's pretty cool. And we have a lot of enthusiasts doing a lot of cool things with Go. And on the right, you can see the screenshot of one of our meetups where we had the privilege of having Bill Kennedy to talk about the generics in Go. So having said that, let's go to the next slide and look at our past events. So we have had a great track record when it comes to our events. We have the likes of Bill Kennedy, and we have Isan Mukherjee and Zain Askar talking about Pixie. If you are into the Kubernetes space and for observability stuffs, like Pixie is great. And yeah, although we have been in this space for a pretty short time, but we have had great leaders from the Go community come to our community, expand it, make it more knowledgeable. And yeah, it's pretty exciting. Next. So our experience so far, for every growing community, you need a positive feedback loop. So the first point talks about virtuous cycle, where we have like enthusiast people in the community who inspires the next generation, and the same cycle repeats so that we have a budding and thriving community of Go developers. And also one of the experiences we have had on our meetups is like market needs sometimes expects personal drive. So, this is pre-pandemic, so maybe next year when we come, things might change. But yeah, the Nepali market is used for JavaScript developers, so the Go is like on the rise, I would say. But since international companies are opening up for jobs, so it's going to be a different scene next year. And also we need more push for open source software, although I have mentioned like there are a lot of contributors, but I think it's not enough, right? So that's where you guys come in. Next slide, please. Yeah, so that was our community, and we invite you to join us. If you want to showcase your tools and techniques, if you want to talk about design patterns, if you want to talk about industry standards, or some open source projects you are like passionate about, you're contributing to, or you're founder of. So we will be pleased to have you in our community. We will provide you the platform. We have a very thriving audience that is seeking to get the knowledge out of all of this. So yeah, if you want to join our community, we have the meetup link down below. So you can just go to that link and be part of it, and we can talk, join the discussion, what we can do together as a community for the community. Yeah, Arun, you're up.
For me, I'm also a beginner myself, and I'm only starting with my Go journey now. But to be able to have the representation for Go Nepal here with GopherCon for the first time, it's absolutely great. We really want to thank GopherCon, and especially thank Mark Bates, because of his lightning talks. A small voices just like ours has a chance to just come out to the big worldwide space. So we thank Mark, we thank GopherCon, and hopefully the next time you are going to be seeing us is actually going to be in an event that is organized by Go Nepal. So we are there. We are trying to get out there as well, and we look forward to you in our next events. Thank you again, and Dhanyavad, which actually means thank you in Nepali. So that was us, and we hope to see you next time.
Thank you, fellas. I really appreciate that. Speakers, please hit them up for talks. I'm sure, like all good meetups, they're looking for great talks. And I know I'm very excited to someday be flown business class to Nepal to speak at GopherCon Nepal when they have it. With that said, that's all we have for time for today. We got a great lineup of 8 talks tomorrow. Join us at the same time. And we're going to throw it back to the studio for more great content.
Thanks so much, Mark Bates, and all of the presenters for the Lightning Talks today and yesterday, and those that'll present tomorrow. The Lightning Talks are such an important part of the conference, and we thank Mark.
How cool was that? So much. Gophers on the top of Everest. That's what we were told in the peanut gallery. That's what we want.
Do you know why we have sponsors? Because this costs money. Yes, indeed. So we want to thank all our sponsors, and we want you to visit them on the Discord, and also visit CrowdStrike, because they hired everybody, I heard.
They hired everybody. I know a lot of you are typically looking for jobs.
You can put in your notice.
It might be a little awkward putting in your notice after only a single day, but
But hey.
And it's going to be a little embarrassing because you're going to have to do that in front of one of your new coworkers.
Tom Lyons. So let's get into Tom's talk. Tom is self-described as a person who types things. He's going to talk about testing async architectures. Also, he is CrowdStrike's first ever hire out of GopherCon. So with that,
which used to be impressive till you were all hired.
Till you were all live.
Yeah. Yes. Yeah. And Tom is now their manager. So you're the manager of every attendee now.
Yep.
Congratulations.
He ain't lying.
Because Tom Lyons says,
Look, if you have to explain the joke, it's not a joke.
Oh, I thought
it wasn't a joke anyway.
Tone it down. Your shirt's too bright.
Yeah. All right, let's get into the talk. Tom, why don't you take it away?
Hey, thanks there. Happy to be here at GopherCon. Like they said, I was the first GopherCon hire at CrowdStrike. So it's really great to be back and be able to talk and actually talk about stuff at CrowdStrike. So a little bit about me. That's too far. There we go. So a little bit about me. I'm a senior software developer at CrowdStrike. A little background about CrowdStrike. We are a cybersecurity company, and we ingest over 1 trillion messages a day into our distributed graph database called Threat Graph. Kind of the basis of the company is that we have sensors all over, the servers and laptops and desktops and mobile devices of all of our customers, and they use our cloud to be able to send us different data about what might be going on in the system, so we can have a global resource pool of all of the events that happen throughout our network. So we're able to use that to build different data models and really protect the entire network live. So to do that, we need to process a lot of messages. We need to process a lot of data and get it into our cloud. So today I'm going to be talking about that for how we kind of build this architecture and are able to troubleshoot it and do that live. So this is going to be a talk about asynchronous architectures. These are also called event-driven architectures. It's relatively common concept in modern cloud computing, where you have different microservices, service A, B, and C. A gets a message, sends it over to B. B then takes that message, does some processing, sends it to C. Asynchronous. These are very common because they're very fault tolerant. They are able to ingest a large amount of data and process that. And they're able to do that because it doesn't necessarily have to be time dependent. So you might have a low lag time where you're able to process something through the pipeline in milliseconds, but you want to have the architecture available so that you're able to ingest all of that information and then process it whenever you have the CPU cycles or resources available to process it. So if you get a large chunk of messages for whatever reason, all of your devices are sending, millions of messages, or in our case, hundreds of millions of messages a second, then you might end up with a small backlog, and you can work through that where in other times you might have lower need for latency. All right, so let's talk a bit about the current state-of-the-art for testing architectures. So very baseline is unit tests. So this is the absolute minimum for any kind of Go application is writing your unit tests. If it doesn't have a unit test, it's not done, allegedly. They're relatively easy to write. These tend to be very small. If you're writing unit tests correctly, you're writing them on a per function basis or per method basis to basically verify that it's doing what you're intending to do. So if you write a function that reverses a slice, you want to write a unit test to make sure if you put in a bunch of random different slices, does it reverse it properly? Are there any bugs or other things you need to do? And these also tend to be service specific. So it's very rare that you'll have a unit test do cross-service functionality tests, especially now that Go is a lot more modularized and you'll have different services and different modules. So for most cross dependencies, you won't be really writing that many unit tests. And it's generally limited to that scope. So although you can theoretically write different unit tests and mock data, so for instance, if you have a Redis application, you want to be able to talk to it, you can mock those messages coming in and out of it and kind of get that data there. But once you go up to against a live Redis cluster, then that would go into integration tests. Integration tests are also one of the core foundations of testing your architecture. They're basically something that you can run in a development or production environment that allows you to verify that your services are talking together. So if your service needs to talk to Cassandra or Kafka or Redis, or your service needs to talk to another service, this is where you would write those integration tests. They're relatively straightforward. They will usually include injecting some kind of real or mock data into the system and seeing what you get. So for instance, if you have a RESTful API, then it's very easy to test. You can very simply go into your API, send it a message, say, hey, I'm sending you this message, and expect to get some kind of response from that. So RESTful responses, or really any kind of request response, fairly easy to test. Did I get what I expected? Yes, no, cool. It's also relatively easy to test for very simple asynchronous flows. So if you have a single service that, say, writes to a database, you can inject a message into that service, and then you can verify, did it actually show up in the database like I expected it to? So the problem is that asynchronous pipelines can get incredibly complex, incredibly fast. So let's kind of take a look at this use case where we have some service A, it writes to B, B does some analysis on that message, and then it writes it to C. C creates a very complex message and writes it back to A. A then writes it to D and E. D sends it to a database. E sends out an email. So this is based on a real, kind of flow. It's relatively common that you might have, something come into your pipeline and it spawns just a bunch of processes as part of your asynchronous architecture. the problem is that there's a couple different layers for how you could do this with integration tests. So for instance, if you have an integration test where you want to check to make sure it got in the database, you send it to A, and then nothing happens. It's fairly common. There could be queue lag. You could have injected it into the queue, but there was, you know, a million, 10 million, whatever backlog, and so it won't process immediately. And so you have to continually pull your database to see if it got there, and then eventually time out. So the test could have failed because it never got to D, or it could have just been delayed, or it could have been dropped legitimately. So if you were to send it to A, you know, how do you know that it didn't get dropped at B or dropped at C? You could theoretically simulate the message that came from C and put it into A, or simulate the message that came from A and put it into D. The problem is that at that point you have to write very manual mocks. You have to write data that is essentially allowing you to verify what came out of your previous service, which if you've ever worked with developers, you can absolutely rely on them to never update their integration tests. Yeah, because it's hard, it takes time, and it's very difficult to keep those updated and keep those up to date in a very robust way. So, before I keep going, let's talk a little about the last point of testing, tracing. I absolutely love tracing. So tracing is a just incredible way to look at your data. So things like open tracing, tracing IO, Jaeger, all of the many tools I won't really get into here, will allow you to have really robust views into your architecture. So if you take in a message, each service can then send to a central data lake all of the attributes of that message as it goes through the system. So when it goes into A then sends up a message, hey, I got this message, I sent it over to B. B then gets the message, it sends up a common message to the data lake that says, I got this message from A, and I'm going to take these different parts of it and kind of move through the architecture. So as you go from A to B to C, all of them are uploading that data into a central data lake so that it can kind of make a full view of the picture. So you can see all of the steps that this message is taking as it traverses through your system. And this is fantastic. I highly recommend it. We do actually have tracing at CrowdStrike, but we're not able to have the same level of tracing for a lot of our asynchronous pipeline because we get 1 trillion messages a day. By the time I started this talk, we've processed, probably a billion, yeah, definitely a billion messages. So we don't have there isn't a data lake big enough for us to ingest all of those messages. So really, it's something that we need to be able to do in a more robust way. So before I get into how we do that, we're going to talk about context in Go. I have opinions on this, and I'm going to share them with you. So context is one of the most powerful things in Go, and also one of the worst things in Go. If you use it correctly, it is amazing. Context allows you to add a context to your downstream method calls and your functions. So if you use it correctly, it's great. So number one rule, don't attach things you want your function to call or data you want your function to have. These are very common, especially for new developers coming from Java environments or things like that, where they want to just pack in stuff to context so they don't have to add params to their function line. Which is great. It's very normal for new developers who want to use this as their kind of just central repository for all of their parameters that they could possibly pass to the next function. The problem is that it's incredibly hard to debug, and it doesn't allow for the same robustness that you get and that you can expect to get with a strictly typed language like Go. And generally, you should not have anything in context that modifies how your function fundamentally works. So if you have some kind of value or parameter in context and the result of that context will wildly change what your function is doing, you've used context wrong. Now some do's are absolutely used for things like logging and tracing. That's what it's there for, is so that if you are adding a customer ID or a device ID or a message ID or trace ID or whatever that is, it's not necessarily a parameter that you need for your function, but it's something that you want your downstream loggers and tracers and modifiers to be able to use, so that when it's logging, hey, I have this error, then you're also able to include the message ID or the trace ID or whatever it is. It's also valuable for things like context deadlines. So context is very robust in that you can add things like context deadlines. So you can add timeouts to otherwise normal function calls. So this is very common in the RESTful library, where you might make a request and be able to really cut it off if it takes too long. So if you're making a request to Redis and you say, well, this should come back in 5 seconds, absolutely, then you're able to add a context deadline so that if it doesn't, you know that that service might be dead and that you should bail out faster. And the last do recommendation is always assume whenever you have a function that accepts context that that context is blank, that it doesn't have any data on it. If you can assume that and your function still works, then you've written it correctly. All right, so let's talk about our testing paradigm here at CrowdStrike, or at least part of our testing paradigm for our asynchronous pipeline. First, we're going to talk about no-op services, or NOOP services if you pronounce it that way. So our pipeline, like I said, we handle trillions of messages. We handle over 1 trillion messages a day. We have massive data lakes. And so we cannot mock every permutation of a message. We have such a wide variety and expansive scope of our messages and the potential data that we might get off of these, because these are from sensors, computers, servers all over the world, from all different developers, backgrounds, people, companies that might send us different data. So it is virtually impossible to mock all of the potential permutations of that message. So we mock the services. We have the ability to put up 2 instances of a single service, and that we're actually able to use that to deploy so that they live side by side. So for instance, if you have a Kafka cluster and your service is reading off of that, you can simply spin up a different service or the same service with a different consumer group, and it will process the same messages that the live service is doing. So one of the services is just your regular service, takes in data, writes to the database, writes to the next service. Easy peasy, good to go. The other service is what we call a no-op service. So this is something that takes in the data, it goes through all of the business logic, but when it actually goes to do any I/O, any call to the network or call to the disk, so that it's writing something like that, we simply skip that step and say, oh, it succeeded, assuming that that service, Cassandra, Redis, Kafka, whatever services you're using, is available. So yeah, we call those services no-op, no operation instances. So why? So we can use this to canary some of our services. If we want to deploy a no-op service, we can, if we want to deploy a service, we can first deploy the no-op instance. So this allows us to put it against live data and see anything that can go wrong. So this is really important because we're able to process all of the real-world message, all of the real things that we might see coming in our production environment. And for whatever reason, if somebody updates the code, they forget to initialize a map, for instance, that can cause a panic. And so we want to be able to catch that very early on before this data actually gets processed by anything in our system. So we're able to still rely on the existing version service that's out in the cloud, but also put up this no-op canary service so that we can kind of verify, oh, is it going to die under this kind of load? So it can exist for a few seconds or a few days. It depends on really the change you've made as a developer and how long it would take you to verify, has the change I made actually succeeded in what I want it to do? So how do we do that? Very simple. If memoir.noop on the context, return nil, or return whatever the parameters are for success. So this is basically checking if a value is true. If it's a no-op instance, we should return assuming that we've done everything else in business logic. So for instance, here is a function, the no-op and context with no-op. So no-op just looks at the context. If it's nil or if it doesn't contain the value, it'll return the value false. So when we check the context for this value, we can get a true-false. It'll only return true if the no-op was originally set as true. We see in the context with no-op function, this is basically adding a no-op value to the context and returning it. So if it's nil, it'll create a new context off a background, and then it'll add that with the value with that no-op context key. Now the reason we use the context key as a constant, as a specific type called context key, is so that it's package specific. So it doesn't matter if another package adds the string no-op true-false, it won't actually be picked up by the no-op function because this is looking specifically for that context key. So it is only going to return for that type. So we can reliably say the only way this will beat no-op is if we add it with the function context with no-op. So let's take a look at a message. So this is something that we might have running off of a queue so that whenever we get a new message in, we give the context and we give the raw data of that message. In this case, we're going to unmarshal it with JSON and get that into our message structure. From there, we're going to check our environment variable, no-op. In this case, it could be an environment variable. It could be something like a RESTful parameter. We're going to check if it's true. And then we're going to add that to context. From there, we just call our other functions like normal. We're going to write that message to the database, and then we're going to send it to the next service with write to Kafka. And we do that while passing in the context earlier that contains our no-op value. So let's check that the write to Kafka version. This one's very, very bare bones. We're just going to marshal the message again in JSON, and then we're going to write it to Kafka. Now, before we actually do the Kafka library write, we're going to check if it's no-op. We're going to basically check if that context has that no-op. If it does, then we're going to assume that we succeeded. We're not actually going to write to the next phase of Kafka. We're just going to end there and say we succeeded. And I literally just got done saying, don't let context change fundamentally how your code works. So let's first address why not a global variable? Why even put it on context at all? You could just have a check, is this global variable true? Yes or no, and then keep going from there. The reason for that is that we actually want this to be service specific or request specific. So we want to be able to run this service in production without a canary, just as a standalone service, and still be able to feed it messages that we want to run in no-op mode. This is useful if we want to replay a message and get back what had happened, or test something without it actually affecting production data. So that's why we will use context, so that we can do it on a per message, per request basis. And then let's address the fact that I just said context should never fundamentally change your code. And that's valid. So I would argue that this is actually not fundamentally changing the code because of how it's placed in the code. You only want this to change your criteria for success on saving to a database or sending a message. So as opposed to other instances where you're going to just check the error, does it succeed or not, we want to be able to say, this would have succeeded, and our only criteria that has changed because of this context is our recognition of whether or not it would have succeeded. So that really comes down to where you put it. So this is exactly where you want to put it on the left-hand side of the screen, the one with the green check mark, is all of your logic. So you have some write to database function that takes in context, takes in the message, and you want to be able to look at it, make sure it's the right type, for instance, or make sure it has a field, make sure that that field is valid, and then call your no-op before you do something like insert it to the database. You do all this so that if you mess up the code somewhere, if you are trying to change the code so that it's more robust, or maybe you're changing the field that might handle, that's the thing that you're really checking when you're checking a no-op, is how it handles the real message, the core business logic of what you're doing. So once you've gotten through that core business logic, then you're good to go. What you don't want to do is put it at the beginning of a function or ahead of some method that you don't really check for validity. So in the second case where we just immediately no-op out of there, we could actually have caused a panic once this gets out of no-op mode, because maybe it's not a map stringing interface. Maybe it doesn't have a field ID, or maybe that field's not a string. Or really any number of business logic checks that you need to do prior to writing to the database. If you check your no-op before all of these, then you could have deployed bad code and you won't really recognize that. But if you do it just before you do that disk I/O or network I/O, then you're in a much safer place. All right, let's talk about step 2, API injection. We talked about how asynchronous services can be very hard to test because they're very intricate. They have a lot of different layers to them, and it can be very difficult to kind of go through those different layers and really get to the root of the problem. But RESTful response requests, super easy. Also gRPC, or really any kind of request response service, super easy to test. You give it data, you get back data, see what happens. So we're going to just use that paradigm. This is a very simple hack, really, to be able to test your asynchronous pipelines, that you use the same code that's coming in on your asynchronous pipeline, and you treat it like a synchronous request response structure. So we'll just set up an API handler and then pass that off to the message handler, the same one that we're using with whatever queuing service we're using. So actions that are returned inside the handler, we want to return to the API caller. So what we're going to do is we're going to have an API injection service. You give it a message as if it came off the queue, and then it's going to take that message and it's going to replay it into the pipeline, into the message handler, and it's going to make a record, make essentially what's a trace of all the actions that it's going to take, saying that, oh, I would have written to the database, I would have written to Kafka, I would have written to Redis, I would have written to any number of services, downstream, upstream, whatever. And so it's able to kind of return that trace back to you. All right, so let's look at what that might look like. This is just the RESTful handler. So this is pretty common format for Go for different REST services. There's a lot of different opinions about how you should structure your RESTful handler functions. We're not going to get into that in this talk. This is a very basic example. But first, just read off the message off the request body. We're going to check for that no-op value. So in this case, we're going to check if the no-op URL parameter is true. So this way, a requester can actually set no-op if they want this request to run in no-op mode, or if they want to run it in standard operation mode. So they actually want it to write to the database or the next service. Both can be valuable for different reasons, and really it's up to you as a developer or as a tester to determine which one works better for you. This next one, we're going to create a new data structure. We're calling it a memoir. I'll get into that in a little bit. But we're going to create a Go pointer, and we're going to add that to the context. And this is going to be the thing that we populate with all of those calls. I wrote to the database, I wrote to Kafka, I wrote to the cache. All of these things are going to be saved in that memoir, because we're going to pass it into context in the handle message, and then we're going to encode it as the response to our RESTful request. So that memoir that will contain all of the actions the handler did or would have taken, and we're able to send that back. So we're able to verify that our service is actually operating the way we expect it to. All right, let's get into memoirs. What is a memoir? It's a historical account. It's basically something like a journal or a log or a trace. It is in the same realm in that it is gathering data up for all of the operations that have taken place in a way that makes sense that you can send it back. So we need to record everything it's doing. So we need to record everything that a service is doing. and that we need to be able to put that onto context and have downstream services decorate it, assuming that a memoir is present on context. We're not going to use memoirs at all in terms of our production code. No downstream code will open up a memoir, see what happened before it. This is going to be the same way, no service looks at the logs that came before it, or really, the traces that came before it. This is purely for the response that we're building up for this RESTful response. That is the only consumer of it, and that's why we're doing it. Now, because it'll only operate on this memoir when it's in context, it becomes super cheap to run in production. Because when we don't have an asynchronous, when we do have an asynchronous message come through, we simply don't attach a memoir. So all of these fields, all of these events that we're adding to it will not actually take up any memory because we're not actually adding it because the memoir doesn't exist. So we're able to run through and do everything at scale, but every time we make an API request, we're able to get a very rich data context off of that message and all of the traversals that it's done. All right, so let's make some memoir. So a memoir is just a very simple structure. This has a channel of a slice. In this case, I used an empty interface. In your application, I would highly recommend using a common structure, things like service name, host name, data, logs, trace ID, things like that, that is much more specific to your needs in terms of what you want this memoir to contain. But if you're doing a GopherCon talk, you just want something generic, then you can use an empty interface. When we initialize this memoir, we simply create the new memoir structure. We create a channel of length 1, and then we put a single array onto that channel. We do this so that it's much more thread safe, so that whenever we go and add an event, we can pull this array or this slice off of the channel. We can append to it whatever event we want to append to it, and then put it back on the channel. In this way, we can have a common pointer that has this channel structure, and we can constantly be updating it and appending it in a thread-safe way. So if we branch out, we do multiple Go routines with a common context, with a common memoir. As they update events, we're able to get that in a thread-safe way, relatively in order. There might be a race as to which one comes first. If there happened to be a something in a Go routine, sometimes you might, let's say, write to 2 caches. And you might write to one first and the other second because they're in a Go routine, or vice versa. And then finally, when we actually go to marshal this, when we're actually marshaling the memoir structure, we have a custom JSON marshaller. And this allows us to kind of supersede the marshal function, so that whenever we call marshal JSON, it will take all of the events off of that channel. It will marshal them as a JSON event, and then we defer putting that back onto the channel, so that we're constantly able to keep updating this even after we marshal the JSON. And then totally thread safe, really easy to use. All right, so let's look at the context with memoir and the from context. This is very similar to our no-op instance. Surprise, you thought you were learning about async architectures. It's actually more about context. In this case, we're using context key again. In this, we have memoir, and we're simply updating it to allow context with memoir. So we put a new memoir on there. If not, we create one. We make sure that the channel has been initialized, and we're putting it into the context. Later on, we're able to take it from context and really just store it up. Now, you'll notice that from context, if context is nil, or if the memoir isn't actually present on context, it will return a nil memoir. That's totally OK. And that's because in our previous one, before we check any of these, we're checking, whenever we add, for instance, we're checking, is the memoir nil? Are the events nil? If they are, return nothing. It's fine. We don't need to add to this. We don't need a memoir on this. And because we only call the marshal JSON in our RESTful function, we really only need to check the events field. Although, it's probably good practice. I should update this to if m equals nil. All right. So let's go back to this handle REST function. So just like before, we're reading off the body into a message. We're checking the no-op. We add the no-op to context, but then we're also going to add the memoir to context. So it's the same thing as before, add memoir new, and then we pass that into the handle message function. This handle message function, again, is the same thing that we're using to process all of the data off the queue. So we'll process this from Kafka or from this RESTful command. Either way, the only difference is that if it's from the RESTful command, we'll have a no-op and we'll have a memoir. And now our write to Kafka function will add in that memoir. This is a very simple instance. In this case, we're just adding a string. But you can add very complex data structures or much more robust things to your memoir in order to be able to better debug and kind of process that. So we marshal the message, and just before we check our no-op, we're saying that we are writing to this Kafka topic, and this is the message that we are writing. This is very important because it allows us to then take all of the messages that we would have written to all these services and kind of get them in that RESTful response. So let's put it all together. So going back to that service, A goes to B, goes to C, goes to A, goes to D and E. All of these services can contain API injection and memoirs and no-ops. So we're able to very cleanly go through the structure and actually see it all put together. So we're able to take in a message to A and then get the response back and go to B and go to C. So it becomes much less asynchronous and much more synchronous in the purpose of testing. So this is great. So first we have our testing program. This could be a CLI. This could be something that's in your CI/CD pipeline, or really just random engineer going through to test things manually. I do this all the time. If I'm testing out a change locally and I want to just send it something, I'll spin up a small CLI to send to RESTful requests and then get the responses and see where it goes. So fairly straightforward. They're all synchronous responses, but you go A to B, and then A sends back that it would have written something to B. So you go over to B. You send it that message, then go over to C, send it that message, and you go down the pipeline constructing your messages from the actual services that come before it. This is really important because it really allows you to go through your services, and if there's any change, like let's say two services both had a version update within a very short time of each other, they might have had this, they might have still had the same services going, talking to each other. They might have needed to deal with integration tests that haven't been updated. And so you need to find out where in the pipeline it actually fell down. So in this case, we really want to be able to test them and see that, did it actually get from A to B? Did it get from B to C? And are those messages legitimate? So we can have a lot of confidence that the messages we're sending between these services are the literal messages. They're not mocks, they're actually what would go in. We're also able to check things like the database writes and email sends. So for instance, if you are wondering why, I'm writing it to the database, but why isn't it available after a couple days? And you find out that there was a time to leave stamp that was incorrectly calculated. That could be a bug that you actually find prior to deploying any of these in production environments, because you can do this in a test environment, or you can deploy it as a canary and see what the actual data coming through is. Now, this is also really valuable for blue-green testing. So if you're testing in the case of a blue-green deployment, that's where you have two instances of the same service, and you want to verify that they're each behaving as expected. So you can send in a message to your version 1 and your version 2, or your version blue and green, and really see, oh, I sent this message into A, I got back a response, and then I sent a message into A 2.0, and I got back a different response. And you're able to actually analyze, either automatically or manually, is the change valid? Is there any change at all? And can I expect that this would be an appropriate context? So really, that's the core of how we've begun and really motivate us to test our asynchronous pipeline. So it's allowed us to be incredibly robust in the fact that we are handling, trillions of messages in our system in a given week. We are handling millions, tens of millions messages a second, and that really allows us to have a high confidence in our production so that we can deploy stuff out and we can guarantee it's not going to have downtime, because we're a security company. We can't afford to drop any detections. We can't, afford to have this kind of thing where we leave messages on the floor, because that could be the $1 million message. That could be the thing that saves however many customers from however many breaches. We really value our customers, and we really make sure that we strive to give them the best possible delivery, because our core business is stopping breaches. Shameless plug. Work for CrowdStrike. I will actually take this time to say I really appreciate CrowdStrike, allowing me to come to GopherCon and really speak about some of the work we do here. It's an amazing company. Like I said, I was hired at GopherCon. I highly recommend applying. Jobs.crowdstrike.com. All right. And with that, I'm going to actually throw it over for more questions. All right.
All right. Well, thank you, Tom. Why don't you come on over? We're going to have a little chat. I'll move my stool here.
All right.
So yeah, that was really interesting, Tom. But thanks again for going through that in depth. That was really cool. So you brought up this kind of concept of no-op services as kind of like a canary, right? Is that what you both kind of got out of that as well?
Yeah.
Sorry. Yeah. So I guess Erik, you kind of had this idea too. Like this is all assuming that things succeed, right?
Oh, this is assuming that they'll probably fail.
That they'll probably fail. Okay.
So this is assuming that your services might succeed. So you can reliably say, Kafka, Cassandra, if they're healthy, if they're running, that you want to be able to test. You can assume that they'll succeed, but your code won't. So when you deploy a new version of a service, you're not testing whether or not it can talk to Cassandra. That's something that you should be testing in like integration tests. Make sure, when I do this in my dev environment, is able to properly construct the Cassandra query. Cool, good to go. But when you're actually deploying to production, you want to see, is the new version of the service I'm doing going to be a breaking point?
Gotcha.
So if it can write to Cassandra, cool, that's covered in integration. But what you want to test is, did I add a nil pointer? Is this going to panic and crash? Is it going to be a, terrible fire?
Yeah. Always good to know beforehand.
So easier to know at 3 p.m. than 3 a.m.
Yeah. Spoiler alert, it's going to be a terrible fire.
Always, as a rule.
It's always the one thing you didn't think about, the assumption that you made, oh, that'll work.
Oh yeah, this has definitely caught those things. This is something where deployed it to production and messages came through and we're like, nope, we're not sending out that service. Keep the robust one up. We'll work on this later.
And distributed systems are always fun because you end up in situations where you make a lot of assumptions and you're like, oh, the packets will always come in order, right? And so.
When you do something a trillion times a day, you will find things that break in really fun and interesting ways. It's did you know, this is no longer a problem, but did you know you cannot provision hundreds of thousands of AWS instances in November?
Just November.
Just yeah, I didn't know the November part.
It's Black Friday.
Okay.
Yeah. So you run into really cool and interesting problems and really good engineering challenges. Work for CrowdStrike.
They already do.
They
they already do. As of
You're going to have to review some really funky generics code starting in February.
I look forward to it.
Yeah.
Yeah, there's a Perl implementation you might want to check out. That just came out.
He's talking about a Perl implementation of all of CrowdStrike, by the way.
Oh, good,
not
good.
Just generic.
AWS, I don't think I've heard of it.
Oh, it's relatively new. Mr. Bezos can tell you about it.
Is that supposed to be?
Yeah, that's you.
Oh, okay. Oh, okay. Well, there's.
Yeah, that's good.
Yeah.
That's not bad.
Yeah. Cool.
All right.
Yeah. Well. I think are we
Well, yeah, we've got an exciting talk coming up.
Yeah, cool. Yeah, so thank you so much for coming, Tom.
Thank you.
I mean, this was a really cool discussion. I am actually kind of amazed, like every time I hear the number of events that CrossFit does.
It keeps growing.
Yeah.
Somebody was in, I think the Peanut Gallery channel was commenting about the like billion shirt, and it was like outdated by the time I got there.
Yeah. Oh no. For the record, the 1 trillion number is already outdated. That's why I keep saying over a trillion, because it's a lot.
Right on. Very cool.
Awesome.
Oh, well, thanks so much for joining us.
Thanks so much, Tom. Yeah.
I think you've got some paperwork for all your new hires.
Yeah, yeah, a lot of code reviews, so we'll let you get back to that.
Yeah, awesome. I'll be on Discord for anybody who has any questions.
Yeah, please do join him on Discord.
Awesome.
Yeah, you'll
Thanks,
be
guys.
prowling the Discord, right? Lyons, get it? Oh, man.
Oh,
you know?
boy. Slow clap for that one.
Do you have a lot of pride for that joke?
Oh, the rebuttal.
Man.
Nice, nice.
They're coming out hot, back and forth.
Oh, yes, it's getting hot.
All right.
Awesome.
Thanks, guys.
Thanks again, Tom. Thanks, Tom.
Oh man, the dad jokes. I hear the dad jokes.
Some of those are so bad, I don't think they qualify as dad jokes.
I mean, but we do have some action going on in the dad joke channel.
Yeah,
I think you said there was kind of dying, but I disagree.
Oh, it was dying, but I think it's heating up, especially after that exchange.
After that exchange,
at least somewhere it's heating up.
something. No, but I do have news though.
Okay.
There's a slice of apple is about $2.50 currently in Jamaica, and $3 in the Bahamas, if you can believe that. These are the Pirates of the Caribbean.
Oh!
You can thank Theo for that one.
Hat tip to you, Theo. That was great. Yeah.
Anyways, I have to remind you all of our sponsors. Do check them out. Yeah, as you heard, CrowdStrike, they are hiring everybody, and we also have other sponsors too you want to check out. So yeah, with that, who are we bringing on next?
Well, I think it's time to bring on a member of the Go team. This is Suzy Mueller. She is a software engineer specifically on the Go tools team, focusing on the developer experience. And obviously, Go has such an amazing developer experience now, and we really appreciate the work that she has done. I'm sure there's going to be some more amazing work coming. And she's actually going to talk a little bit about that today. Her talk is called Debugging Treasure Hunt. So with that, Suzy, we're really excited to hear what you have to say. Take it away.
Awesome. Thanks so much. If you spend any time developing Go code, you're going to inevitably end up spending some time looking for bugs or debugging your code. There's a lot of different strategies that you can use to do this. So one of which is just thinking hard at your code, especially if you've written your code. Sometimes this is all you need to find the flaw in your logic. Other times you can add print statements to your code, and this will help you narrow down where the bug is faster. And lastly, you can take it a step up and use an interactive debugger to help you figure out where the bugs are in your code. And that's going to be the focus of this talk today. My name is Suzy Mueller, as I was introduced, and yeah, I work on the Go tools team, and I'm going to be taking you through the Go editor debugging experience today. So a quick intro to interactive debuggers. If you haven't used one before, it allows you to set breakpoints in your code where the program will stop on that breakpoint and allow you to look at the state of your program, as well as step through and investigate different things like the call stack and what variables are in scope. And we're going to be looking at all of that today. So we're going to be doing this in a hands-on demo, which you're welcome to follow along with. But instead of doing a kind of generic demo of where we try to find a bug that I have accidentally left in the code somewhere, I decided to spice it up, and we're going to do something hopefully a little more fun, which is we are going to go on a treasure hunt using the debugger to find our clues and get to the treasure at the end. So to set up for this, I'm going to be doing this treasure hunt using VS Code. So you need to install VS Code and the Go extension, which can be found in the VS Code Marketplace. We also need to install Delve, which is the Go debugger. So this is the back end of the debugging experience, which will allow you to set breakpoints and look at the values of variables in all of the things that we are going to be seeing today. And lastly, you need to download the code of the treasure hunt. So you can download it from GitHub, and then you want to open the root folder in VS Code. Quick note here, do not read the source code if you do not want to ruin the surprises of the treasure hunt. So let's get a quick lay of the land of what we're going to do today. We're on GopherCon Island looking for the treasure, and we have a bunch of different locations on this island that we're going to visit and look for clues using the debugger along the way. This is implemented as a web server that just serves some static HTML pages, and then also creates Go routines where we will stop the program and look for clues in the code using the debugger. All of the locations that we saw on the previous map are in their own package, and we'll be using the URLs to navigate between these locations. So let's quickly lay out some ground rules. First, always run the treasure hunt in the debugger. We're doing this treasure hunt to get familiar with the debugger, hopefully learn some new things, and if you don't run the treasure hunt in the debugger, the treasure hunt will actually crash because we use a hard-coded breakpoint from the runtime package that allows us to stop the program in different places, and this feature will not work if you're not using the debugger. Second, as I mentioned before, no browsing the source code. I did my best to hide the clues, but if you just read through all the files, you would be able to find the clues and know what to do. On a similar note, don't use any language features. We aren't going to be using those. For example, if you want to see the value of a variable, we won't use go to definition, but we'll use the debugger instead to find that value. And last rule is to have fun. This is a game, so let's not take it too seriously and try to learn something along the way. So with that, I'm going to go over to VS Code and start the treasure hunt. So here I have my VS Code window open, and I have the Go Nightly extension installed. So this is a preview version of the Go extension. So I'm getting any of the latest features to try out. And I have the GopherCon module downloaded here in main.go. We have the web server, and then we have all of these different packages that are the different locations on our treasure hunt. So now we need to launch our program. So I'm going to open this debug view. I can see that I can select run and debug here, and this will launch our program and allow us to debug it. But instead, I'm going to take this opportunity to talk a little bit about launch configurations. So I'm going to create a launch.json file where we can define different configurations that we can use to launch our program. And a launch configuration is just a piece of information that we can pass to the debugger to tell it about what settings we want in our debug session, as well as what program we actually want to launch and debug. So I'm going to select create a launch.json file. And I'm getting a few options, and we can edit all of these in our launch.json file. So I'm just going to go ahead and select this first option, and we'll talk about the different settings more once we get to the file. So now that we've added this configuration to our launch.json file, it's pretty simple. All we have is an array of configurations, including this one we just added. So let's go through all the fields and talk quickly about what they mean. So first, it's just the name. So this allows us to identify which configuration we've chosen. It appears up here on the left so that we can choose which ones to actually launch. The type is Go for obvious reasons. And then the next part is request. So the type of request we're doing for this debug session is a launch request. And what this means is that we are asking the debugger to actually launch our program, and then we will connect to it and do everything that we want to do. And then at the end of our session, the debugger will kill the program, and it will be done. We've launched it entirely within the debugger. If we instead change this to attach, we would then be attaching to a process that's already running. So the debugger would not be responsible for actually starting the process. So the next field is the mode. And so this mode of auto is specific to the VS Code Go extension. And it allows you to use the same launch configuration for both testing and regular packages. So if I have a test file open, then it will automatically change this mode to test so that I can debug my tests. But if I have, for example, main.go open, then this mode will instead become debug, and we can just debug the package as normal. So the last field is the program. And so this is what we are telling the debugger to launch. So in this case, it's going to be the directory of the file that we have open. And for our purposes, what we want this to be is that root directory that we have open, which contains our main package. All right, so we've talked about this whole launch configuration. So I think we're ready to actually start our treasure hunt. I'm going to navigate back to main.go, and we're going to hit launch package. So as we do this, we see that a toolbar appears on the top right that has some options to pause or stop our debug session. And another thing that may appear, but in my case didn't yet, is the debug console. So the debug console, there's one of them associated with each of your debug sessions. And it includes some logging from the debugger, which are these first few yellow lines, and then also output from our program. So here we have a message from our web server that said listening on port 1234. All right, so and we'll talk about everything else that's happening here on the left in this debug view as we go along. So our server is listening on port 1234. So let's go ahead and connect to it. So we have our first instruction, which is our Gopher got a text from Eve that says, I overheard something about treasure on GopherCon Island. Meet me at the bar, and I will tell you what I know. So this is our first clue. So we're going to navigate to the bar by specifying bar in the URL. So let me go ahead and type that in. And we've reached the bar. There's a bunch of different Gophers here, and we need to speak to Eve. And we're going to do this by finding the stack frame that has Eve on it. But the first thing we need to do is find our Go routine that contains our clue. So we're going to start this. So we've hit this hard-coded breakpoint. I'm going to get rid of this debug console view so we can have some more space to look at the code. And so we've hit this hard-coded breakpoint, which is here, the runtime.breakpoint. And we can expand the call stack. And what we see when we've expanded the call stack is we have 4 different Go routines here. So each of these is, Go makes it really easy to write highly concurrent programs. So we're often going to be dealing with programs that have multiple Go routines running. And we can investigate the call stacks of each of them. So let's take a minute and look at what information is presented in each of these labels before moving on and looking at the stack frames. So here we have that same line from our call stack view. And the first piece of information that we get is the Go routine ID of the specific Go routine that this line represents. Next, we get the function name for this Go routine. So this is the function where the Go routine is stopped on. So we see that the package name is at the beginning. We have gophercon/bar, and then the function name follows it. So gather intel. Next, we get the thread ID of the OS thread that this Go routine is running on. So not all of the Go routines are going to have this piece of information, because not every Go routine is scheduled to run on an OS thread. So if it's currently running, we will get this piece of information here. Lastly, we get more information about the state of this Go routine. If the Go routine is running, it will say running. But if it's stopped, we may get some additional reasons about why it is stopped. So for instance, this Go routine hit a breakpoint. So we have some additional information that this was paused on breakpoint. if you didn't notice, all of the Go routines were paused in our call stack view. So let me navigate back and we can look at that. And we can see that they're all paused. And this is because the Go runtime does not allow us to have certain Go routines running and other ones stopped. So when the Go routine 53 hit the breakpoint, all of the Go routines stopped and we were now able to investigate the state of our program. So we're going to, for the rest of the time, also have all of our Go routines are paused or all of our Go routines are running. So now that we know where to look for our the bar where our clue is, we can expand this stack trace. And we can see that we have a bunch of stack frames here. This first one matches the function that we're stopped on. So this, it contains the name of the function as well as the location in the source code. If we then select a different stack frame, for example, Alice, the location in the source code that we're looking at gets updated to match, and the context that everything is evaluated in also gets updated. So what does this mean? So our original stack frame didn't have any local variables, and if I expand the variables view, we can see that. But if I then step up and step into Alice, we instead see the local variables that Alice has, which is what she's saying to us, which is, sorry, I don't know what you're talking about. But if we go ask Eve for our next clue, Eve will tell us that I left the first clue in locker 7654321 in the gym. So that's our next clue. We need to go to the gym and go find locker 7,654,321. So to do this, first I'm going to go back to VS Code and I'm going to hit continue. I need to do this because, like I was saying before, either all of our Go routines are running or they're all stopped. So if they're all stopped, it's not going to be able to serve our next request to go to the gym. So we need to make sure to hit continue first. So let's leave the bar and go to the gym. So we've made it to the gym. We have a bunch of lockers to search, and we're going to use the variables view to do this. So we've again hit a hard-coded breakpoint, and we can see that we have a local variable named lockers. I'm going to collapse the call stack view so we can have a little more space. And so there's a lot of lockers. There's over 12 million lockers, and we need to find the one locker that contains our clue. If we expand this slice of strings, we see that the contents, we didn't just get a list of all 12 million lockers. Instead, these are going to be paged. And this is for performance reasons. Instead of trying to load all of the lockers or just some of them, these are paged so that we will only load the ones that we are actually looking at. So if we dig in, they'll continue to be paged until we get to the last 100, and then we can see the each individual locker. And all of these lockers have dirty socks in them, so they are not the locker we're looking for. So let's go look for locker 7,654,321. So even with this being paged, so it is more performant, but I still have to do this search, and I'm kind of lazy. I don't really want to do this. So we're going to use another feature of the debug console to actually be able to do this really quickly and easily. So the debug console, as I mentioned before, includes logging from the debugger, as well as output from your program. But it also provides a way for you to evaluate different expressions. So you can specify different expressions that will get sent to Delve, and Delve will evaluate these expressions and give you back the results. And we can use this to find our one locker that we're looking for. So let's go back to VS Code, and I'm going to open up the debug console. I'll again collapse this on the side so we have a little more space. So down here at the bottom, we can specify some expressions. So if I type in lockers, I'm going to see a very similar thing to what we saw in the variables view, where if I expand it, I'm getting these paged lockers. So this didn't really solve my problem, but we can actually just request a single locker. So if I instead try the answer we're looking for. So this is our next clue. It says, this locker contains a note, meet the monkey in the jungle. So that is our third clue, so we need to go to the jungle. So let's go back, hit continue, and switch over to our browser again and go to the jungle. So we've reached the jungle, and now we have to figure out how to speak to the monkey. So the monkey that we have is a process with the name monkey, and we're going to need to attach to this process and then figure out how to trap the monkey and get our next clue. So we're going to do this by creating a second debug session in addition to the one we already have running that will attach to the monkey and allow us to investigate that process as well. So we're going to go back to our launch.json, and we are going to add another configuration to do this. So I'm going back to the VS Code. I'm going to open launch.json and get put extension that will provide a process picker and allow us to choose the process that we want to connect to without having to know the process ID off the top of our heads. And we can use this by specifying the name of the process that we want to connect to. And if the extension finds only a single process that matches that name, then it will automatically connect to it for us. So I'm going to replace this 0 with monkey, which, hold up, yeah. And we're going to hit save, and then we're going to launch using this configuration instead. And the extension will find the process name monkey, fill in the process ID to be the correct number, and will then send that information to Delve. So let's go back to our debug view. Let's toggle over to the attached to process configuration, and let's hit debug. So not a lot has changed, but we actually have successfully started a second debug session. So we can see here on the toolbar, we now have the name of the current debug session that we are looking at, which we can switch to attach to process. And if we look here, we can see that this stop button has switched to a disconnect icon. And this is because by default, when we're attaching to a process, since the debug session wasn't the one that launched it, it's not responsible for cleaning that up. So instead of killing that running process, we're just going to disconnect from it and allow it to continue. So now that we've done that, let's stop on the attached to process one. So we see that we still have two separate debug sessions. The launch package one is still running, but we have our attached to process one, which is now paused. And we're also going to have two separate debug consoles for each of these. So let's take a look at what's happening and see how we can get our clue from the monkey. So we can see that we're in this loop on line 14, where we have some bait in a trap, and we really want to catch the monkey, but the thing that we've put in the trap is not what the monkey actually wants. So let's go to the variables pane and see what we have in the trap. So we are trying to bait the monkey with a banana, but the monkey doesn't want a banana. But we also can't see in this variables view what the monkey wants. And that's because IWant is not a local variable to this scope. And by default, for performance reasons, the debugger does not load the global variables, but instead will only do that if you change the configuration to do so. So our options now would be to go back to our launch.json, add show global variables true to our launch request, or our attach request, and then start our session again. But if we were in a long debug session, this might be annoying to have to restart the whole thing to change something that we didn't know we needed when we started. So instead, we're going to use another feature that we provide in the debug console to make this configuration on the fly. So in the debug console, Delph has provided a few additional commands that allow us to change things like the configuration on the fly. So by specifying these expressions, which wouldn't be valid Go expressions anyway, we can make changes to the configuration. So let's go back and open up our debug console so we can figure out how to trap the monkey. So we now have the debug console open, and this is a separate one from the launch package debug configuration. And we can specify the command that we want to run. So let's first quickly look at the help for the configuration. And we can see that to change the value of our configuration, we specify delf config with the parameter in the value. So to update show global variables, we're going to type delf config show global variables true. So now when we go back to the variables view, we see that we have two different scopes. We have the locals and we have the globals. When we expand the globals, we now see the value of I want. And if right now you're thinking, we could have instead in the debug console typed in I want, surely Delph could evaluate that expression. We absolutely could have, and we could get that value here as well. So that would be another way to do it. But if you want to see all of the globals at once, we can also use the debug console to update the configuration. So now that we have the value that we want, how are we actually going to use this? We're going to do this by using a feature called set variable. So I'm going to right click on the value of I want. I'm going to copy the value. And then I'm going to set the value of bait. I'm going to change the value of bait to ice cream. So this is another feature provided by the debugger that is useful in scenarios that are very similar to this in the real world. So if you have a loop that has, is running many iterations, and it's not important for what you're actually trying to debug, so you just kind of want to skip ahead and get past it and not have to wait for the millions of iterations that it's going to do. You could use this feature to skip ahead so you can break out of the loop early and continue on with finding your bug. So now that we've done this, we're going to catch our monkey in the trap. OK, we successfully broke out of that loop, and we were able to catch our monkey in the trap, and the monkey panicked. Let's take a minute to look at all of this information that we see here. And I'm going to do this on a slide so we can focus in on the different parts of what's happening on this screen. So here I have the same screenshot as we had before. We can see that the stopped reason here is panic. So this is the same thing as we had where it was paused on breakpoint. Instead, we are paused on a panic. And what the debugger does is if there is a fatal panic or a fatal throw, it allows you to, it catches the program before it exits and gives the user a chance to investigate the state of the program right before it's on its way down, it's shutting down. So it does this by setting internal breakpoints. So for example, this one, there's an internal breakpoint set on fatal panic that allows us to see the state of the program here and catch it before it exits. We get some additional information from this exception info, which includes the call stack, which is also something you would see on a panic when it crashed. And what's important for us today is this message that was passed into the call to panic, which is our clue, which says the butterflies in the garden can tell you where to find the treasure. So there we have it. We're on clue number 4. We need to go to the garden. Let's navigate back and go to the garden from our browser. So I'm going to hit continue and allow this monkey process to exit. So now we just have that single launch package session again. and we can now go to the garden. So we arrive at the garden, and there's a bunch of butterflies flying around, and they're trying to tell us something. So we're going to look at a certain variable and try to figure out what they're trying to say. So we have 10 different butterflies that are flying around this garden, and we have this function here called watch butterflies. So let's set a breakpoint there and try to figure out what's going on. So let's hit continue, and we can see the value of pattern here on the right. So I'm going to zoom out real quick so that we can see the full contents of that string. And let's hit continue a few times. Another way for me to actually kind of pin an expression or a variable is to right-click on pattern, and I can add it to watch. In this way, it appears here in this watch view, which gets updated every time the program stops. So if I have a lot of variables and I need to dig through, or it's something that's really far nested, so you often are going to have to dig into a mapped or a struct to find the value, you can add that to the watch view, and then that will get updated every time the program stops without having to do those extra steps. So let's continue. Clearly something's happening because it's changing, but I don't really see a pattern here. And we're going to use another feature called log points to try to get a bigger view on what's happening. So what is a log point? A log point is a special kind of breakpoint that where the backend does not break, but instead prints a log message. So this means that instead of the program breaking and allowing us to investigate, the debugger will, when it hits this log point, will print out a user-specified message to the debug console, which we can then later go back and investigate. And we can also provide different expressions to evaluate to that log message. These log points are very similar to print statement debugging. Essentially, it's just about the same workflow. You can specify log points at different places, and if you run it through the debugger, it will act very similar to print statement debugging. An advantage over print statement debugging is that these messages never actually get compiled into your code. So you don't have to worry about accidentally leaving them behind to get caught in code review later, which I have definitely done, or even having them commented it out. But a disadvantage of doing this through the debugger would be that it's not as performant as if you would just add a func.printf to your code. So let's go back to VS Code and use the log points to try to get a bigger picture of what's going on. So we're going to do this by right-clicking on the breakpoint and selecting Edit Breakpoint. We're going to navigate to Log Message, and now we're going to specify the value of the message that we want printed out. So we could just type in hello or whatever we want to say, but what we really want to look at is pattern. So we just want to add pattern as an expression between the braces so that we can, it'll just print out the value of pattern. So we hit enter, and now this breakpoint has been updated to be a log point, and we hit continue. So the program's no longer breaking, it's just running, which is exactly what we wanted. So let's navigate back to the debug console so that we can see what's actually being printed out. So we can see that it's working. We're getting a lot of different messages printed out. Each of these starts with the Go routine ID, very similar to how we see that in the call stack view, followed by the message. So this is pattern that's being printed out. And then we also have a link back to the location in the source where the breakpoint is so that we can see where this log message is coming from and what context everything was evaluated in. So if I click on this, we get sent back to where our log point is. Now that we have this, we're getting a bigger picture, but it's still not very clear. And this is because we are looking at a bunch of different Go routines or a bunch of different butterflies, which are flying in different patterns. And we need to focus on a single butterfly in order to get our next clue. So let's do this by, again, editing our breakpoint and adding a condition. So let's do edit log point and switch to expression. So by adding an expression, we are making this breakpoint a conditional breakpoint, which means that we are, the breakpoint will only break when the expression is true. So if we want to, in this case, we want to do this only when a certain butterfly is running this function. We don't want to print it out every time any butterfly is running this function. So we can see from this comment that the IDs are between 0 and 10. So these do not line up with the Go routine IDs that they have. These IDs are a separate value. So let's just check for the first butterfly with ID 0 and hit enter. And it's updated our log points. So we don't see anything different, but that's because I haven't scrolled all the way to the bottom where this update has actually taken place. And we're getting a clear picture. Let's zoom out so we can see what it is. So we have a palm tree. So this is our next clue. This is what our butterflies have to tell us. We're ready to move on and go find our treasure. So our clue is a palm tree. And if we go back to the map we had earlier, we can see that the palm tree, the only palm tree on the island, is on the beach. So we need to go to the beach to hopefully dig up our treasure. So let's do that by specifying beach in the URL. So I'm going to go back to VS Code. I'll zoom back in. And I'm also going to disable this breakpoint. And this is because we're printing out a lot of messages. Let's not add any more clutter or slow down our debug session. So we're just going to get rid of that log point. All right, so let's go to the beach. So we've made it to the beach. We have a bunch of different locations. So in this case, these are actually going to be the names of the functions that we're going to. And we need to go find the palm tree. So we're here on the beach. And we can't actually see where we're going. The functions aren't immediately visible in the source code. So we're going to have to use the toolbar to navigate through the code. So far, we've only really used the play or the continue and the pause button. But for this section, we're going to focus on using the stepping function. So this is something that if you're debugging code, you're probably going to want to use, where you'll set a breakpoint and stop somewhere, and then you might want to step through and see how things change. So there's 3 different options for stepping. The first is stepping over. So this allows you to just step to the next line. So if you have a function call, you won't step into the function call. Step in allows you to step into that function call. So you won't step to the next line, but will step to the next line, including any function calls. Step out allows you to go back up a level. So if you are in a function, for this example, fPrintline, if you select step out, it will take you back to where that was called. So let's start stepping. I don't know where the beach is, so let's just start stepping in so that we can figure out where to go. So I'm kind of just clicking through quickly. And this is a bit of a journey. I don't know when it's going to end. So I kind of want to do this quicker. I don't want to just keep hitting this. I don't know where it is in our source code, so I can't set a breakpoint that way. But I can set a breakpoint using the information that I have, which is the function name. So from the breakpoints view, I'm going to select add a function breakpoint. And then I can specify the location that I want to set a breakpoint on by just specifying the name. So I'm going to type in palm tree. And so now I have a breakpoint set on the function palm tree. I hit continue, and we go straight there. No more stepping. We're able to set a breakpoint just using the function name. And we've reached the end of our journey. It tells us a link to go to where we're going to find our treasure. And if we go to that link, we are rewarded with a golden gopher for completing our treasure hunt. So this treasure hunt used a lot of different features that are available for debugging. We went through all of the different views that we had available and used those to find our clues and figure out what to do next. If you're interested in a more complete set of features, there's some documentation available on the VS Code Go documentation. I'm going to spend the last 5-ish minutes going through the behind the scenes of the integration of the debugger, which is Delve, with the editor. As I mentioned before, Delve is the program that will allow you to do all of these debugging features. But we're using it from VS Code. So we have a way that it's set up to allow us to communicate with Delve and get those features in our editor. So for the setup, we have VS Code in our Go extension, which provides the Go language features as well as the Go debugging features. When we want to start a debug session, VS Code will tell the Go extension, and the Go extension will launch Delve. So it will do that setup. Once it's launched Delve, Delve can communicate directly with VS Code using the debug adapter protocol, which I'll talk more about on the next slide. But this debug adapter protocol is how VS Code will tell Delve what program to launch and all that information so that Delve can either attach or launch to a Go program, and then these will communicate with each other to give us the debugging experience that we saw here. So what is DAP? The debug adapter protocol standardizes an abstract protocol for how a development tool communicates with concrete debuggers. And what this means more generally is that the VS Code implements a client of the debug adapter protocol, so it speaks the same language to the Go debugger, the Python debugger, and the Java debugger, and all of these debuggers called a debug adapter because they implement the server side of the debug adapter protocol. What this looks like is a tool like VS Code will send requests to the debug adapter, like launching, or what variables are in scope, or what threads are available. And the debug adapter will in turn update the tool with what's happening with the process by sending events, like telling the tool that the program has stopped because it hit a breakpoint. And what does this mean for you as a Go user? Is that because the Delve is a debug adapter, it implements the server side of the debug adapter protocol. It can be easily talk to any editor that implements a DAP client. With minimal additional configuration, the debugging experience can be used from any editor. And to kind of hammer this point home a little bit, my coworker Rob Finley set up this treasure hunt on using Vim and Vim Spectre, and was able to use it to investigate the clues. So even though this treasure hunt was designed for VS Code, it was easily translated to Vim Spectre, which implements a debug adapter client. So lastly, I just want to finish off with thanking the Delve maintainers for all of their hard work on creating such a great tool, as well as to the Go team for all of their feedback and support on this talk. And I'll just throw up this slide with the links to the software I had, and I'll send it back to you all. Thanks so much.
All right. Well, thank you so much, Suzy. That was amazing. In a word, amazing. Someone on Discord put it very well as well. They said the presenter put an enormous amount of effort into this presentation. I would agree. Well. I think that is, yeah, I think that may even be an understatement. Yeah, indeed. I like seeing DAP in the wild too. I think DAP is just kind of it's a cross-company effort, obviously, cross-editor effort, cross-tooling effort. but also the amount of specification in DApp. I don't know if you've ever looked at it.
No.
Is like pages and pages and pages of interfaces and protocol. So just to see that implemented out in the wild must have also been an enormous amount of effort.
I mean, what's interesting for me is like I mostly have been Vim for years, and so like a lot of these things that I'm not as in tune with them. Like now I know like LSP has become pretty popular inside of Vim, but I'm actually not familiar with DApp at all.
Yeah, I guess LSP and DApp, they work side by side. One is while you're writing the code, and the other is while you're running and testing and everything. But I know LSP and DApp, they both kind of started from a multi-company group of people, and they both seem to have kept that same kind of vibe, I guess, spirit, yeah, for lack of a better term. There's no one company that seems to be taking over or anything like that, or editor or language.
I mean, I think we've kind of seen that as a pattern in the industry as a whole, right? Like we're creating a lot more kind of shared technologies that we can all build on, which makes for much better features when everybody's not building the base layers of things.
Sharing is caring.
That's right. And now the VS Code folks and the Vim folks can take advantage of the same technology. There's no more editor wars except for the Emacs Vim wars.
I mean, it's not a war anymore. Vim won, I'm just saying.
I have no opinion on this, but I know that's going to get the peanut gallery going. That's where my cringe comes from.
Right here at this table, there's 3 of us, and at least 2 of us are Vim users, so
I am too, because I opened it in 1998 and I've never closed it. I can't figure it out.
Permanently.
There's a terminal tab that just has it in there running. That's how
like,
stable
great, I'm gonna have to reboot now.
Yeah, somehow. But yeah, seeing the progress on Delve itself too, it's pretty cool to see.
Yeah, I mean, I remember Derek Parker coming in and talking about it. What was it, 2016?
Yeah, I mean, it might have been the first GopherCon I went to, maybe.
2015, 2016, it was one of their earlier GopherCons, and yeah, Delve itself has made a ton of progress as well.
Yeah, enormous strides, yeah. Indeed. And it was sorely needed. Having a good debugger in...
What's wrong with Printline?
I had forgotten how good debuggers can be.
I know, right? Yeah.
Got so
GDB. No, you can do better. You can do better.
Someone at a previous job used to say, I don't use GDB, I use FMT. Because the Funked Printline is the,
yeah, I mean, I always liked GDB.
Yeah, it's been a solid debugger, but for Go...
Yeah, it's not Go-centric. You want like, I don't typically use a debugger, but when I do, it is Delve.
I mean, if you wrote perfect code all of the time, you wouldn't need a debugger.
Exactly. Exactly. If you don't write faulty code.
That's right. Yeah. That's 2 memes right there. I don't always do, and then this, if you don't have to debug if you always write perfect code.
So so everybody join discussions in Discord. I'm sure Suzy will be hanging out there, answering questions. Coming up here in a few minutes, we'll also have more of the Go team answering questions. If you're not in the Discord, you can go to discord.gophercon.com to jump in. Keep an eye out for some of the virtual meeting spaces we have coming up.
Yep.
Do we have one coming up?
I don't know.
I think there's one later with Mercari again, but I think that's like an hour or so from now.
Yep.
You do need to be registered for that, so just go to gophercon.com and register there. Aside from that, hang out with sponsors in Discord.
Yeah.
Go check out some of the links. There's tons of cool giveaways going on right now.
Jobs.
Some of them are hanging out in Gophertown.
Yeah, GopherCon, yep.
Have either of you been able to jump on Gophertown?
No.
I was on there yesterday. It was fairly lively. I think it's probably only going to pick up steam, I would imagine, today and tomorrow.
We should just jump on here and wait for the production crew to be like, what are you doing? Stop.
Can we
get feedback loop?
I don't know. I mean, I have to say, like, the reason I haven't been on GopherCon is because I enjoy the live human experience. You're right here. So it's like saying, yeah, let's go out there so we can actually get on GopherCon. No.
It's because we're too busy. Actually, I just noticed it's
better.
It's a little better. It's not. It's only like 25 degrees.
No,
now.
it's like a lot better.
We might have hit 60 degrees Fahrenheit.
Really? You think so?
I might have. I'm not going to go 100% on
the
that.
Caribbean in me is saying it's still cold.
I mean, we can't see anybody's breath anymore, so it's clearly gotten better.
You know, I just got it. The pie pun.
Mm-hmm.
Pirates. And then
You just got the. Oh.
And you know what's even more embarrassing, Peanut Gallery? I'm the one who copied and pasted that pun.
And you didn't. Yeah.
And
you're like, oh, this must be
this
funny.
Is probably funny.
This,
I
let
just
me
didn't
copy.
think
It's
about
probably
it.
funny.
I just didn't think about it, but I'm like, yeah, the apple pie, yeah, ha ha ha. But I didn't really like.
Wow. Okay. Yeah.
Someone want to screenshot this? Oh man,
it's gonna go side by side with the other.
The other one. I would rather have this one than the other embarrassing whatever.
Have you seen the one with me with the 2020 glasses? That's
that
a bad
got
photo.
dug up again, didn't it? Just now. Yeah.
Yep.
Hey, but you
Yeah,
know,
you can't
at least
live
your
that
eyes
down.
are open. Can both completely. Not one smaller.
I
like
would
one
rather they
closed
were
more
closed.
than- Oh man.
Good times.
I didn't even think to look at the Dad Jokes channel.
Yeah, well, let's see what we got.
Oh, new material.
Yeah, is there new material?
There's always new material. I know Theo's been laying them down.
I mean, if we're short on dad jokes, we can just
we're
call
not.
Tom in. He's got dad jokes for days.
Yeah.
We're not. All right, here's one. I'm just gonna read one. I'm not gonna go all in on this. Used to be able to get air for free at gas stations, but now it's $1. That's inflation for you. And that's, very applicable to our time, right? That's Dan from CrowdStrike. Thank you, Dan. Thanks for getting that one out in the ether.
Are they just sitting on these, or is somebody looking them up?
We have more diversity in the Dad Jokes channel. Like there's a lot more people coming in, but there are like Dylan and Dan. Like they keep hitting them. They keep coming in with new ones. So I don't know.
How many months have 28 days? All of them.
Oh, this is nice. I went on top of the municipal courthouse yesterday. Someone told me I couldn't be there. I told him I was above the law.
All right, so Jared's got one. Who built King Arthur's fabled round table? Circumference.
Oh man. Oh, y'all are masters at this.
Keep them coming, everybody.
Keep 'em
Seriously,
coming.
these are great. These are great.
Oh my goodness.
Coming up, we're going to have the AMA with the Go team. If you hadn't taken the opportunity to ask questions of the Go team, there is a Go team AMA channel inside the Discord under the speakers category. I know there's a lot of channels. So if you scroll down, there's like category for speakers, Go team AMA in there. Drop your questions in there for the Go team.
We haven't had a lot yet, have we? Has it been picking up?
I think there's a few in there, but yeah, so prime opportunity to make sure that your question gets answered.
Yeah.
In addition to that, we've got the Go Time episode coming up tomorrow where we're going to do like a Family Feud style, I say we, they are going to do a Family Feud style game. We're going to announce it for them.
Yeah, we'll be here before it.
I'm going to be a director one day with that whole like, oh, look what we did.
Yeah, right. That's management for you.
So, yeah, they're going to do a survey to the Go community. Go team members are going to compete, guess what the most popular answers were. So to make that more fun, go to gotime.fm/GS for Gopher Say, and that'll allow you to complete the survey.
Yep.
And we can
troll them. Don't forget to troll.
We got a big increase overnight, right? Of
new material.
submissions. Now we're looking for
yeah, like
more
now I'm
trolls.
waiting to see whether it's legit answers or trolling.
Yeah.
I'm kind of hoping it's trolling.
Me too. Yeah, I'll be honest. Me too.
Cargo built.
That is a troll. Like you get your team together for an onsite or whatever, and then you alias all their Go tools to cargo, and then it's just cargo build, and it'll build their Go code bases, and then you're there trolling them, and it's wonderful.
Yeah, and then they'll quit. What could go wrong?
Exactly.
then
they're like, that's it.
They go to work for CrowdStrike.
They go to work for CrowdStrike. I mean, they might already,
Oh, that's true. What's going to happen to the Go language now that the Go team works for CrowdStrike?
It's now it's CrowdStrike as the development team for Go, I guess. Yeah.
Right.
That's where the language is now. Yeah.
I guess so. Yeah.
I mean, are we still? Do we need to give up our badges now that we work for CrowdStrike?
Yep.
Yeah, they can tell us.
That's right. We do. Yeah.
I guess we need to go get a visitor's badge.
Yeah. We do.
Is Tom still here, or is he still out
Tom's our
prowling?
manager. Yeah. Our manager is off to the right. Tom.
Our manager is still out there somewhere, prowling the prairie or something.
Yeah.
I legit hope Tom gets promoted over
all this. I know, seriously. Yeah.
So whoever Tom's manager is, if you're watching, we all truly believe he deserves a promotion to CEO of CrowdStrike.
CEO.
we just went straight to the top.
Good luck to you, Tom, as the CEO.
Don't forget to help who helped you got there. Don't forget us.
Yep. Takes a family.
I thought we were gonna like maybe jump up director or something. Maybe next year we get him CTO, but you just let's go.
Go big or
go
go
all
home.
the way.
Yeah.
Aim high.
Yeah. All right. Well, shall we get started with go time?
We shall get started.
All right. We are going to throw it over to the go time folks to begin the AMA.
Yeah. Can't say thank you enough to the Go Time team for all of this, all of these sessions they've been putting together. The game show, the interviews.
Yeah, this is great stuff. It's awesome to have, the talks and this kind of all as part of the same conference. We also did the lightning talks and the virtual sessions as well. It's really cool to see this all, coming together as one.
Indeed.
Yeah. As a panelist,
yes,
I think you should do the honors, Johnny.
Yes. Yeah, well, thank you very much, sir. So it is, I think we should do a countdown and say go time. Right?
Okay.
Right, ready?
Are we starting at 3?
Starting at 3.
On
We're going to do
three
Matt Ryer style. We should be on 3. All right, he's going to be on 3. Ready? 1, 2, 3.
It's go time.
Let's do it. It's go time.
Hello and welcome to a very special Go Time GopherCon mashup. I'm Matt Ryer, and today I'm going to be putting your questions to members of the Go team. So please hang out in the Discord channel. It's Go Team AMA, and ask your questions in there. Let's see who's on the panel today then. Well, we're joined by Samir Ajmani. Hello, Samir, Engineering Director, and you run the Go team, right?
That's right. I manage the Go team at Google, and basically have to keep everyone happy and get them all paid.
I'm sure they appreciate it. We're also joined by Cameron Balahan, who's looking at the product side of Go, right, Cameron?
Yeah, that's right. I'm a product manager. I'm one of 2 product leads for Go, along with Steve Francia. My focus in Go is primarily on the IDE tools and security spaces, but I also work across all of Go, especially as it relates to how we position it in Google.
Yeah, very interesting to think of a programming language having a product. I'm keen to dig into that a bit more. We're also joined by Alice Merrick, who's a UX researcher, and you run the Go developer survey, right, Alice?
That's right. If you took the Go developer survey in the last couple of weeks, thank you very much. I'm a part of a small group of UX people that we work on various things, but yeah, the Go developer survey is definitely the largest or most visible one.
Yeah, what happens if you get nobody answering? Can you just have a day off?
That's never been a problem. We got over 10,000 responses this year. It was amazing.
Oh, wow. Yeah, well, great. Yeah. Okay, well, we're also joined by Rob Findley. Rob, you do sort of the tools side of things, particularly generics, right, recently?
Correct. Yeah, I'm on the Go Tools team.
at Google, and I work on Go Please, but also recently I've also been working on support for generics in the Go type checker and parser.
Yeah, so very, very cool. And everyone's very excited about generics, and I'm keen to also kind of understand what the impact of these kind of big language decisions are on the tools, because obviously it's a sort of domino effect down the chain, no doubt. And last but not least, we're joined by Keith Randall. Hello, Keith. You're sort of what is your focus on the Go team?
I work mostly on the runtime and compiler. I do performance mainly, although I've been working on some of the generics implementation recently.
Very cool. Okay, so I feel like we're going to learn a lot about generics today, which is exciting. Yeah, so maybe we could kick off then, Samir. By the way, we're asking questions that have come from the community. So anybody watching live, if you want to head over to the Discord and ask your questions, we will try and get them answered for you. And we've had some questions in already. Samir, the Go team, like when it started, it was just kind of a few people, and it's grown so much over that time. What sort of challenges have you seen in that time as it's grown? What's changed?
That's a great question. Yeah, when I joined the Go team, I think it was 12 people. And now, including our cross-functional partners, we're upwards of 50. And It's really quite remarkable growth over a period of time, but it's been a bit spiky. So a lot of our recent growth was in 2018, 2019. And so a lot of our time since then has really been about scaling our team and the way we work to really gel and, new processes and all the sort of managerial work to make sure that the team works well. But it has allowed us to take Go from just being a language to more of an end-to-end platform. We have full-fledged IDE support. We have the Go command, which has been a platform, all sorts of extensions. Of course, there's our suite of libraries, and then our web suite around go.dev and package discovery site. So this larger team has enabled us to really build something much more holistic. So Go feels like Go throughout the various things developers have to do. In order to succeed, we've invested a lot in having more cross-functional partners. So on the call, we have Cameron and Alice, who are two examples, and we have many more. Challenge-wise, scaling the team, scaling the user base, scaling with larger uses of code. And a lot of this is driven by mainstream usage. So instead of our early adopters, we're now dealing with mainstream adopters, enterprise adopters who are maybe looking for a slightly different thing from Go. And security is top of mind, both for enterprises and all the supply chain security attacks. And Cameron, I'm sure, can help speak more to those issues.
Yes, that's very interesting then. One of the things about Go that I think I appreciated when I first looked at the language was some of the principles, like the simplicity and some of the trade-offs and the taste that was kind of in the design. How do you make sure that people that join the Go team kind of really understand those principles? Is it something that you find you have to teach a lot, or do you find people that naturally think that way, or does it not matter? Do you prefer the mix?
It used to be that we hired a lot from the community, in which case we were hiring like-minded people. As we've grown and diversified, there's a bit more of an onboarding journey to sort of get the ethos across. I think a lot of it's peer-to-peer. New engineers will work with existing engineers on the team. Within Google, we have processes for helping people learn how to use Go and write idiomatic Go. And there's, of course, documents on this as well. But I think a lot of it, for example, our tech writer is a good example. He came in with great experience writing for enterprise users and had to learn really what the Go voice was, how we communicate. But he also educated us on how to better connect with the users. So it's bi-directional.
That's very interesting. Yeah. So, and it's funny to think of Go really starting out as a language, and as you say, growing and like that. It kind of makes sense that you have a product perspective on it. So Cameron, how does that work? What sort of things do you care about as the product person for Go, the language and the tool chains and the community and the ecosystem?
Yeah, so it's not that different from something that's not an open source language ecosystem. Everything's different in its own way. We're not looking to monetize this or something like that sort. So there are some differences, but really it's got the same sort of things any product would have. You got to think about its strategic direction, like the complete end-to-end picture of what we're trying to accomplish and whether all the different pieces are lined up to sort of get us there. And then you also want to think about like you're the voice of the user. what is the sort of research we have, and what have our users been telling us, and how can we synthesize all of that to try to add more value and make Go a better product, a language that more folks want to use to accomplish their goals. And that's just our goal, and just to try to keep that whole vision together and moving forward as a coherent whole rather than a bunch of individual pieces.
Yeah. So do you foresee, have you seen any examples so far of like tension between a sort of technical perspective and a product perspective? Is it joined up quite nicely because of the nature of the project, or are there ever those sorts of disagreements between you?
I'd say not that many disagreements, really. It's like the whole Go team is interested in trying to make Go a better experience and something that contributes value. So we're all hungry to figure that out. And so, we all sort of collaboratively work together to try to do that. It's like nobody's really trying to just go engineer something that is off the value path. Everyone is looking to see, well, what's next? What are our customers really looking to do? And how can we better service that? So I'd say the answer is no. It's all been a good, coherent thing together.
That's really interesting. And of course, a big part of product is hearing from users, as you say. And so that's another unusual thing, I think, that you wouldn't expect to have on an open source project of, if it was just a programming language, is a user experience research. What sorts of things do you research, Alice?
Yeah, well, I'll talk a little bit about what I have researched and also what some of my fellow researchers have worked on. The kind of the lower level stuff is too low level for us. We're kind of looking a little higher at things like developer workflows. So how how somebody might look for documentation or packages when they are writing Go, for example. Things like when you are in your IDE, what kind of challenges do you have there? When you're debugging, looking for those kinds of challenges and opportunities of where could we improve something, where could maybe introduce something new into the ecosystem as far as tooling goes, or smooth out some workflow there. So those are kind of some of the interesting questions that we've looked at. Another thing is that we do run the annual survey. So looking at, how happy are people using Go, and do we see more usage in particular areas, and where are opportunities that we might want to grow? Cameron sort of mentioned leveraging some of that research on the product side. And then recently, we were looking at what are people really concerned about, as Go developers, and what other areas might we branch into. This year I did a study that was looked at specifically people who considered using Go and then didn't, and why. And is there something that we could do there that would make it easier for more people to use Go? So
if error doesn't
exist,
isn't it? That's the big complaint.
Yeah. Actually, no, but
what is it
seems
then? to be
it's only a problem for people who are using Go, apparently.
Fair point. Yeah.
Yeah.
But that doesn't drive people away. I met somebody once, and he just said, I saw how many times I had to write that, and I just thought, no, proper dramatic. Yeah. So he wasn't happy.
That's true. And at that point, I might not have even spoken to them, because they didn't consider Go seriously enough to even make it through the filter of people for us to talk to. So that's true. That could have turned somebody off very early in the pipeline, and we just didn't find them.
Yeah. I think that's very interesting. Well, you see, I mean, I actually like it. I love the fact that we sort of are faced with errors all the time, and we have to deal with it in some way. I think that turns out to be a positive for us. But yes, I've heard that in the past. So obviously generics is a big feature that's coming, and this was one that was talked about in the community for many years before. This one is a reason why I've heard people avoid Go, because for a particular class of problem, generics kind of are perfect. So Rob, you've been tasked with the responsibility of making generics work in the tools. What kind of impact does it have, and what sort of work have you had to do there?
Yeah, I mean, it's been really interesting to see the way such a large language change propagates throughout the tools ecosystem. And there's been a lot of work on support for generics in tools, which is how I'm interpreting your question. And I think there's a lot of work yet to do. I'll say that it was nice to see how much just worked once we updated like the parser and type checker. A lot of things in the basic editing of code in Go Please, for example, just worked. But where we've seen the most update required is for things like static analyzers, things like the vet command that need to understand Go code. Well, now there's a whole new way to understand Go code. You don't worry about the type of a variable anymore. You worry about which types of variable could be. There's many types that are possible. And so how do we manifest that in tools is an interesting question and one that we're still exploring.
So, but with people with experience, like if they've used the AST stuff, if they used those packages, has that been completely rewritten, or is that it's just changed in a lot because of generics?
No, so we've had to preserve, we have the compatibility promise and we've kept that promise. So we have updated those packages to support generic code. So we introduced some new constructs into those packages, but we've done it in what we hope is the least obtrusive way possible. And so a lot of those packages deal with generic constructs, like what's an object in a program, and that we've translated into the generic realm. So that's why a lot of stuff just works, because those packages were updated in such a way that things just make sense, I hope.
Yeah, okay, that's very interesting. Well, yeah, we have a question from Aaron on Discord, and it's related to this. And Keith, this might be a good one for you since you've worked on generics, the compiler level. The question was, how are you measuring success of generics? How do we know if it was a good thing to have done or not in, say, 5 years?
Right. Well, I think the major signal there is adoption. Like, how much do people actually use it? How much do they get value out of it? And that's a very nebulous evaluator, right? So it's sort of hard to say, like, if we get X adoption, we've had success, otherwise we fail. That's hard, but we can look at more specific things like, are there libraries that people write that use generics that other people then use? And so we can look for all kinds of signals about how much adoption is happening, how much new sort of interesting code is being written, how many people go from a V1 to a V2 where V1 didn't have generics and V2 does. So there's sort of things like that we can look at. I'm sort of look at generics at a much lower level, which is, make sure it doesn't crash, make sure that, it's as fast as writing the code out with a code generator, sort of all that kind of stuff. And that I can get more concrete evaluations of that sort of thing. And so that's sort of where I'm at. I think at a higher level, at like Samir's level, they're thinking more about how do we measure adoption, and that's a more nebulous thing. I'm very concerned about, is generics 2% slower, and is that enough, or is it too much, and why, and can we fix it? That's the sort of stuff I concentrate on.
Yeah, okay, interesting. So on that then, oh, sorry, Samir, were you going to say something?
Yeah, I can pick this up if you want to hear the higher level success criteria. For the last several years, we've been running the developer survey now, I think at least since 2016. And
yeah, this is the 6th year.
Wow.
Right. And a few things have been sitting at the top of the what I want from Go list. And generics has been number one. Dependency management, I think, was up there. If you look at our issue tracker, fuzzing is up there. And better support in my editor. We've really taken all of that to heart, and really, we took our time with generics because we needed it to feel like Go. And I think Robert and Ian's talk this morning really showed the effort that was taken to really make it fit with the language really beautifully. Our hope is that it's not necessarily that we need people to adopt generics a lot. So it's not like more generics is better, but generics should solve the problem it's designed to solve. And so we want to really see that whatever problem people were saying, oh, we need generics to solve, that concern goes away. And if we've resolved that concern, if we've resolved dependency management, vulnerability scanning is another one, right? We resolve that. What then starts bubbling up in the concern list, right? So this allows us to look at the next set of concerns and resolve that. And hopefully we just keep making Go better for the users over time.
And if people want to influence that process, then I guess the developer survey is the way that you're asking
That's
them
a
to
good way to do it. Definitely.
Yeah.
Definitely tell me all about it.
Yeah. Yeah. Okay, so here's an interesting question from Segfault AX. Do you expect there'll be any changes to error handling idioms post generics? So this is kind of a general question in lots of ways.
So Matt, we did try.
Mm-hmm. You certainly did. We'll put the drums in post. Don't worry. That definitely.
Yeah. So we did explore simplifying error handling with the try proposal a few years ago, and our assessment, or the assessment of the community, really not ours, was that it didn't make things better. That the explicitness, the debuggability of the current way of handling errors was simply better. That all the work we tried to do with sort of condensing the syntax and then moving the handlers up to defer, it just made things worse. And so I think this is a case where we really want to understand what is the problem, right, that users are struggling with. And I think people like Alice and Todd, our other UX researcher, can really help us dig into that. And that'll help us understand what solution we should be going for. But I think we need to understand the problem better first.
I think it is an interesting question of whether generics is a new tool in the toolbox that can make a new interesting design that may be better in some way or another. And I don't think anyone's come up with a good answer to that question yet, but it's certainly something to explore.
Yeah, I mean, for sure, like if you've got code that's working in a generic way, I expect the errors to kind of work in a generic way, potentially. Like if it's going to return some object that contains a value that, there's some error to the value or whatever, then I could see that kind of thing happening quite easily. Is anyone worried about us overusing generics? This is one of the big arguments that people make against having generics in the language, is that it can be abused. How do we feel about that? Are we worried?
Yes.
What's the remedy?
Education, I think, setting a good example. But honestly, we need the community to help with this. This isn't something that can come top down, right? I think, Go has a reputation for being a simple, comprehensible, readable language. It is very easy to use generics to create things that make code inscrutable. And so I think we as a community, when we do code review, when we adopt libraries, need to be conscious of the trade-off we make between perhaps a deep functional one-liner that is very concise but very inscrutable, hard to debug, hard to manage the performance of it, versus the more explicit way we write things in Go that, yeah, costs you a little bit more typing, but when you have to debug it and optimize it, it's way simpler. So like that's where my head is at, but I would love to hear from others on the panel.
Any of the takers?
Yeah, one thing that is coming out in 1.18 is generics for the core, but like much of the standard library doesn't have any generics in it. In fact, there are only a couple of packages that were added that had generics in it. Most of the rest of the standard library is still pre-generics. And so we want to find a way, probably in 1.19, to make some of those packages generic. And when we do that, we'd like to set a good example by making them generic in a way that makes sense. And so I think to some extent, we'll be piloting a good, I don't know what you call it, a good experience with converting existing code to generics, and maybe in addition, adding like the maps package or whatever, some other new package, and what does a good generic code look like? And I think that will help. And if you're interested in what good generic code looks like and don't want to wait for 119, you can sort of follow along in the CLs or on the issues to look at what the prototypes look like.
Mm-hmm. Very cool. So do you expect there to be generic versions of some of the libraries and you can kind of have both because of the backwards compatibility? Or will there be types alongside non-generic types inside the packages? How do you see that happening?
Well, we're certainly not going to break any existing code. So we sort of have to leave the things as is. There's some discussion about how we might add generics in a backwards compatible way to function so that sort of the type inference all magically works out. I don't think we know whether that's possible yet, but we're talking about it. And if not, then there'll be a set of parallel, different packages or different names within the same package that will be the generic versions of various things like container list and whatever else.
Yeah.
And you could automate migration from, the, say, interface-based version to a generic version as well. But that should be fairly straightforward.
Oh, I see. Yeah. Help people out with tools. Mm-hmm. And speaking of tools, yeah, I wonder, what was Cameron, the biggest challenge? Or what was the hardest thing to do when trying to get generics to work with the tools? Was there one thing in particular that stood out as difficult?
I would say that Robert's probably the better one to speak to this, but I can say that the overall theme has been that because this is the biggest change that we've ever made to the language, by its nature, it's very deliberate. I couldn't identify a specific thing as well as Robert could, though. So maybe I'll yield to him to potentially give you a better answer than that.
Okay,
yeah, I mean, I can tell you the package.
Oh, yeah.
So the more that a tool needs to understand about your Go program, the more difficult it's going to be to update. And so in our code base, the most sophisticated package that we have like this is the SSA package. And so there's still more work to be done there. And I know other external third-party tools like Static Check also use a form of SSA. So those things are hardest to update.
Mm. So with the Reflect package, is it that there'll be extra methods and things in there, but all the other stuff will still work, but you need there'll be a way to find out if it's a generic type and things like that get added?
So it turns out that a lot of the Reflect or a lot of the generic stuff is completely gone by the time you get to runtime. So there's very little in Reflect that needs to understand anything about generics.
Does it just see the types that they end up being then?
Right. So if you have a generic function that has a generic type in it and you make a reflect value out of that thing, if you ask what type it is, it'll be the real concrete type of it. It won't be the generic type of it. So almost everything in generics is in the compiler. There's some stuff at runtime, but it's pretty minor, like putting better stack traces than you would get otherwise, and various inlining heuristics and stuff. But all that stuff occurs at compile time. There's very little at runtime that you need to worry about, and particularly Reflect is all going to work the same way as it did. The names will be a little weirder because they'll have brackets in them, but otherwise you won't notice a difference.
That's very interesting then. Yeah, so obviously generics was... Sorry, yeah, Rob.
I was going to say, Keith just reminded me of one other thing that was difficult, which is producing good error messages.
Ah, right. Yeah, well, we do appreciate good error messages, to be fair, so it is worth it. And actually, that's an interesting kind of point. When we think of generics was at the top of the developer survey most wanted list for a while, but how do you decide what to work on? How does that happen? Does it happen somewhat organically? Do you have some process where you think about it? And I'd also like to hear your thoughts more generally. And we had a question specifically on Twitter from Tim Heckman, who asked about governance and how you think it should be, how these things should work and will work in the future.
I guess I'll take this one, or at least start us off. Yeah. We do want to be informed by our users. So we start with our users, and the developer survey is one example, but Allison, her partner Todd on the UX team, have done a number of studies to really help us zero in on pain points. And then our product team, Cameron and Steve, look at the broader ecosystem, look at specific users, use cases. They look at, specific, they look at things in aggregate and also look at the strategic landscape, like how is software engineering changing? So as I mentioned earlier, one thing top of mind is security. When we interviewed certain large-scale enterprise customers, one of their first questions was, how do we check Go programs for vulnerabilities, right? And there's a compliance reason for that. But it turns out when we interviewed the users, like, it's top of mind for all the developers because it's scary, right? And so we knew we wanted to make that streamlined and easy. And it turns out that the work we did on modules actually really helps us with this, right? So we're able to build a vulnerability checking system that leverages modules and packages. And then we have a team that works on deep static analysis. We're able to leverage their work to really build something much more precise than you might get just checking the module level for finding vulnerabilities. So it's a bit of looking at what developers are concerned about and how to meet those needs, and also looking at what assets we have. Like the fact that we have modules, the fact that we have static analysis means we can do something really interesting that still helps solve the user problem, but in a differentiated and better way. We save you time by eliminating a lot of false vulnerability reports, for example. That's just one example. I think the other major driver is that we have a lot of users, and users are going to have production issues, scaling issues, performance issues, and we will get reports from all over the place. And then we've got our IDE and web. So we do listen to our users and we prioritize the issues we're hearing from them. And some of those turn into larger projects to make, strategic changes to what we have.
I think I'll add a little bit. It is a bit organic, actually. We all sort of think about this together. We take all the data that we have, we synthesize it, we try to see what's prevalent in the landscape overall, and how we're fitting in that scheme. We're also thinking, and this is similar to something Samir said, but maybe a little bit different, is we think about the whole end-to-end experience. We think about like what it's like to be a Go developer, what you are trying to achieve as a Go developer, and of those options, how can we be sure that each part of that chain is accounted for and is a good experience? And if it's not a good experience, how can we make it a good experience? And then we think about how we're going to integrate with, like, security, for example, which is a really important topic right now. And we know that Go is very well positioned for that because it's always has a strong focus on security from the start. And now that it's becoming a more important, scarier issue, we think we're well positioned to work our strengths, think about that end to end, and say, all right, at this stage, what kind of security would I want to be thinking about as a developer? Do I want to what vulnerabilities do I want to know about right now? And what do I not want to know about at some certain stage? What might overwhelm me and detract from the overall experience? So, the sum of my message there is we try to think about it holistically, and we start with the user in mind and the user's goal as the sort of end of this journey, and we try to pack in all of our data and everything that we learn, and then talk about it internally. And we're all very passionate about making Go a better product. So together we're able to accomplish this, and we're always interested in hearing from the users as to how we're doing and how we can do better and what we may be missing.
Yeah, very interesting. And actually, there was a release today on this very day. Go 1.17.5 and 1.16.12 were released. And that was they're somewhat probably easier decisions to make because these are security related. What's the sort of process for that? How do they happen? And at what point is there a decision that this is important enough that we're going to do an update and a release?
We have an extremely talented security and releases teams who make these decisions, and they basically say, we need to do this. And we say, we're not even in their way. Basically, I got told yesterday that it was happening. I got told this morning that it was done. And, there's a deep trust in the expertise these teams have.
Yeah, no one's going to say to the security team, nah, it'll be fine. You can never say that, can you?
You only live once.
I do think this serves what Cameron described and what we were just describing bridges a bit over into governance. Go is unusual in that we have this, talented, well-paid employed team at Google who's driving this major open source project. We do try very hard to engage productively with the community, and we've tried to increase our transparency over time. I think Russ Cox has done a lot of work to make the proposal review process more transparent and things like that. In the end, we also try and build a highly functioning cross-functional team that leverages the diverse talents we have, like Cameron's analysis and several others. And we believe this is an asset to the community. We serve the community better by building this highly functioning, well-managed team. If I can take some credit for that. So the question of governance comes down to what are the problems we're trying to solve, right? And this is where we want to hear the community. Like, what's not happening that you would want to see happen? Because governance is a solution to a problem. And again, we'd want to really understand the problem well to understand how best to serve the community in that way.
Yeah, no, that really does make sense. Okay, so we've got a fun question coming at you now. We're going to do a quick round table. I'm just going to say your name and then just tell me what IDE you use day to day generally. Samir, what's your IDE?
Google Docs at Gmail. No, on the rare times that I code, it's VS Code because I want to use what the team is developing, the VS Code IDE plugin, Go Please. But it's rare that I get to code. It's sad.
Yeah. I should just say this question came in from Billy Drop Tables. And Billy wants to know what everyone's IDE is. Cameron, do you use an IDE?
Well, I certainly don't do any of that for work, but in my own time, I am a Vim user, but also a VS Code user because I like to use our products and know what's going on. But previously, Vim.
Oh, Vim. There you go. You've just
previously Emacs over here.
Oh, there we go. Yep, it didn't take long, did it? You've just earned loads of street cred, though, Cameron. By the way, Alice, how about you? What's your IDE of choice?
I've actually got VS Code on in the background here. I don't have to code very often. Mostly it's just R scripts, because I'm just doing some data analysis. But VS Code is it's handy.
Yeah, so. And you've got it open now. You're just working on something.
Yeah, I was just working on generating some graphs.
Fair enough. None taken, Alice. This fraction of your attention we're getting is great. So don't.
Yeah. It's yeah. I mean, it's definitely on a different screen. It's like.
Oh, what can you?
Not even looking at it.
Yeah, it doesn't count if it's not on the same screen. It's not rude.
Yeah.
Rob, how about you? You work on tools a lot, so do you have to use the same ones that the users are using too?
I primarily use Vim, but I also work on VS Code, so I use VS Code as well, so I can understand the way that Go Please looks in VS Code and in Vim, and sometimes I even use Emacs.
Oh, there you go. And then what about you, Keith? What's your IDE?
I'm an Emacs diehard. So I use Emacs with a bunch of plugins. I've tried the VS Code, the Go Please plugin, which works pretty well. And I've got that set up on my Linux machines. I still don't have it set up on my Mac, which I need to do. And that's sort of my primary sit down and code platform. So I still don't use it day to day, but I have used it in the past. But yeah, Emacs is my editor.
Yeah, these text-based editors, because I use the mouse or a trackpad, so I've never been into that. And I used to have Windows, and so there's so much point and click and stuff in MS Access and Visual Basic. But yeah, when I see that it looks like magic still. It looks like the Matrix, like people are tapping stuff and things are happening. It's amazing. I love it. So, okay, we have another question here from Makaki. They say, "Hi Go team, if there was anything you wanted to remove from Go, what would it be?" And so this is assuming that there's like a go-to, or you can do breaking changes now. What would you break? And Keith, since we're chatting, why don't you start?
That's a good question. I'm not a big fan of the 3-argument slice operation. I think there should be a slice to length and slice to capacity operations as separate things. And I lost that argument many years ago when we first edited it, and I'm still angry about it.
So you would have had 2, so you could either specify the capacity or the length. Is that right?
Right.
Yeah.
Yeah. You often don't want to modify the capacity. You're generally just slicing because of the length, and it's only occasionally when you need to talk about the capacity.
Yeah.
In which case you don't need to talk about the length, or you could do that as a separate slice. It makes the language a little bit simpler. But But yeah, otherwise, yeah, it's not a huge deal. It doesn't come up one way or the other either all that much.
Yeah. No, but that's a nice answer. Rob, do you have an answer for this? What would you like to get rid of?
It's really tough. Nothing significant. I think. I think it's easy to answer this once we land generics, right? There's a lot of stuff that we would write differently if we had generics. A lot of the built-in functions would be just a generic function. Yeah. So I think that's probably, it's kind of, maybe it's a cop-out, but that's my answer.
No, but that's a good point. And like with generics, that's the interesting thing, isn't it? You almost wish you could just go back and rewrite the standard library in this. And to be honest, there's even code in the standard library that doesn't now look very Go because it was written so early. So that's sort of always the curse you bear, really, with the backwards compatibility promise. But everyone's grateful, I think, for that promise. And any others? Anyone else got anything that they'd remove from Go if they were allowed to? Samir, what would you do?
I'll mention a few. Range variable loop capture. So this is just, it bites all of us when we write a closure inside a range loop. That may still be fixable. Depends. I think the confusion around nil pointers inside an interface and that not being nil itself, like the whole question of reuse of nil in interfaces just creates a lot of confusion. I wonder if we could have done better there. And buff.io scanner. I don't like APIs where you run a loop and then you have to check whether the loop exited because of an error because you always forget to check. And I'm sensitive to this because back when I used to write C++ and I was on the maps team, I had a loop. I had a similar API where I forgot to check for an error, and I dropped 500,000 places from the map index.
Oh wow! Because
I forgot to check that error. So when we introduced buff.io scanner, I'm like, no, that will create really terrible bugs. But again, lost that argument.
Did that just wipe out like loads of restaurants?
No one noticed. So I think if you drop 500,000 random places from, the location index, you're unlikely to hit stuff that's very important.
Oh, wow.
But,
there you go.
I stayed up late and fixed it.
Yeah, just type them all back in from the phone book. Very nice of you. You got to
regenerate the index. Yes.
Okay, fine. Yeah, sure. Yeah, they're good ones. I would actually probably like to get rid of the new keyword and just have the curly brace way of making things, because I always use that anyway. And now if I see new, I'm like, what? Although I quickly do remember, to my credit. Okay, so will there be a go-to? Johan Brandhorst actually asked this one on Discord, and so did Tahal Altinel. So did Tahal Altinel. Will there be a go-to?
I don't think we're going to make breaking changes to Go. I think we'd rather find ways to support people, fix things, like maybe some of the things we just described, range variables, for example, without breaking users. Like maintaining compatibility for users, like we would much rather do work on our end to minimize the work that, the whole Go community has to do to adapt to these changes. So I think once you set aside breaking changes, go-to becomes a marketing term. And I think it would probably break a lot more things than it would fix.
I think the one remaining big language thing is the errors problem, and whether we ever come up with a fix for that, and whether that fix requires language changes and how extensive they would be. I could conceivably see something go-to coming out of that, but I don't see anything else even on the horizon that would force us to go to a go-to.
Now, I suppose it would just be if it'd have to be a significant enough change, wouldn't it, to warrant something like that. But I'm kind of glad that we don't have these multiple languages, like Python code from one major version won't work on another. And the fact that our Go code has that long life, I think really does help us out a lot. And we sort of rely on that, which is pretty important. Anyone else? Anything else they'd remove? If not,
maybe the G.
Sorry,
keep it BO.
Just
remove the G.
Yeah, that'd be good. There you go. That's cool. Yeah.
Make it easier to do the internal Go links.
Yeah, that would be easier. Typing out most project names would be one character easier. Yep. The command that kicks off a background, kicks off a Go routine, would just be O.
There you go.
Would just be an O routine at that point. Yeah,
I mean, yeah, 50%. You know, just cut that task time in half.
Yeah, honestly, the amount of internet that would save. I don't know the exact numbers, but I think it's a lot.
I like the idea that O is just the completion of the C.
Yeah. There you go.
Yeah, there you go.
Missed opportunity, Alice. A good call.
I wasn't on the team back when.
No, it showed. Yeah.
Too late now.
Well, maybe the next breaking version, you can really break it by changing its entire name. It'd be Olang. Yeah, it could. I'm not against it. Okay, there's another interesting question that came in from Def Piano on Discord, and Def Piano asks, do any of y'all use GitHub Copilot for work, either Go or another language, or on personal projects? Have you played with GitHub Copilot?
I don't think I know what GitHub Copilot is.
Oh, Keith, it does your programming for you. It does all your programming for you.
Well, then what would I do day to day if it did all my programming for me?
Chill out. Chill out. No, you still have to do some programming, unfortunately. But
I could day drink instead of doing programming. It'd be great.
Does it look up things on Stack Overflow for you?
It learns, yeah, it learns, and it knows smart enough not to pick the top answer to scroll down a bit, which is
always go with the second answer.
Yeah, exactly. Well, yeah, it's kind of well, I'm not going to sell it. If you've not heard of it, I think that speaks volumes. He does all his programming himself, does Keith. Yeah, this is actually, we've reached our time. This is all the time we've got. But thank you so much to everybody who's joined us and joined along and asked questions in the Discord. And thank you to Samir, Cameron, Alice, Rob, and Keith. And we'll see you next time on Go Time. Sorry for the abrupt ending, but that's just live.
Thanks so much to the Go Time team
We're certainly still on the podcast
for doing that AMA and everybody who contributed questions in Discord.
I guess Matt too.
Matt,
So thanks, Matt.
Yeah, it was good. Yeah, it's good to see Matt. Hey, Matt. Hey, mate.
Hey, Matt.
Definitely. Yeah.
Yeah, so we're like wrapping up the day here. We've got one more session, but feel free to hang out in the Discord and go for town. And if you haven't taken an opportunity to stop by and thank our sponsors, either in Discord or Go for Town, or by hitting their links for some of the giveaways and things that they're doing, please take the opportunity to do that. Also, special thank you to Capital One, Salesforce, and Microsoft for kind of helping us bring this live in this studio at the last minute when we needed to go virtual.
Mm-hmm. Yeah, they've been huge for that. Absolutely. Yeah,
we appreciate that.
I mean, we're freezing, but
well, they sprung for a little bit of heat in the middle of the day.
Yeah,
but I don't know.
That went out the back door, maybe quite literally.
They're like, you can use the cameras, you can use the crew, but
bring your own heat if you must.
BYO, yeah, BYO space heater.
I mean, maybe they were expecting that I'd have that 3090 like I did last year, where my office was literally a sauna.
Yeah, right.
So who do we have up next, Aaron?
So we have got Arish Labroo. Arish is a principal engineer at Zillow. He's going to talk today about a case study, which I love, these use cases for Go. I love hearing about this. He's going to talk about how we go at Zillow.
I'm particularly excited to see, like, my home value has been skyrocketing.
Yeah.
Like the Zestimate on it has gone through the roof, and now I understand it's the performance of Go is really helping.
Exactly.
I'm actually more interested in those used cases you were just talking about. Like
used cases.
Yeah.
Is that different from a use case?
Yeah, man, it's cases that have been used.
I see.
Yeah.
So use case is current. Used is how we used Go in the past.
Nah, man. You have a box, you have a case, and it's used. Dude,
I'm slow. I didn't have lunch. This is what happens. I'm sorry, everybody. All right. Yeah. Should we throw it over to Arish?
Yes. Let's do
All
that.
right. Take it away, Arish.
Thank you. Hello, everyone. I'm Arish Labroo, and today I'll be talking about how we build Go services at Zillow. Most of my slides are code snippets, actually, which you can go at this repository if you have any feedback. Zillow has a lot of services, actually, a lot of services built in different languages and different stacks. And a few years ago, one group started advocating using Go for production applications and services, and it grew in popularity. More and more teams started using it, and we started seeing some patterns and practices emerge, which we wanted to standardize on. Zillow has an amazing developer experience team, which in addition to managing our deployments, containerization, CI/CD, observability tools, and stuff, they also manage archetypes for all our stacks. So we started out with building our archetype for Golang with certain goals in mind, right? Consistency was huge. Every service, every deployment should look and feel the same, so that if you're jumping across services, there are no surprises. We write a lot of services, microservices, some more broad scope services, but a lot of services. They should be maintainable. The underlying components, a lot of cross-cutting concerns change more often than we would like them to, but anytime something has to change or we need to add a more core feature, it should be easy to distribute that across all the deployments. If you have hundreds and hundreds of services, small changes like adding new traces or new metrics become a year-long effort. So we wanted everybody to get that automatically. Resiliency is a must for a production-grade Zillow application. Reducing the blast radius, minimizing the impact of errors and stuff like that. Observability, we need to have ability to comprehensively observe our production applications. Logging and metrics are obvious. Distributed tracing, you need to have an end-to-end comprehensive visibility on how your application is performing. Throughout this talk, you will see how pervasive tracing can get, and you have to be very conscious about opting in at every step. Testability. Every application has to be thoroughly tested. Unit testing support in Go is already great. What we found out, bigger value was observed when you wrote end-to-end integration tests, right? So you can, if you can, don't worry about all your fringe dependencies, and then test your application and business logic comprehensively in your test. That provides a lot more confidence. So with these things in mind, we set up on an architecture. Most of our services, most of our deployments look more or less like this. We have an explicit transport layer. You have your service logic, the application domain, and then you have all your dependencies. Dependencies are more or less the same across all applications. You either read or write from database. You have to emit events, or you make HTTP call to downstream dependencies. Transport layer is interesting because all of our services out of box are 100% transport agnostic. What that means is, no matter if you're calling your service as a HTTP REST endpoint or an RPC endpoint, or you're passing messages over a durable transport, your service should not care. All the transport-specific logic terminates in the transport layer. Unmarshalling JSON request body, decoding binary encoded protobuf messages, reading from Kafka or SQS, should all be transparent to your implementation. All the expectations that you can have from one transport, you should have from the other transports too. We actually have services in production which are used both with REST and RPC, and they all have workers, which process the same requests over a durable transport. We use HTTP primarily for reads, and most of the writes are through SQS or Kafka. Separating your reads and writes CQRS style. And even if you make a write request over HTTP, we immediately offload that to a queue and process it asynchronously. And it gives you nice reliability guarantees. So in this talk, we'll be primarily focusing on how we standardize on these components so that individual developers, hundreds and hundreds of developers, can focus on the requirement, on the business value that they're providing, while a lot of these cross-cutting concerns just light up for you. Let's start with the server. HTTP server, RPC, REST. However, there's an HTTP server, and setting up a server in Go cannot get simpler. You have the HTTP default serve mux. You have HTTP server. You just listen and serve, and you have an endpoint which is handling your requests. This is not production ready. There are a lot of things that are a lot of non-negotiable requirements that every server has to implement. You need to have timeouts on your connection. Request handling has to be capped with certain time so that slow clients or slow requests don't bog down your availability. You have to handle graceful shutdown, OS signals, giving some buffer for in-flight requests to complete and not serve any more requests. Simply you just listen to the signals on a separate Go routine. Distributed tracing, again, distributed tracing is very persistent. Every hop across every transport, ingress or egress, you have to be cognizant of propagating your traces, propagating your context. Because if you miss even a single hop, the traces are rendered useless, right? They will get new trace IDs and there's no correlation, and you don't have end-to-end visibility into how a request performed. So you can wrap your request in a open tracing net HTTP middleware, where every request automatically is processed under a span. The tracing context is propagated in the request context. Or like we use Datadog for tracing and visualization, amongst other things. They provide a serve mux that we use, which is similar in behavior. It wraps your request, creates a span, adds a few additional tags, which just light up in the trace visualizer. No matter what tracing tool you are using, you have to be aware that every request needs to work under a tracing context. Health checks and probes. Our infrastructure mandates that we have probes available on every server, every live server in production, health check, liveness check, readiness checks and stuff. And in addition to just returning like an HTTP OK response, at times you would want to check that your dependencies are behaving. Your database is available, your downstream dependencies are available. So these health checks, these probes need to be extendable, specific to application requirements. Swagger, right? We describe most of our services in protobuf. And we use Twitch's twerp RPC framework. The beauty about twerp is it does all the content negotiation for you automatically, and you can serve REST as well as RPC endpoints from the same server. It takes care of inspecting the headers and unmarshalling or decoding the request so that you don't have to worry about what was the message format. And since our services are described using protobuf, we use the Proto-C Swagger Gen plugin to generate Swagger specification and use an open source HTTP Swagger package to host the Swagger UI. So every HTTP server has a /Swagger endpoint automatically readily available without individual developers having to worry about this. Great for documentation, ad hoc testing. You can just simply curl this server. And there's a bunch more. Every request we would like to be profiled automatically, logged. Metrics, you need to have a metrics endpoint where the Prometheus server can scrape with some metrics already registered, collectors already registered automatically. You need custom request context propagation. So if you have some configuration flags or user ID or user token available in the request headers, it would be nice if they automatically light up in the request context. Authentication, security headers and stuff. So when you take all of this into account, a simple server becomes a few hundred lines of code, and this is all required features, not recommended, not nice to have, must have features that every server has to have. And we don't want hundreds and hundreds of developers have to duplicate this every single time. Again, nothing special about this. Everybody knows this. We just don't want to lose it in any service at any hop. So what do? To standardize server behaviors, we create a simple server abstraction. It's a simple abstraction around HTTP server. It has a handler, which is your serve mux. We use Datadog's tracing wrap mux. If you use Gin, and you can adapt your Gin engine to this interface, or Gorilla's mux, it just needs a simple handle function. We pass in a configuration. Everything about the server is configurable. Where is the Swagger file hosted? What are the timeouts and what port and all that stuff. Configuration can be read from environment variables or configuration files and whatever. And the server has a simple serve. This is where we spin up the HTTP server, correctly configure it, add all the default routes, listen and serve, and also handle graceful shutdowns, right? So now, and server has a simple constructor, which will give you a default server instance, and you have functional optional parameters that you can pass to modify behavior. And then, using this new server, this incomplete implementation of an HTTP server becomes this. You new up a server, and you add your application-specific routes. This server is already more featureful, more resilient, and more complete, but this is still not production ready. You must have noticed that the server has other members like the logger, the tracer. Configuration needs to come from different sources, metrics handler, and stuff like that. We don't want every individual application to worry about composing these dependencies too. And we don't want the server to be opinionated about how it logs or how it traces, right? The logs need to be contextual. They need to be correctly scoped to your request. Tracing needs to be configured for your application, for your environment. Configuration sources can be different. So if we had to request, either make these as required parameters in the new server, the constructor, or we make sure that everybody passes this as options, that's still a lot of overhead in every service. So instead, what do? How do we simplify and standardize on creation of this server? We have a server factory. If you have an immediate aversion to factories in Go, I promise you, for standardizing and consistently creating opinionated instances of certain common types, factory is a great creational pattern, actually. Factory has a simple create, which gives you a server. Factory has a lot of these members, the loggers, the tracers, and all that stuff, which somebody needs to compose. Like, for example, the factory's constructor would look something like this, where all these parameters are required. How a factory is actually composed, we'll talk about that towards the end, how we do composition in our services. But let's just assume there's a factory from which you can create a server while still keeping it configurable to your application's requirement. And now, instead of initializing the server yourself, you have a factory. You get an instance of a factory. You call create and handle your application-specific routes. Now, this is 100% production-ready, featureful HTTP server. It has timeouts, shutdowns, context propagation, tracing, all the probes, Swagger, and all that good stuff for you automatically available. And the best part is, if we wanted to introduce, across the board features into this server, exposing a new endpoint that by default should be available everywhere to, or we need to enable pprof, for example. We don't do that in production, but you see the point, right? There is one place, one library where we have an opinionated server which we can change. Everybody just updates their package, and everybody gets this feature for free. The factory is still customizable. You can pass in options. For example, here we are extending the health checks to ping the database and see that the database is available. But more or less, this is how a server initialization works at Zillow. So along with the server, another deployment model that is very popular at Zillow is a worker. Worker is a long-running process, which is reading messages from Kafka or SQS or polling databases at a regular interval, cron-like operations. We build a lot of systems as event-based at Zillow. So we pass a lot of messages over durable transports. And the best part about workers is, you can scale them horizontally, reading from different topics or different queues, or where different request types can go over different queues. Most of our services are like one server. You have one HTTP server which you can also scale, but we have many different workers. So setting up these workers, it's paramount that it is very simple and seamless to be able to spin up these workers easily. Let's take a look at Kafka worker, for example, right? For a Kafka worker, let's consider that we have this Kafka abstraction, which takes care a lot about, all the intricacies and the complexities of reading and writing from Kafka is handled by this Kafka client. It has a very simple exported surface. You have a client from which you can get a reader, and from the reader you can read messages one at a time, right? So let's say this just automatically lights up from somewhere. The composition of this package follows the same pattern that we'll see eventually. But for now, let's just say there is a Kafka client. If you want to build a worker, a simple implementation would be, an incorrect implementation would be start a forever loop, read messages one at a time, and process them. This is not comprehensive. This is not production ready. This is not deployable, at least at Zillow. It doesn't do timeouts. Similar to HTTP requests where you don't want a slow request to bog down your server, we don't want slow message processing to create a bottleneck in your worker. Simple implementation, you have a with timeout which is configurable, context with timeout which is configurable. You need to handle OS signals too. Circuit breaker is something that we ideally want every worker implementation to have. So that if message processing is failing above a certain threshold, we want to slow down or maybe even sometimes stop processing more messages, to give some breathing room to the dependencies if they are having issues, not overwhelm them. Or if your worker itself is having issues, having more messages go into dead letter queue or having to move the offset around in Kafka is irritating. So ideally we have some circuit breaker implementation, so we reduce the the blast radius. We use Sony's Go Breaker library, which is completely configurable, very simple to reason about. Again, distributed tracing. Distributed tracing will show up literally everywhere. Just like HTTP request, where we had a middleware, when we are processing a message, we need to extract the tracing context automatically and light up and do the processing underneath a span. We use open tracing, which has a text map reader and a text map writer interface. The implementation is transport specific. For example, Kafka has a tracing context in the message headers. SQS has it in attributes. Sometimes you have it in the request body itself. So extracting that context, creating a new span under this context as a child of the parent context, parent span ID, and then passing it to the actual processing context so that it can propagate it down even further is very important. And it's not optional. We need it to be done consistently every time. So we we extract the context for you, and when we call process, the context already has the correct tracing context in it. Concurrency. Concurrency is best left to your application, right? That's the recommendation. But doing concurrency consistently has a lot of boilerplate. Even though Go makes it super simple, but having concurrent evaluation of circuit breaker features, error groups, context propagation, having bounded number of Go routines that are running at the same time. If you're using SQS, for example, you want at least the max number of messages being processed concurrently, otherwise the revisibility timeout kicks in. For Kafka, you want at least the number of partitions that you have to be processed concurrently. So, if we leave this on at each hundreds and hundreds of deployed services to do it consistently, there's a lot of boilerplate that everybody have to implement. Chances for errors go up. So we just do simple concurrency constructs for you behind the scene, and a lot more. Logging, profiling, metrics server. You need an HTTP server exposing the metrics endpoint for Prometheus to gather metrics, custom context propagation, like we talked about in HTTP. User propagation, if you have a user in the header or SQS attributes, you would like it to just light up. As I said early on, the implementation of the service is completely agnostic to the transport. So whatever expectation the service implementation has, we need to keep it consistent across transport. So all the behaviors that you would see for a worker is exactly, you can make the exact same request over a worker or over HTTP and the behavior, and there will be no change in your service implementation. Error handling, for example, is very important in worker, right? You don't want a panic in one message's processing to bring down your whole worker. So when you take all of this into account, this worker becomes, again, a few hundred lines of code, which we don't want everybody to have to duplicate hundreds and hundreds of times. Just like server, to solve this problem, we create a worker abstraction. Simple does a lot of heavy lifting for you behind the scenes. You just have to focus on your application-specific logic. Worker has a simple factory too, which takes care of initializing consistently all your dependencies. The factory has a simple create, which will give you an opinionated, correctly instantiated worker instance, and worker has a run. Server has a serve, worker has a run. You just pass it a processor, which is nothing but a function which takes a context, the correctly scoped context, and a function, basically the message, the message that you're processing for this request. And it takes care of timeouts, concurrency, tracing, error handling, all that good stuff. And usage is also super simple. Instead of doing this incomplete implementation, you create a worker from a factory and you just run it. Pass it your application-specific processing, and you are good to go. This is 100% production-ready worker. All right. So, server and worker are two more important deployment models that we have at Zillow. We actually, we have a lot more workers along with all our servers, but all of these services have common dependencies. Let's talk about databases first. Quickly how we do databases. The DB SQL package makes it super simple. Open a connection and do your database operation. This is not production ready. You're ideally supposed to reuse all your connections. One common pattern that we see is, hey, just create a global variable for your connection, and then it will be application scoped. The standard library will take care of the lifetime and retries and all that stuff, or creating new connections and all that stuff. But a global variable almost makes testing, end-to-end integration testing, impossible, right? Tracing, if anything in your application you want to trace comprehensively, if you want visibility into, is your database operations, right? How is your database performing? We want it to just light up for you. There's a lot of configurations on the connection that you would like to set up based on your application's requirement. We want you to be cognizant about it. We have some sensible defaults. We use SQLX, just because it's easier to work with strongly typed structs. And we want to use the contextual members, right? The DB has select and select context, for example. We would like everybody to use the select context always. So how do we do this? We have another abstraction. We have a provider, a very simple implementation which gives you a database SQL DB instance. Provider caches the instance for you, the key being connection string, a few other parameters, simple mutex around this cache. We use Datadog's DB tracing library to wrap database operations with the tracing context. And you can set up all your configurations here consistently. And you just, every time you need to make a database operation, you call this provider to give you a database instance. What this does not do, though, is the contextual members, right? There is no easy way to mandate that you only use the contextual member out of the package. One way is to create your own abstraction, which only has the star context members, but we didn't want to create our own abstraction around database. So we actually use linting, a tool that our teammate wrote, which uses the analysis package, totally configurable, rule-based. And one of the rules is that you have to use the context members, and it runs as a part of our CI/CD pipeline. And if you're not using the contextual member, it will prompt you. All right, and usage is very simple. You ask for a DB instance from the provider, and then you use it. And you get timeouts, configuration, tracing, all that good stuff for free. All right, HTTP. Every service has to make an HTTP request. Almost all the services have to make an HTTP request, usually reads. As I mentioned, we use HTTP primarily for reads, but even if you have to make a write request through HTTP, could not get simpler. Use the default HTTP client, make a request. This works. This is not production ready. You would like to be aware of timeouts that you set up on this request. By default there's no timeout. As I mentioned, we use HTTP primarily for read. Retries for transient errors is a safe default assumption, and we don't want everybody to have to implement retries. It's simple, but it is duplicative, it's boring. And you have to worry about jitters and backoffs and all that stuff. So a good comprehensive implementation of retries, which is freely available to you just via configuration, is ideal. Tracing, you have to make an HTTP request, you have to propagate your traces, right? Super important. And other custom context propagation. So what do we do? Just like everything else, we have an provider which will give you an HTTP client. We use HashiCorp's retriable library to give you a retriable client where all the behavior is completely configurable. As I said, we don't retry posts or writes, because then you have to worry about idempotency and all the other application guarantees. But transient error for reads is a safe assumption. But again, this is configurable. We set up the configurations on the client, like timeouts and all that stuff. What this still does not do, though, is anything about trace propagation, right? It does not participate in distributed tracing. The challenge there is no good way, at least that we have found out, where you can intercept every outgoing request automatically and inject or add request headers, right? There's the round tripper interface, but you're not supposed to modify the request in it. So we provide a simple helper, where you can pass in an HTTP request and your context, and it will inject headers into the request for you. Also, as I mentioned, we use twerp, the RPC client. The twerp-generated RPC client actually does not require an HTTP client type instance. It requires anything which has a do method, right? So we create a simple wrapper around HTTP client, where the HTTP client inside the wrapper is the retriable, completely configured HTTP client which we use, and we provide the do method, which basically creates a span for your request, injects the tracing header using the open tracing HTTP reader carrier. And now every request has retries, timeouts, tracing, and all the configuration correctly set up. And you have a way to get a wrapped client from the provider. Usage is super simple. Instead of using the HTTP default client, you get the wrapped client from the provider, pass it to your RPC generated client, and you have all the goodness for free. Again, where does this provider come from, right? We talked about provider, Kafka client, worker factory, server factory. Where do all these things come from? We'll talk about that in a little bit. We write to Kafka a lot. Similarly, every message that we write to Kafka has to have some consistent shape and structure. We want some certain headers automatically added, like a unique identifier, timestamp. The tracing context needs to be propagated over Kafka. So simple abstraction, we already talked about the Kafka client. It has a writer. When you write, pass it the context, and it does a lot of goodness for you. The actual implementation of Kafka write, we won't get into it. There's a lot that goes in there too. But let's just assume there's a Kafka client which does a lot of the heavy lifting to interface with Kafka. But this is a simple write method which does a lot of consistent message passing for you. Again, using Open Tracing's text map writer interface. All right, so we talked about all these components which at ingress and at egress. We talked a little bit about context propagation is important, tracing is important, metrics. We want metrics to be easily emitted. StatsD or Prometheus, whatever you're using, it should be configured and set up for you automatically. Logging is ubiquitous. And we do logging consistently. Every logs need to be contextual. Every logs need to be consistently scoped, right? So we have this simple logger interface that we use throughout all our services. The only point to note here is they take in a context as the first member. So when you actually emit a log, it has a lot of fields already automatically added with your log messages. We use Uber's Zap library for logging. Super amazing, super low overhead, super fast, super configurable. You can shape your log messages however you want. You can add initial application scoped fields at the initialization of the logger, like the application name, environment, process ID, host name, and all that stuff. In addition to whatever fields the infrastructure is going to add, and then you create a new instance of this logger which holds on to the Zap logger as well as a tracer, so that you can inject trace information with all your log messages. Like if your logs can be easily correlated with your traces, it's super powerful. So we would ideally want the span ID, trace ID, and all that stuff to be emitted with the each log messages automatically. And the good thing is you can go to your log visualizer and say, hey, give me all the logs for this request ID, and you get an end-to-end comprehensive view of how everything is behaving. Super powerful, right? So you inject using open tracing. Tracer which has been correctly scoped to your application, and when you log a message, in addition to the message that you're logging, you get like 30 odd fields also added into your log. Configuration, we use a lot of configuration. Everything at Zillow, every service has behavior is configurable. We like to have strongly typed and localized configurations, right? So many different small configuration structs which can be hydrated from many different sources. For example, host here can come from environment specific configuration file. API key comes from environment variable or HashiCorp Vault or AWS Secrets Manager or wherever. Timeouts can be, they have default value or they come from another environment variable. So, we have multiple sources for configuration, and believe it or not, the configuration sources change. We have gone through like console, Vault, Secrets Manager, parameter store multiple times. So we don't want everybody to have to worry about parsing these configurations. They should just light up for you. So you just create a configuration struct, and you give a newer for this struct, which takes this app configuration dependency. We'll talk about app configuration in a second. And you say, hey, app configuration, just load this configuration for me. Go figure out where all these members are going to come from and give me a correctly initialized configuration instance. And app config is a simple data structure. It's a map which stores the raw merged configuration for that particular key. In the newer for the app configuration, we basically use the conflate library, merge all the application configuration sources, and just hold on to it in the map. And when somebody requests a particular type, we use reflection to get the configuration name and unmarshal the raw message that we were holding on to. Now this is, all this unmarshaling, gathering the sources, reflection is just once per application. So there is no per request cost here, and you get strongly typed configuration, which is super helpful when you are doing testing, because it's just a struct. You can pass in whatever struct and modify the behavior in your tests, rather than having to set up environment variables in your test, which gets irritating. All right, so we talked about how we have all these cross-cutting components available to you for you to use, which offer a lot of consistency, resiliency, tracing, and all that good stuff. And we don't want everybody to have to worry about the implementation details about a lot of these functionalities. And I mentioned we'll talk about how these are actually composed in the end. How are they actually composed, right? Because to initialize them correctly with all their dependencies is a lot of work. What do we do? Let's actually take an example, right? It should help showcase this much better. Let's say we have a simple service, which on every request has to do three things: make an HTTP request, write to a database, and emit an event to Kafka, right? Not completely hypothetical. A lot of our applications actually do things along the same lines. If you had to compose this application yourself, this is what you would have to do. Right? Initialize your configuration, then your logger, your tracer, your Kafka client, your server factory, your DB provider, and all that stuff, and handle your request with all these initialized members. This is correct. This is 100% production ready, but this is almost impossible to maintain. For example, imagine the Redis client introduced a new dependency, a breaking change, because it always wants to consistently capture cache hits and misses, right? And you change the newer for the Redis client Now this is a breaking change for every application. All the hundreds and hundreds of services have to make code change to satisfy this new requirement. And if you make it optional, then nobody will pass it, right? And then you have to go beg every team, hey, can you please do this too? And it becomes a multi-year effort. So we don't want to have that overhead across the hundreds and hundreds of services that we have. Instead, we use Wire. According to the documentation, Wire is a code generation tool that automates connecting components using dependency injection. The beauty about Wire is in its simplicity. Like, if you have used dependency injection frameworks in other languages and stacks, they have a lot of bells and whistles, a lot of features and runtime inspection and stuff, which almost always end up biting you. Wire does none of that stuff. Wire is simple 100% human readable code generation. I'll give you a small example. Let's say you have this dependency tree where foo depends on bar, bar depends on boo, and boo has a simple newer, right? If you had to write this code by hand, you would initialize a new boo, you would initialize a new bar, pass it the boo, you initialize a new foo, pass it the bar, and now you return a foo, right? Simple. But imagine if this dependency tree was like n deep and m wide, it would get very irritating, very fast, and almost impossible to maintain. Instead, we create a Wire initializer, right? We create a set which has all the providers. Providers are nothing but a handle to your constructors, your newer functions, which says, hey, if you want to create a foo, use new foo. If you want to create a bar, use new bar. If you want to create a boo, use new boo. Whatever are the parameters that are required in this newers, Wire will take care of initializing them for you and passing them along. And then you create an initializer, which will tell Wire, hey, create a woo using this set that I just gave you, right? And it will know how to write this code, how to emit this code. This is actual generated code. This is exactly the same what you would have written by hand, but this is auto-generated. Now imagine if this dependency tree was huge, it's a big benefit because if there is an underlying change to one of the core packages, you just update the version in Go mod, run Wire again, and it takes care of it. You can actually put this in your CI/CD pipeline to make sure that you are using the latest and greatest core components, and every service, every deployment is consistent always. So how do we use Wire? We provide a Zillow-wide common Wire set. The actual production set does not look like this. It's more pluggable, smaller sets. But we have a Zillow-wide Wire set, which has all the newers for all these common components. And if you have some indirection, for example, like logger is used everywhere, but we don't want every package to have to depend on a common logger package. Like server has its own local logger interface, Kafka has its own local logger interface, which is shaped the same as the logger that we use throughout Zillow, but it's its own package, its own type. So we can tell Wire, hey, when you need server.logger, you can actually pass it the default logger, right? So we create this Wire set with all the initializer, and now in your service, you just have to say, hey, in my service, I need somebody to give me a server factory. I need somebody to give me a database provider. I need to give me somebody to give me a Kafka client. Who's that somebody? That somebody is Wire. And you don't have to worry about how they are initialized. Whatever their dependency tree is, somebody else will walk through that. And you just have a way to create your server where you just handle your application-specific routes, create the server from the server factory, handle your routes, and Wire. Handling your requests is exactly the same, right? Because all your dependencies that you are requiring are available in your My Service, and you can make your HTTP request, Kafka request, and all that stuff. And to initialize this server, you just create a simple Wire initializer, right? You say, hey, give me a server. Use the Zillow-wide common set to populate all the dependencies. And one additional dependency that my server has is this My Service. Populate all its exported members, right? And most of the members of My Service come from the Zillow common set. Now, instead of doing all this handwritten code, this is all your server looks like. Your server has a simple newer, and Wire generates all this code for you. Super maintainable, super low overhead for people to start creating new servers consistently. Another huge benefit that Wire offers us, not just Wire, if you're using dependency injection or inversion of control in your application, it makes testing your service end-to-end that much easier, right? Your application just depends on this my service, which has some of these types, which are composed by some applications, composition root. You can substitute them whenever you want with mocks and then reason about your application. Your application code did not change. It's 100% the same code that you would like to test comprehensively, just your fringe dependencies, which you don't care about. Like, you don't care about if Postgres works or not. You don't care about Kafka works or not. In your application, you only care about if your business logic is working or not, right? So we, along with a Zillow-wide common set, provide a Zillow-wide common mock set, where all these dependencies are substituted instead with mock implementation. Wherever appropriate, we have interfaces for these types, and we use mockgen to create mocks, which you can set up in your test, assert in your test, verify behavior and stuff like that. It just makes testing that much easier. For example, when you want to initialize a testable server, you want to use your same server that you have been working with so that you can test your application logic, but you just want to substitute where the database comes from so that you can pass in a SQL mock database or an in-memory database, or if you want to use an actual database in your CI/CD pipeline, it does not matter. The actual server doesn't care about who provided what database to it. It just expects somebody to compose a database provider for the server. Similarly, Kafka can be mocked. The database can be mocked. The HTTP client provider can be mocked so that you can intercept your outgoing HTTP requests. So you just tell Wire, hey, when you are newing up my server this time, instead use the common mock set. Don't use the production mock set or production set, but use the production mock set, and give me an instance of this server testable, so that I can use this in my test. And your server remains the same. This is where your application code lives, which you want to test. And then you can write a comprehensive end-to-end, starting from your transport to your dependencies, single test case. If you are into code coverages, this will give you 100% code coverage of your application. You have intercepted your outgoing HTTP requests here. You have set up some expectations on your database and verified that they are happening. Similarly with Kafka, you set up your expectations and then verify that the right message was written to Kafka, and then you just use the HTTP test package to create a request, pass it to your actual application server, the system under test, and you have comprehensive end-to-end integration testing using Wire as a dependency injection framework. We're not saying dependency injection is the only way to write testable code, but we find it to be least intrusive and a very efficient way to write, consistent way to write testable code. And with Wire, it's very idiomatic, it's very human readable, it's very low overhead, it's compile time, there's no runtime magic here. It's code that you can still reason about. One big concern about dependency injection is I don't know where my stuff is happening from. It's generated code which you can see and understand and follow. So there's almost no magic. And since it's compile time, if you have composition errors, it will just tell them in your CI/CD pipeline or when you run the Wire tool locally. As I mentioned, you are testing your actual server. Like, for example, here you're writing to HTTP, to your database, to Kafka. You are verifying all these behaviors are working 100% consistently. That's pretty much it. Those were most of the core components that we have at Zillow to write a Go services. I think we achieved some consistency. All our services look and feel and behave the same way. They are maintainable. As I said, common components change more often than we would like them to. We have already changed how we do logging multiple times. How we collect metrics from StatsD to Prometheus, and we eventually want to go to OpenTelemetry. Resiliency needs to be baked in for a production grade application. You don't want hundreds and hundreds of developers to have to learn it the hard way, right? Observability we talked a lot about, and testability. Testability is huge. If your application is 100% testable through code, that's amazing. And I like to believe most of our services are well tested and testable. That's it. A big thank you to the Go community. All this work is based on a lot of these amazing packages. So thank you to all the all the contributors to these packages. And thank you so much for your time. I'm done. Back to you guys.
And thanks, Arish. So I always love hearing these kind of stories and seeing all of the companies that are using Go and how they're using it and things like that. And Johnny's with me here with, you know, how long we've been a part of this community to see like where everybody's like, what is Go? And now we get to see, you know, all of these, you know, household name companies using it and seeing the interesting things they're using it for. Some of my favorite things are use cases where you wouldn't think that Go would be a good use case.
Indeed, and we hear more and more stories.
And we've got sort of the typical internet problem. You're on mute. Johnny.
You know.
And see, and we fired Aaron. We should have fired you.
Aaron, should have fired me. Yeah, I'm gonna self-fire. I'm just gonna. No, actually, yeah, Aaron. Speaking of Aaron, yeah, we had to fire him because you know his shirt was just too loud.
It was, and I mean the corny jokes. It just pushed it over. We couldn't do it anymore.
We just couldn't. Yeah, we had to part ways.
And then you know the hostility. You know, about Vim and being able to quit.
We just couldn't take it.
I don't know whether I can sit at the same desk as somebody who doesn't like Vim.
Yeah, maybe we'll change our minds tomorrow. Who knows? We'll see. So listen up. We've got a rebroadcast of everything you've seen here today, where we will have everything sort of played back to you, basically from about 4 p.m. East Pacific.
4:30.
4:30 Pacific, and 7:30 Eastern. Time zones are hard, and
yeah, our time is hard.
Time is hard.
If you've not seen the site, your calendrical fallacy is. Good luck trying to spell. Like I don't know how to spell calendrical, but that's what it is. If you Google it, it will correct you, and then go to that site. It goes through all of these assumptions we make about time,
like having 24 hours in a day.
Yeah.
Yeah, can you imagine? That's not a...
Or that there's only 1 a.m.
1 a.m.
Except for when you set back times, and then if you needed to do something at which 1 a.m. or is it both? And if you like things like that, or you just, I mean, that is the Debbie Downer site, right? Like you read that site and I give up. I give up.
It's 1 a.m. Did you know that it's actually not 1 a.m.?
Even though day's ending, there's lots of ways people can still communicate.
Indeed, including Gopher Town, right? And you can go over to Gopher Town and still people, you know, have their cameras on and hopefully seeing top half only kind of situation. And also there's Discord. You can obviously all of you have been sort of very active throughout the day. And the Dad Jokes channel is still very strong. The force is strong in there, I tell you. And yeah, what else we got going on? Yeah, we will be back tomorrow morning, 7:55 PST. And
I mean, if you're sick of hearing our voices, you could wait till 8. I suppose. You could watch the talk.
Yeah, you could exactly. But I'd highly recommend you come listen to us. Yeah, it's a good time. And 10:55 Eastern, by the way. Yeah, we had some amazing talks today, didn't we?
We did.
Man, like I think we keep doing better and better every year. Oh, I don't know. I think we're excellent every year. I'm gonna pat ourselves on the back for this one. I think we do a good job every year with the talks and the speakers. We had an excellent.
I mean, it's easy when there's so many talented people in the community.
That's why. Yeah, these folks, basically say, "Hey, I want to give a talk," and we're like, "Oh man, like." Sometimes it's hard making the decision on which talks we're gonna pick and which ones.
That's the hardest thing is to see like after all of the talks have been selected, all the good talks that there just wasn't.
We just have to leave on the cutting room
floor. I
mean,
unless we just want to do a 24/7 Go conference, we'll all just live in a convention center. What do you think that'll cost? Do we have any sponsors interested in buying us a convention center that we could just use every day?
Every day. I mean, as long as it's warmer than this place, I'll try it. We have special thanks to Mark Bates for organizing and running the Lightning Talks. As always, special thanks to the Go team for coming onto a Go time and sharing their experience and sharing what is and isn't in the future of Go. Again, thanks to the Go Time panelists, my fellow panelists, and unfortunately I couldn't be there with you today. You know, stuck with these guys all day.
It would have been a better time.
And obviously, thanks to Matt Ryer for also handling things over there, and obviously the Change Lives team for making all that happen, and for our production team back here, man, like we couldn't do this without them, could we?
Yeah, we couldn't. You know, thank you to, like, you see all of us here, and there was some questions in Discord about where these desks were in relation to each other. It's a big room. But we're staring at where the speakers are, so we could actually have a staring contest with the speakers. So that's
might be a little awkward.
Actually, I mean, we do a zoom out on the way out. You'll probably see where we are in relation to it. Oh, there we go. They're panning it now. That's what the studio looks like.
There you go. There you go.
And so, yeah, thank you to everybody who's behind the scenes. Maybe at some point we'll snap some photos or a little video of all the people who are behind the glass back here. Also, huge thank you to all of the GopherCon planning team that spent all year planning this for it to come together, what you see today, and then replanning it when we decided to go online. So huge shout out to them. Well,
and obviously, you know, we have to thank our sponsors, right? Again, this takes money to do, and we couldn't make this happen without our sponsors, especially Bread. You know, these if you're into payments and you do Go and you want to do Go payments at Bread.
We're seeing more and more like finance companies using Go, and that's like, I feel like that's like a real inflection point of language adoption. It's like when banks and health companies and things like that start adopting it.
Exactly.
So yeah, thanks again to everybody who's made this possible. We look forward to seeing you all again tomorrow morning at 7:55 Pacific for our final day. And, you know, most of all, thanks to the audience for watching. We'll see you tomorrow.
See you tomorrow.